Hello there, Anthony Sequeira here, and I'm so glad that you are joining me for this playlist where we are going to teach you the basics of Python. That's right, you're sick of hearing it probably, that we should all learn the basics of Python. That's how ubiquitous Python is becoming in the information technology industry. More and more there is a push for automation, and Python programming, or scripting as we often like to call it, is such a key element in that automation. So if you are interested in learning the fundamentals of Python programming, you're in the right place. And I know what you're thinking, wouldn't it be nice if after we do all this hard work to learn the basics of Python programming, wouldn't it be nice if we could prove this to potential employers? And that's exactly what we're going to do, because this entire playlist is going to be mapped around a certification. Yes, we're going to be teaching you to pass the Python Institute certification entitled PCEP. That's right, the PCEP, the Certified Entry-Level Python Programmer. So I am going to teach you everything you need to know to pass this exam with ease. If you come to the testing page here, notice there is a link for the syllabus, and you're going to be noticing that I follow this syllabus and teach you every element of this syllabus as we move throughout this content, so that you'll have no problem whatsoever in your certification exam. So this playlist will serve two purposes. It will make sure that you can engage in entry-level Python programming activities, and it's also going to ensure that you're completely ready for our entry-level programming exam for Python to really boost that resume or CV. Well, let's get started. Let's jump over to our next video where you know what we're going to do. We're going to cover the fundamental terms and definitions that we are going to be using in Python. Let's get started. Now, I know you're excited to learn Python, and we are so tempted to just run up and get Python installed and start coding. But before we do that, let's just cover some key terms that you really should know. Not just according to our entry-level Python programming exam objectives for the exam that we're studying for, but I think it's a really good idea that we know some of these key terms. The first thing that I want to discuss with you is this whole concept of a programming language. You see, there's lots of different language types out there. For example, we speak in what we call natural language. Here's an example of two folks speaking in Spanish. So they're going to be using this natural language to communicate with each other, and that natural language is going to evolve over time and change over time. If you look at the English language, we have the new word skibbity. Sure. So these natural languages are going to evolve over time, and guess what? That's going to be the same with our programming languages. Now, a natural language is so easy for us when it is our native natural language, but the polar opposite of a natural language for us would be a machine language. Yeah, this is a language that a computer is going to understand and speak. And here we can see an example of hexadecimal machine language, and that doesn't seem very friendly at all. No, that is not friendly at all. In fact, suddenly I remember a great scene from the excellent television series Halt and Catch Fire, where two of the engineers there are reverse engineering code, and they are starting with the machine language. Yeah, so this is not friendly at all. So what we want is, we want something like Python. Yeah, we want a programming language, and we specifically call that a high-level programming language. And it is almost just like our natural language. Yeah, if we look at this Python 3 example, we can see that we want to print hello world. And sure enough, that's what'll happen. On the screen, we will have hello world printed, high-level programming language that is so easy to understand and so similar to the natural language that we use every single day. We are going to be studying the high-level programming language of Python 3. Notice it is Python 3, not Python 2. Python 2 is an incompatible previous version of Python that we will not be learning in this course. Now, something else that we need to understand from a key term standpoint here is the term lexis. What exactly is a lexis? Well, it is the vocabulary of a language. So we had Spanish as a natural language in this example, and a key piece of vocabulary there we saw was hablar, the verb to speak, hablar. So, and forgive my pronunciation, by the way. But anyways, yeah, a lexis is just that. It's the vocabulary that a language is going to use. And we're going to see keywords and mathematical operators and string indications and all this rich vocabulary that we have inside of Python 3. Yeah, this is called our lexis, and it's what we're going to be working with. Something else, of course, a language is going to have is syntax. Yeah, this is the structure that we must follow. On the top example here is Python 2. Yeah, in Python 2 code, we would say print, and then we would put in single or double quotes, hello world as an example. That would work fine in the syntax of Python 2. But sure enough, below it, I give you an example of Python 3 syntax. Notice with Python 3, we need to have opening and closing parens around the string we want to print, in addition to the double or single quotes. So print and then open paren, quote, hello world, close that quote, close that paren, and there is your Python 3 syntax for printing. Now think about it. A language is also going to have semantics. Yeah, this is really giving us the meaning of our code. So, for example, in Python, if we say x equals 10 plus 5, the semantic meaning of arranging the characters and letters in this manner is going to mean that we are creating a variable x and we are setting that variable equal to 10 plus 5. So we're going to have different semantics that we will study together inside of Python that actually gives meaning to our code and allows the program to accomplish wonderful things for us. Now, something else that I need you to realize in this section of our course is that there are two basic categorizations of programming languages. In fact, there's many different ways to categorize our programming languages, but one of the ways we can categorize them is the programming language one that needs to be compiled, or is it one that needs to be interpreted? Let's take a look at this. A classic example of a programming language that needs to be compiled is C++. So what happens is the coder sits down and writes their C++ code, and then this code needs to be compiled into an executable file that is then delivered to the end users. Wow, interesting. Notice this is very different from code that is interpreted. And sure enough, Python is code that is interpreted. It needs an interpreter in order to run it. So we have our Python language, we have our syntax and our semantics, we use the print command, and the interpreter goes ahead and runs this language and does on our computer what we need it to do. So C++, great example of a compiled programming language. And then, of course, we have our interpreted language, and that would be Python as a great example of that. So immediately we might think, well, wait a minute, there must be advantages and disadvantages to these approaches. Well, sure, compiled programming languages, they typically will run faster. That's right, they'll typically run faster. And the end user only needs the end result of the compilation. So if we're compiling into an exe file for Windows, for example, that's all the end user is going to need. And another nice feature of compiled language is it is stored as machine language. So if you've got all kinds of nifty little tricks and secrets that you've got inside of your code, it's going to be much tougher for someone to look at your high-level code. Yeah, they're only going to see machine language, and they'd have to do a tremendous amount of reverse engineering to actually see your code. Now, compiled languages like C++ certainly have their disadvantages, like the amount of time you'll spend compiling them. Yeah, think about making changes to your code. Oh my gosh, we write the code, we compile, we test, and then we realize, oh, we got to make some changes. We make those changes, we have to compile again, and then test again. And there's probably more changes we have to make. So more compiling has to be done. The other challenge with our compiled languages is we have to compile for each hardware platform we need to support. Yikes. So we might be compiling our code many different times for many different platforms. An interpreted environment like Python's environment is certainly going to have its advantages, and one that we absolutely love, and you'll see it in the very next video, is we can run our code immediately. Yeah, we don't have to pause for the compilation of the code, and we can write once for many different hardware platforms. Now, Python and other interpreted programming language certainly have their disadvantages. We already mentioned they're not going to be as fast when they execute typically, and they are stored as the high-level language. So someone can easily be very, eavesdroppy. They can be very, they can scrutinize our code. Yeah, they can easily look at our code and see what our code is doing. And I suppose it's a disadvantage that everyone needs an interpreter. Yeah, when we're writing our code, we need an interpreter. When we ship our code out to the end users, they need the interpreter. The great news is the Python 3 interpreter is totally free and is even pre-installed on many operating system environments. So a lot of times these disadvantages, of course, they're going to be very easy for us to overcome. Well, now that we've gotten some of these key terms out of the way, I'm sure you're excited, just as I am, to go out there and get Python and execute your first Python program. Let's get to course, and it is time for us to go up and get our free Python. That's right. we are going to go to python.org. And here at python.org, notice there is a prominent downloads area. Python is free for us, so it's not true what they say, that nothing in life is free. Python is free. And notice there's going to be platform support for whatever you're working with. And I don't know about you, but I went ahead and put Python everywhere on every machine I tend to work on. My Mac, my Windows machine, my Linux box. That way you can always practice. Now notice there was some auto detection going on here, and it says, okay, you're on Windows, so here's a nice happy button to help you out. Download for Windows, and notice it's Python 3.13.3. Remember, we are not going to be working with the legacy Python 2, which is not compatible with Python 3. So I'm going to go ahead and click this button, and we see that we just had a download take place to my downloads folder. I'm going to click on Open File, and we are going to install Python. So what does it ask us here? It says, all right, select Install now to install Python with default settings, or choose Customize to enable or disable features. We want to go ahead and see the customization, so we're going to choose that path. I want to add Python exe to my path so I can run Python more easily at the command line. We'll be showing you more about that later on. Use admin privileges when installing Python sounds good to me. And remember, I'm going to show you the customized installation options here. So yes, I want the documentation files. I want pip, which is a tool that we can use to download and install other Python packages. We want tkinter and the idle development environment for sure, a test suite, the PyLauncher, and I would want to install this for all users on this Windows machine. So some nice options there. They're all selected. That's what we want. We're going to choose next. There's some more advanced options like associating files with Python. Yes, this is great. We have the PyLauncher. We can just accept the defaults here. Notice where Python is being installed. It's going to go into my app data local programs Python area. We'll accept the defaults here. I don't need it installed for all users on this machine, so I'll leave that unchecked. And all that's left for us to do is approve the permissions here of user account control and say, do your thing, install Python. So it's wonderful that we're getting our Python that we're going to be working with for free in this class. And notice it comes with something called idle. This is the integrated development and learning environment. Learning is the key word there. So Python is going to give us a nice integrated development and learning environment that we can use as we are moving throughout this course. So Python is almost done installing here. Great. We're going to close up the installation window, and now we can start using Python throughout this course. Now, one thing I'm going to do is I'm going to find the Python folder that it created here, and notice there is our integrated development and learning environment, and I'm going to go ahead and create a shortcut to that out here on my desktop. Yeah, for sure, I want a shortcut to that on the desktop so I can get to it easily. I want to make sure, it's been a while since I've done that in Windows. I want to make sure I just didn't move that object. Yeah, there we go. Okay, great. So I do want a shortcut of that out there on the desktop, and I'm going to double click that idle environment, and it is going to launch on our desktop. And look at this, we can begin experimenting with Python right away. You gotta love it. One of the things I'm gonna do though is go to the file, let's see, it's probably under edit. Gosh, I'm used to doing this on my Mac. What we're looking for here is, there we go. No, not the, configure idle under options. This will be under the file menu in the Mac, But find your configuration settings, because one of the things you might have to do if you're like me is you might have to really blow up the font so that your eyes can see stuff. And of course, I'm doing this so that you can see very easily what is happening as I do demonstrations of technologies here in Python. So you probably know what's going to happen now. We have to do a hello world program. Of course we do, because it's good luck to create your hello world program. So I'm going to type in print. And the first thing we notice is, look at that, print gets a pretty kind of purple color. So notice right away, the integrated development and learning environment of Python is trying to help us as we code with what we call colorization of our code. And we'll be talking more about this as we go. You might remember that we do an open parens with our print function. And notice we're getting help here from the integrated development and learning environment. And from now on, I'll just call it idle. Idle is helping us, and it's telling us things we can do, arguments we can make with the print function. We'll be covering the print function and these arguments in detail later on in our course. But what we're going to do is just do our straight quotes, and we're going to say, hello world. And we are going to close that straight quotes and close the parentheses. And there we go. So we have print, the function called print, and then for the print function's kind of instructions, if you will, we're saying go ahead and print the string hello world. So if we hit enter on the keyboard, look at that, it runs and it does just what we asked it to, Python. It prints hello world to our screen. You gotta love it. Now, before you leave your idle environment here, I'd like you to practice with errors. Yeah, let's do some intentional errors. So the first thing I'll do, and you could see this happening to someone, is I'll do print and then my quotes, and I'll say hello world. And notice what I'm doing. I am intentionally forgetting the open and close parentheses. This would work if I was in Python version 2, but sure enough, inside Python 3, we're going to get a syntax error. And notice the accuracy of this. It's like, hey, you are missing parentheses in your call to print. Did you mean to do that? So very, very explicit syntax error messaging. Our error messaging isn't always great like that. For instance, watch this. I'm going to say print hello world, and this time I'm going to forget the quotes. And what is the syntax error? It's just saying, look, invalid syntax. Perhaps you forgot a comma? No, good try, Python. We forgot the quotes. Yeah. And let's just do it right one more time, and let's do it in a slightly different way. Remember, I can use single quotes here as well to get the job done. So there's our hello world application with the single quotes inside the parentheses for the print function, and that works just great. Now, when we are ready to quit, we can, watch this, I'm going to type quit and it'll say, wait a minute, you need to use the quit function or Control D. So, all right, great. We're going to use the quit function, and notice we don't have to specify anything inside the function there. We just say quit, and it says, are you sure you want to kill your running program? And we say, we sure are. And an easy way for us to quit using the quit function. So there you go, folks. You're going to want a shortcut to the idle environment on your desktop, I'm sure, like me, so that you can practice your Python at a moment's notice. Thanks so much for joining me, and I hope you're excited for the next video where we're going to take a look at some of the main fundamental structural components of Python code per our certification exam objectives. Welcome to part 4 of our journey in the Certified Entry-Level Python Programmer course, and it is time for us to talk about a couple of topics regarding the logic and the structure that we are going to be using in Python. Yeah, Python's going to be made up of, as we'll see, our Python code of keywords, and the whole meaning of our Python programs are going to be made possible thanks to instructions, as we'll talk about. And then we have indentation that we must use at times in Python. So we'll discuss that, of course. And finally, we'll be using comments in our Python code like we would use comments in other programming languages. So when we are working with Python, there's a bunch of words that we're going to be learning, and these words are reserved, meaning we can't use them for other purposes in Python. For example, you can see the word if. Look over in the 4th column. Actually, it's the 5th column on the right. And if you look at the 3rd entry down, it's the if keyword. This is reserved. I can't create a variable, for example, in Python and name it if, because this is a reserved keyword and it's going to be used, you'll see it later on in this video, we use it in a famous if statement. So keywords are reserved. And the great news is when you are working with Python, these keywords will be colored in orange. So the colorization reminds us of the reserved keywords, and it helps us write great code, that colorization, as we'll see again and again and again in our videos. Now, remember, Python is constructed to carry out our instructions. That's what's really the magic behind Python. So when we go in and we say x equals 10, Python knows that it is to create a variable named x and set that variable to the integer value of 10. When we say print and then our parentheses and quotes hello world, that is understood by Python as us calling the print function and it printing whatever string we provide it, in this case, hello world. Yeah, these instructions that Python is carrying out for us is really the magic of Python. Now, one of the things that some programming language folks dislike about Python is it is mandatory that we do indentation in places. You see, other programming languages will use like curly braces in order to keep blocks of code together, and the people that use those programming languages are really biased and they love that, but we must get used to indentation inside of our Python because it is going to be critical for us. And wow, isn't that weird how some of the letters ran together? I think that has to do with me creating this slideshow on a Mac and then running it on a Windows machine. It did some font substitution and stuff got a little crazy there. That's all right, though. We can still read it. So anyways, notice x equals -4 is us setting a variable of x to -4, and then we have our if statement. If x is greater than 0, then we need to do something. Print positive number, else print negative number. Notice that the indenting must take place here. Let me prove that to you. Let's go over to Python, why don't we? And there it is. Here's our Python idle environment. And let's set, as you can see here, we have set x to a -4, and we should get the negative number printed out as a result of this simple if-else statements that we are doing inside of Python. So I'm going to go up and say, run this module, and what happens? Sure enough, it runs and it reports we have a negative number. So that works beautifully. Now, what I'm going to do is go in and get rid of the indentation. We're going to do a file save. We are going to go up to run and run this module, and notice we have an error. Yeah, expected an indented block after the if statement. So indenting here is mandatory. Now, how should we indent? Well, we're going to be talking about best practices when it comes to the Python code, and the best practices tell us we should do 4 spaces. Yeah, we should be doing 4 spaces. By the way, I have to stop the running of this program right now. So one way I could do that is just to close the file. Let me now reopen that file. And that was indentation. There we go. So I'm going to go in and put in 1, 2, 3, 4. The recommended way to do it. That is 4 spaces. 1, 2, 3, 4. Now, you can use tabs. So if you wanted to, I could go in and just hit tab on the keyboard and then tab on the keyboard. Notice the 4 spaces in the tab are the exact amount of space. You could use like 2 spaces if you wanted to, and that would work just fine. You could even use 1 space if you wanted to, and that would work just fine. Python tells us, look, whatever you're going to do for the indenting, whether it's 1 space to 4 spaces or a tab, do it consistently throughout the entire module that you are building. So yeah, we're going to want to make sure we are consistent with this. I do the best practice of my 1, 2, 3, 4 spaces and 1, 2, 3, 4 spaces. So we will save this now that it is all fixed up and properly indented. Now, the other thing that we need to be aware of when it comes to Python, in addition to this requirement of our indenting, is we need to remember we can use comments inside of our code. And notice everything in red here is a comment, and it is none other than the hashtag. Yeah, the pound sign, as some of us call it, that make this magic happen. Let me close that window and bring up a comments example that I have, and look at how great this is. Anytime we use the hashtag, anything following that on that line gets red colorization because it is a comment and it is ignored by Python. So Python comes in here and sees x equals 10, and then it sees print x. So if I execute this, if we run this module, sure enough, look what happens. It just prints the number 10. Yeah, because that's all there is for it to do. X is equal to 10, and then print X, which is 10. So all of this stuff is just comments. Notice this is an example of a comment that runs over multiple lines. Note we need a pound sign on every line. Also, notice that you don't have to start the line with the comment. So there's x equals 10, which is processed by Python. And then I have the pound, a variable named x set to the value of 10. So we can do the comment right there as well. Now notice comments are going to be great to describe what is happening in your code, and comments are also great because you can have something in your code that's commented out that you can then uncomment. Yeah, look at that. So now I've quickly set x to 20. If I do a file save here, and then I run this module, now the program runs and outputs the value of 20. So comments are fun that way too. You can have something commented out in your code so that it's easy for you to implement that. Notice you will develop your own kind of best practices, like do you do a space after your hashtag or not? As you can see, I like to do spaces. Some people do not. I would recommend, as you develop your best practices, always think about consistency. Yeah, so here I was using the space after my hashtag, and notice I did that consistently, so it gives the code a more clean and consistent look. Something else to think about when it comes to comments is we're always going to try and make our code as self-commenting as possible. So for example, instead of this comment right here saying what this is doing, I'm going to get rid of that and I'll rewrite my code so that it says my variable 1, for example, is equal to 10. Yeah, and notice that makes much more sense of what is going on there. And so now I'll just do that substitution. And yeah, I don't need a comment anymore for that line because it's self-commenting. My variable 1 is equal to 10. Yeah, so always try and make your code as self-commenting as possible, but don't worry about using comments to explain stuff. That is, of course, a best practice when you are working in Python. Now, before we wrap up here, notice we have covered our objectives: keywords, instructions, indentation, and comments. We've covered those just as we need to, but I did want to just wrap up by pointing out something to you that we did inside of this video that I haven't introduced you to yet, and that is the concept of creating these scripts inside of your idle environment. So you can come in here and you can say File, New File, and I will go ahead and immediately save this. I'll just save mine into my Downloads folder and I'll call it Demo. And this is going to get a .py extension so that Python can run it. And notice inside this demo.py file, you can go ahead and start to practice with your Python. So one of the things we learned, and we'll be getting into variables in much greater depth later on, but one thing we saw is we can have like a my variable 1 equals something. And then of course we can print that my variable 1. Yeah, we can print that value. And we don't need the quotes when we are printing a variable. So now I can file, save this thing. I can then go up to the run and I can say, check the module, see if there's any errors. And notice it just returns me here to the run window. So clearly there were no errors in that code. And now I can get back, do my file, save. I had already done that. I can now run the module. And what does the module do? Well, of course, it prints out the value of 10. So great stuff here. We can begin creating these .py files to store and run our practice code. And remember, under the Run menu, you can do a check module to see if you have any errors. And once you've confirmed you do not, you can go ahead and run your module in order to see it run inside the idle shell. Well, thank you so much for joining me in this episode where, as you know, we took a detailed look here at 4 major aspects of the logic and structure of Python 3. We talked keywords, we talked instructions, the magic of Python really, and our mandatory indentation we will need to do at times. And finally, we talked about using the hashtag and comments inside of our Python code. Thanks so much for joining me. Can't wait. And we are ready to talk about Python literals. And you might be thinking, Anthony, what in the world is a Python literal? I've never heard of such a thing. And I want you to just use this simple explanation. It's the opposite of a variable. Yeah, we've all heard of variables, and a variable can contain just that, some varied quantity or value. Literals are the exact opposite. So what is a great example of a literal inside of Python? Well, it's an integer. So if we tell Python that something has a value of 1024, Python realizes this is 1024 and stores that value as an integer. Another example of an integer would be a negative integer. Yeah, so Python understands negative 200. As a matter of fact, in your Python code, you could do a positive sign in front of your positive integers if you wanted to. Of course, most of us do not bother with that. Now, what if you had a number like 1,111,111? Notice this is tricky when you're typing it in because, and pay attention to this fact, folks, there's no way we can use commas in our integers inside of Python. Yeah, this is not going to be permitted. So around 3.6 of Python, they invented a underscore approach that we can use to improve readability. So if you want to enter a very large number like 1,111,111 and you want a substitute for commas, you can use underscores now. And again, that is a 3.6 version of Python invention. So that's one of the latest inventions we're going to be looking at together in this course. Pretty nifty that you can do that if you are so interested. So integers, yeah, they're wonderful. We're accustomed to them. They work great. And guess what another literal is in Python? Well, sure, it's a floating point number. So when we have a decimal portion, we are going to represent that with the period, and 12.5 or 12.5 would be a great example of a floating point number. What's another example? Well, 4.0, although realize that is different from the integer 4. So if you meant the integer 4, go ahead and do it that way. It will be stored as an integer instead of a floating point. How about negative floating point numbers? Yeah, no problem. So we could have negative 120.5 as an example. What's another type of literal inside of Python? Well, it's the Boolean values of true and false. That's right. So things can evaluate to true or false. We can set things to true or false, and this is another literal. Now, what's interesting about Booleans is behind the scenes, they have integer values, specifically true is 1 and false is 0. There's actually a fun way we can prove this in Python. Let's do it together now. I'm going to fire up my idle environment and I'm going to say print false is greater than true. So I am saying here, print the result of the evaluation, false is greater than true. What am I saying here? I'm saying 0 is greater than 1. And of course, Python is going to correct us and say, sorry, that evaluates to false. Yeah, false is not greater than true. 0 is not greater than 1. So pretty neat test to see that Python is actually looking at true and false as 0 and 1 values. Pretty nifty. Well, what other types of literals do we have? Well, there's our wonderful string types. So here is an example of a string, and we know that Python is going to see this as a string because of those quotes around it. How about this example? Yeah, we put quotes around 2, and it is the string of 2. Yeah, you could have fun with this in Python as well. I can say print and say 2, and that is printing the string of 2. But then when I say print 2, this is printing the integer of 2. Yeah, they look identical, but of course, the Python programming interpreter is treating these very differently. What's another example of a string? Well, how about this one? We want to print out, I love Monty Python. Python, by the way, is taking its name from none other than Monty Python. The creator of Python was a huge fan of the British comedy troupe Monty Python. So I love Monty Python. Notice what we did to make this possible. I used single quotes around the string so that I could use the double quotes within the string. Now, if you didn't want to do that for whatever reason, let's say you wanted to stick with the double quotes, you could do I love and then backslash double quote Monty Python backslash double quote. So what we're doing there is we're using what's called an escape character. And the escape character says treat what follows differently than normal. And in this case, it is to treat it just as a part of the string. So notice they thought of everything in Python for us, right? They knew we might want to have quotes in a string, so we're going to have multiple ways in which we can accomplish that inside of Python. Finally, there's the literal of none. That is right. Python has a reserved keyword of none that it will apply when there is no value. Please note, this doesn't equal 0. No. This just means none. There is no value. And one of the things that we can do, of course, is we could always test for this. We could say, is a variable consisting of none? Meaning, does the variable have no value whatsoever? Now, there are some other literals like collections. We have lists and we have definitions and kinds of collections that we can have in Python, but we'll go ahead and deal with those where appropriate, like dictionaries. We'll deal with those where appropriate inside of the course. So literals in Python, no problem at all for us. And we need to follow this up in the very next video with the many ways that we can express literals inside of Python. This includes things like hexadecimal or binary notation or even scientific notation. We'll show you here, and it is time to tackle how Python can easily deal with number systems. That's right. So to have fun with this, I have set up for us a nice little Python script, and it is called binary.py, and you can create a similar thing for yourself, and I recommend that you play with this. We're going to see a couple of new things here inside of Python that you're going to want to play with. First things first, what do we do in this little module in order to demonstrate how Python can easily handle binary? Well, we are going to declare a variable here called decimal_value. Later on, you'll see why I name it like that, by the way. We're going to talk naming conventions in an upcoming video. And we're also, in the very next video, going to dig deep into variables. But just trust me, we're setting up a variable here called decimal_value. And we are introducing you to a new function called the input function. Yeah, this is the opposite of print. It's where we get input from an end user. So we can see input, enter decimal value. So what's going to happen is this program is going to run and it's going to say to the user, enter a decimal value, and it's going to accept that value. Now, the only problem is, as you'll learn when we go into detail with you later on in a video on the input function, the unfortunate thing is anything the user inputs is going to be stored as a string. So what do? Well, I convert that to an integer. Yeah, so the decimal value is going to be entered by the user of this program, and this is going to be converted from a string into an integer. Then what do we do with the decimal value we collected? Well, I create a new variable called binary_value, and I take the decimal value and I have Python convert it to binary. And then I print the binary representation is, and then we print that binary value. Notice we're printing this string, and then we're printing the variable value for binary value. Notice how incredibly simple this Python program is. And again, I would like you to screenshot it, or if you're really brave, go ahead and try and create something similar yourself. Remember now, before we run this, I can check it for any problems. So remember, I can do a run check module. And if you were just returned to this idle shell with no kind of error messaging or anything, then you are off and running. So let's go ahead and run this thing. I'm going to choose run module, and sure enough, it's going to say, all right, enter your decimal value. I am going to enter 192, and what does it do? It says the binary representation is 0b. Yes, that's the prefix that Python is going to use to show us it is using the binary number system. So what is 192 in binary? It's 11000000. And you might have already known that if you are a student of networking and you've studied IP addressing. As a matter of fact, let's think about it. This program that we just wrote, it is a nice little program to automatically help students with binary representations of numbers in decimal. By the way, there is a little trick you can do with all of these little conversion programs I'm going to present you with in this section, and that is you can actually trim off the 0b prefix. Yeah, you can trim that prefix off in the print output. Let me show you how to do that. So I'm going to go back over to our binary file here, and I'm going to say binary value and then square brackets 2 colon and then square brackets. So that's how you can actually trim the binary representation off of that value. Let's go ahead and do a file save here. And let me go ahead and run the module again. So notice, what is our decimal value? I'll go ahead and say 172 this time, and I'll hit enter, and it says the binary representation is 10101100, and notice it did indeed trim off the 0b that is our indicator that the result is in binary. Keep in mind, you could use this to tell Python that you're giving it a number from a certain numbering system. So I could say x equals 0b. It doesn't matter if it's uppercase or lowercase. And then you could say, you know, whatever it is, 1100 1101. And Python says, okay, no problem. I understand that x is going to be the number that's given to me for the variable x is in binary. Yep, 0b gets the job done, that prefix. Well, a fun way to see that, yes, Python can work with binary just fine. As a matter of fact, it can work with the octal numbering system just fine. Yeah, octals based on the 8, right? The power of 8. So yeah, I don't work with octal ever, but it's nice to know that this Python supports it just fine. Look at what we did. Same thing. Decimal underscore value. We are going to get a decimal value from our user, and we're going to convert it to an integer. And then we're going to say, we're going to provide the octal value of that. Yeah, we just take our decimal value and we run it through the octal function. And then we're going to print the octal representation is and that value. So let me go ahead and run this module. And it sure enough says, give us a decimal value. I'm going to say, how about 255? And what is that in octal? It's 377. Notice the prefix for the octal numbering system is 0 and then a lowercase o for octal. Guess what? You probably already guessed it. Sure, Python can work with hexadecimal number systems just fine as well. So I can go in and I can say decimal value, go ahead and give me one. We're going to make sure it's an integer. And then I can say, let's create a hex value out of that decimal value by using the hex function. If I go ahead and run this module, we will enter a decimal value. How about 101? And sure enough, the octal, it's not the octal representation, it's the hex representation. So I've got a little modifying to do in our program. Yeah, no problem. We just caught a bug. No issue at all. A logical bug, right? Not a syntax error. But anyways, we can see 0x is the prefix, and we can see it's 65 in hex. That is 101 in hex. All right, well, we don't want any errors anywhere in our program, so let's pull up that hex little Python script, and what we need to say is the hex representation, and we'll do a file save on that. So notice, Python is going to be able to work with these various numbering systems just fine. Binary, octal, and hexadecimal. And one other thing you should know, the Python programming interpreter will also be able to use scientific notation just fine as well. So I might say x equals, and how scientific notation works is I might say 3 exponent, you can do capital E or lowercase e. I can say 3 to the exponent of, let's say 4. And what this is of course 3 times 10 raised to the 4th power. Yeah, so I'm doing kind of a small number like this so that when I then say print the value of x for me, it will print it out longhand. Yeah, so 3 with an exponent of 4, 3 times 10 raised to the 4th power, that is 30,000. So yes, the Python interpreter is going to be able to handle scientific notation, no problem at all. Notice, interestingly, that it goes ahead and takes whatever you gave in scientific notation and it makes that a float. Yeah, so it is a floating point number that is returned. And of course, the whole thing with scientific notation is to work with really big numbers, right? You know, you might see like 12.3 E 25, for example. Yeah, that is a huge number. And if we go to print that number, it will say, okay, that's a really, really big number. So we're going to leave that in the scientific notation when we present it to you, the end user. So numbering systems, sure, plenty of them are Well, as promised, let's talk about variables. Yeah, we had literals in Python, and now we have variables where the value can change, as we're going to see. So variables are a key part of Python, as you've already seen, and the first thing that we need to understand is there are some naming rules when it comes to variables in Python. We need to begin our variable names a very special way. Now, variable names can contain uppercase and lowercase letters as well as digits and the underscore character. But as I said, variable names must begin with a letter or the underscore character. Yeah, so we'll give some examples here in a moment of variable names that would not be acceptable by Python. And sure enough, it would be, an example would be a variable name that begins with a digit. Also, variable names are case sensitive. I'll give you an example of this here momentarily, but this is very important for us to remember. So if I have a variable named VAR, all lowercase, this is completely different from VAR, all uppercase. And we have to watch out for those keywords that are used in Python. Now, what's pretty funny about this is, thanks to the case sensitivity, you actually could get away with using keywords as variable names, but my goodness, I would never want to do this. Yeah, think about the if keyword. We know this is going to be very, very important inside of Python for our programmatic logic. The if statement is so critical to us. And if I come in here and try and set a variable named if equal to 100, sure enough, I'll get an error. And that error is because if is a reserved keyword, as we have discussed in a previous lesson. Now, if I were to say if equals 100, notice that Python has no problem with that. Would I ever do such a thing? Of course not. I'm going to respect the fact that if is a reserved keyword, and I am not going to create a variable that is named that way. Now, let's see some valid examples, therefore, of variable names. How about my variable? Sure, that would work. How about T1020? Sure, that would work. How about exchange underscore rate? Yeah, no problem. How about underscore test? How about simply X? Sure, these are all variable names that will work for us in Python. I don't like any of them though, because not a single one of these, maybe except for the last one, really honors some best practices that we'll discuss in our next video when it comes to doing our naming conventions in Python. So I don't even like X because, of course, it's not self-commenting. It's just too generic as to what it might mean. But suffice it to say, all of these 5 examples we see before us, they're all perfectly valid. Now, what about invalid? Well, how about 40x? Yeah, can't do that. Can't begin with a number. How about exclamation my var? Nope, can't do that. Can't begin with that exclamation point. Nope. How about exchange space rate? No, we can't do that. We can't have a space in the variable name. So these are examples that would get us into trouble in our Python code. Now, something else to realize about Python and your variables is that we have a system that's called implicit declaration, meaning we just pop up and say, hey, I've got a variable called my underscore variable, and its value is 10. Notice we don't have to explicitly declare the my underscore variable. We can just immediately create that variable and set it equal to something. notice the something is going to be dictated by what we set the variable equal to. Here we can see we set it to the integer of 10. So sure enough, the my variable will contain an integer value of 10. When we print that, it will be printed as that integer value of 10. By the way, if I pop up and say my underscore variable equals quote 10 end quote, now of course it looks the same, but we're actually storing a string in the variable my underscore variable. So notice inside of Python, we have what's called implicit variable declaration, as I said, meaning we can create them at any point and their contents will dictate the format, right? Sure, of how that value is stored. On the left, we see an integer. On the right, we see a string. Python doesn't care, and we don't have to go through some explicit declaration of, okay, we want you to create a variable called my underscore variable, and it's going to be used to eventually store an integer. No, we don't have to explicitly declare our variables inside of Python. Now, let's review with a quick point here. Why would we get an error if we did this? My underscore variable equals 10 and then print my underscore variable? Well, notice we have the case sensitivity issue here. And this also proves to us that while we can implicitly declare a variable, in order for Python to work with a variable, we must have implicitly declared it. Yeah. So why this is failing is the case sensitivity, but think really just of the fact that what Python is really saying with that print statement is, hey, there is no my underscore variable with this exact name. Yeah, the uppercase M and the uppercase V. Yeah, so poor Python can't do anything with a variable that has not been implicitly declared. Now, what about assigning new values to our variables? Well, that is no problem at all. Notice here, I have my underscore variable equals 10, and then I have my underscore variable equals my underscore variable plus 1. If we print the value of my variable, sure enough, we will see that it is printing 11. Yeah, I know this will look strange to a mathematician, by the way, right? We can never take a variable and say it equals that variable plus something else. That doesn't make sense from a mathematical standpoint. It just really goes to show you how in Python, a variable is like a box to store a value, and that can easily be changed. So we'll see where incrementing your variable in this manner is so popular. There's actually a special mathematical operator we have to shorthand that, as I'll show you in an upcoming video. But notice, yeah, assigning new values, no problem. Here's another example of that. My underscore variable, I could say, is equal to 100, but then I could say my underscore variable is equal to 200 plus 300. When I print this answer, what is it going to be? What's the variable going to be? It'll be 500. Yeah, the variable was initially set to an integer of 100, then it was set to 200 plus 300, so its latest value that will be printed is the number 500. Well, variables are very, very important, and you heard me mention that there is great naming conventions that we should take advantage of throughout all of Python, and there's other best practices I want you. Do you remember back in one of our earlier videos? In fact, it was our video on variables we mentioned it, but we've mentioned it several times, and that is there are recommended naming conventions that we should be using when we are programming in Python. Yeah, it's like using great grammar when we speak or write. It's something that we should consider doing. Now, the recommendations, kind of the style guide, if you will, for your Python programming is in something called PEP-8. Let's go take a look at that. Let's make sure you can find that document. By the way, something else that came out of that document that I've mentioned to you is indentation. How we should engage in indenting when it comes to our Python code. So sure enough, we're going to go to the documentation page. So I'm going to go to the documentation and notice there is this PEP index. PEP stands for Python Enhancement Proposals. And if you look in here, there is a document number 8, PEP-8, and it is the style guide for Python code. Notice one of the authors is the inventor of Python. Yeah, so wow, we should definitely give this document a look. And notice one of the things that will really help you is the table of contents. So I was talking to you about indenting, and I said there was a way to do that is recommended. And where would that be under? That would be under code layout indentation. So you can jump right there, and this is where I taught you the 4 spaces per indentation level, which is the Python best practice recommendation. Now, an area in this document that is called out for us in our exam objectives is naming conventions. Yeah, and you're going to see me helping you with the different naming conventions that you should use in your code. Now, before I give you an example of that, let's take a look at all the different ways we could name stuff in Python. You could use a single lowercase letter, an uppercase letter. You can use all lowercase. You can use lowercase with underscores. And you might recognize that one as one of our best practice naming conventions. Yes, we love that for function names and also variable names. So that's where that came up. You saw me using lowercase with underscores inside of our Python code for variables. There could be uppercase in use. You could have uppercase with underscores. You could have capitalized words, often referred to as camel case. You could have mixed case, capitalized words with underscores. And I believe this is the one that they call ugly in the style guide. Yeah, they literally say, try not to do this, it's ugly. There's single leading underscore, single trailing underscore, double leading underscore. I won't read them all. You get the idea. So lots of different naming conventions, and this documentation that we get from Python is going to help us with when we should use a particular style. So if we go back into this document under naming conventions, notice they're going to say what kind of convention you should use for constants. They're going to say what type of naming convention you should use for various cases. So again, I would use the table of contents, and function and variable names are an example, and function names should be lowercase with words separated by underscores as necessary to improve readability. Variable names follow the same convention as function names. So I'll be helping you with this as we move throughout our course, but I wanted you to be aware of where these best practices when it comes to style are listed, and notice you can look them up yourself with ease and check yourself on anything like comments. Are you doing comments in a recommended way? Code layout. This is a document that we should be visiting consistently to make our code easy to read, easy to understand, and again, just such a great idea to follow the best practices. Well, thanks for watching this video. I hope you are excited for our next video where we're going to begin to get into all of the many operators inside of Python that can be used to manipulate our data. Well, it's time now in our Certified Entry-Level Python Programmer course to take a look at some of the numeric operators that we have inside of Python. And these are going to have priority over one another, and I'm actually going to cover these in the order of their priority. So the least priority of the operators is our addition operator, and this one's going to be very easy for you to recognize. It's just what we have in mathematics. We use a plus sign. So if we go to Python and we say print 5 plus 5, what is Python going to do? Well, it's going to give us the result of 10. And notice that's an integer. So we're adding the integer 5 to 5, and we get the integer 10. Notice that with a lot of these mathematical operators, if you were to introduce a float, then you'll get a result as a float. So here we can see at least one of the values we're adding is a float, and sure enough, that's going to print our result in the float format. So we want to be aware of that. Let's take a look at the second mathematical operator. This is the penultimate as far as priority goes, right? It's the second to worst as far as priority goes. Subtraction, so print 5 minus 5, another easy one, just like our mathematics. This is going to give us our result of 0. And sure enough, if we were to introduce a float, we're going to have the result in the float format. Next up, it's multiplication. And with multiplication in Python, we are going to be using the asterisk. So print 5 asterisk 5 is going to give us our result of 25. And you guessed it, if either of those values is a float, we'll get the value as a float. Next up, it's division. And we are going to be using the backslash, or actually it's the forward slash. So it's print 5 forward slash 5. That's going to give us our result of 1. And notice we have an exception here. The division is always going to give us a float. Yeah, so we have an exception to the rule to be aware of when it comes to division. Next up is integer division. Integer division is going to round. And notice to do integer division, we are going to be using the forward slash syntax. So if I say print 25 forward slash 4, it's going to do the division and it is going to respond with 6. Yeah, it's rounding, isn't it? 6 times 4 is 24. And so it's giving us the value of 6 here. You can have 4 6s into 25. We know there is a remainder, but notice it isn't shown. What if we did that, by the way, with a float? So here I'm saying 6 and then /3 period. It's, of course, going to give us the result in the float format as we would expect. Now, another option that we have inside of Python is to do the remainder. In some programming languages, this is referenced as modulo, but in our syntax, we'll call it the remainder operator. And notice what happens here. It's a % sign. And this is going to give us the remainder. So I'm hoping we get a value here of 1. Yeah, that would be our remainder. And that's exactly what this remainder function does. Once again, if we introduce a float, we'll get our remainder presented as a float. And finally, the last of our numeric operators is exponentation, and we're going to use the asterisk for this. So 2 **3 is going to give us the value of 8, and you guessed it, introducing a float will have the value presented as a float. So we have all of these different numeric operators. We need to know these. If you feel like flashcards would be of assistance here, yeah, that's not a bad idea at all, right? If you haven't done a lot of math with Python, well, as you know, in the last video, we took a look at the main numeric operators, and we told you that we'd have more to say about those, and this is that video. This is going to be simple and straightforward, but we wanted to break it out from the numeric operators themselves so that you have everything in small digestible chunks and everything is so easy to understand that way. So one of the things that we need to think about is the operators. Many of them that we saw are actually what are called binary operators. That's right. For instance, look at our subtraction here. The subtraction symbol takes what's on the left and subtracts from it what is on the right. It works with those two components, and that's why we call it a binary operator. Yeah, so when we do the dash in this fashion, it is interpreted as a binary operator that does subtraction. It's the same with our addition. Yeah, this plus symbol is going to work on the value to the left and the value to the right. It is functioning as a binary operator in Python. Now, these same symbols can function in a unary operator role. Yeah, so if I take the negative sign and I run it up next to the number 1.5, then what am I doing? I'm creating a negative number. Yeah, in this case, a negative float. So notice when this same symbol is used in a different way inside of Python, it takes on a unary operator function, and it only operates with that value that is directly to the right of the symbol. Plus would be the same way. Yeah, and this is assumed. So sure enough, when we tell Python, hey, print positive 1.5, it says, well, that's 1.5. Thank you very much. There's a couple of times, couple of kind of corner case times in Python where you would use the unary plus symbol to do some various things. So isn't that interesting? That same operator can have different functions based on how it is used inside of Python. And that's the specific language that we refer to with these operators acting in that way. Now, the other thing I wanted to remind you of is these operators have priorities. I told you in the previous video when we went through the numeric operators that we were doing them in order of priority, from least priority up to the highest priority. And that impacts our readability with our code, doesn't it? Yeah, I mean, we want to know that multiplication takes priority over addition here, so that when we look at this, we say, okay, that's going to be 3 times 5 is 15, plus 2 is 17. Now, one of the things I'll remind you of at the end of this video is you can always use parentheses within parentheses to change the priority however you want, or even just to increase readability. Yeah, a lot of times I'll find myself using parentheses, even within parentheses, just to improve readability, even though I'm not changing any of the priority anyways. So, yeah, we have to keep in mind the priorities of these operators. Something else is how they bind, operator bindings. What is this a reference to? Well, what if you have multiple of the same operators? Now, what is the priority going to be? How does it bind? And this one, the remainder operator, it operates from left to right. And that is typically what you're going to get. Yeah, bindings will be left to right. So we do the 6 into 9, which leaves 3 as the remainder. And then we do the 2 into 3, which leaves 1 as the remainder. And that's what we get, the value of 1, because we do the operation from left to right due to the left to right binding. Now, you knew that I had to give you an exception, right? Sure, there is a time when the numeric bindings that you know about are going to operate in reverse, and that's when we do exponents. Yeah, so this would be 2 raised to the third. Notice we're starting from the right. 2 raised to the third, which gives us 8, and then 2 raised to the 8, which gives us 256. So this is that rare exception where we're doing the binding from right to left. Now, as I promised you, before I leave you in this video, I wanted to just remind you, parentheses can really, really help you out in that whole priority game, but more than that, readability. Yeah, so use those parentheses for sure if it's going to improve the readability of your code. And obviously, you must use the parentheses if you want to override the default priorities of your operators, of course. Well, thanks so much for joining me. We've got lots more to say about operators and lots more different types of operators to share with you as we travel through this journey of entry-level Python certification together. Oh, and of course, let me show the correct answer here. This would print the value of 160 to the screen, and that's because we have that remainder portion being done first, the innermost parentheses. That gives us a remainder of 12, I believe. Yes, and then 5 times 12 is 60. 60 plus 100 is our 160. Well, we have already covered a lot of different operators that we can use in Python, but guess what? As you can see from the title of this episode, we are not done looking at operators. Sure, let's talk about string operators. Yeah, there's one that is very valuable, and it's called concatenation, where we are going to bring strings together, and we're going to use what appears to be the plus symbol for this. Yeah, look at this example. I take a variable named first_name, and I populate it with a string of Anthony. And then last name, I populate with a string of Sequeira. And then the full name is going to be set equal to the first name. And then notice our string operator of concatenation, the plus symbol. I add a space, I add another plus symbol, and then last name. When we print full name, you better believe it, it's going to engage in this concatenation. It's going to give us the first name, a space, and the last name. There's another type of string operator we should be aware of, and it is to repeat a string. Let's take a look at this example. So here I am setting a variable called greeting to the string of hi exclamation point, and notice a blank space. I then say repeated is going to equal this greeting, and then it looks like a multiplication sign. But yeah, this is the repeat string operator, and it says repeat this 3 times. So sure enough, if I asked for Python to print the value of repeated, what does it print? Hi, hi, and hi. Yeah, so that is how we can easily repeat strings with the repeat string operator. What other types of operators should we be aware of? Well, of course, there's the assignment operator. Yeah, we've been using this, since like day 1 in our Python videos. Yeah, where we take a variable, for instance, my test variable, and we set it equal to something. But guess what? There's also shortcut operators in Python. Yeah, so let's take a look at one of these. X is equal to 10. and then I say x plus equal 5. What is happening here? Well, the plus equal syntax is a shortcut operator. It's saying take the value of whatever x is and add 5 to it. Yeah, so sure enough, at that point in the operation of things, x is now equal to 15. It was 10, and we're adding 5 to it. What happens if we have another line of code that says x times equals 2? Well, sure enough, this is going to take the value of x, which was 15, and it's going to multiply it by 2, giving us a value now of 30. So if we tell Python to print the x value, it's going to print for us that value of 30. So I love the shortcut operators. Sure, we're saying go ahead and give us that previous value of x and do something to it. Now, remember in Python, we have our Boolean expressions where we have a value of true or false, and that's binary 1 or 0. Well, sure enough, there are Boolean operators we should know. For instance, not, which reverses a Boolean value, or and, which would return true if both things that are being analyzed are true, and or, which would return true if at least one of these conditions is true. So let's take a look at a Boolean operator in action, shall we? I set x equal to 5, and then I say print x is greater than 3 and x is less than 10. So does both of these stand true? That's what the and would test. Both need to be true in order to give us a true value. And of course, that's exactly what happens. This evaluates to true because x is greater than 3 and x is less than 10 if we set x's value here to 5. So Boolean operators are very valuable for us as well. How about relational operators? Sure, like equal to, or not equal to, or greater than, or less than, or greater than or equal to, or less than and equal to. So relational operators are also available to us in Python. Let's take a look at an example. I say A is equal to 5, B is equal to 3. You guessed it, print is A equal to B? And the answer, of course, will return false, as A and B are not equal to each other. Finally, folks, I know you're thinking, my goodness, how many operators am I going to need to know? Well, finally, we wrap up this video with our bitwise operators. That's right. This is for manipulation of bits in binary operations. Notice there's an and, there's a not, there's an XOR, there's an OR, there's a left shift, there's a right shift. All of these are going to manipulate bits in a different way. And you can see I've got the description of these operators listed here for you for reference. So let's take a look at an example here. Let's zero in on that OR bitwise operator. Sets each bit to 1 if one of the bits in the two values we're comparing is equal to 1. Let's take an example of this one. So I'm going to say A is equal to 5. Now, notice the comment I added here. In binary, that is 0, 1, 0, 1. I then set B equal to 3. In binary, that would be 0, 0, 1, 1. And then sure enough, I say the result is equal to A, and then the OR operator, bitwise operator of OR, and then B. So what is the result going to be when we print it? Well, it's going to be 7, because in the first bit position, there is nothing set to a 1, so that remains a 0. In the next bit position, we have one of the values at 1, so that's going to set it to 1. In the next bit position, one of our values was 1, so that gets 1. And then finally in the least most significant bit position, the far right, both were set to 1, so that's going to equal 1. So the binary is going to be 0, 1, 1, 1, and when we convert that to decimal, it's 1 plus 2 plus 4, and that equals 7. So our bitwise operators, a little tricky, a little strange if we're not used to working with binary, but it's important for us to understand that these bitwise operators exist in Python and we can take full advantage of them, especially when we are working with binary operations, as we often do when dealing with things. Well, if you are like me, going carefully through the Certified Entry-Level Python Programmer objectives as we move throughout this course, you're going to notice an objective that talks about floating point accuracy. Yeah, so let's go ahead and cover this subject of floating point accuracy, or a lack thereof, in Python. And just so you know, this is probably going to be the shortest of all the videos that we have in this Certified Entry-Level Python Programmer course. Yeah, there's just not much to discuss here other than the fact that there is accuracy issues with floating point, and this really shouldn't surprise you. Remember, I mean, we can't always perfectly, accurately represent numbers. If you look at 1/3, our fraction 1/3, we know it's 0.333333, and that goes on forever, just as a way to demonstrate how we can never have complete accuracy here, or at times we don't have complete accuracy. And that is going to happen with floating points in Python. Let me go ahead and prove that to you. So here we can see an example where I'm asking Python to print the result of 0.1 plus 0.2. You might look at this and go, well, this is going to be easy. The answer is going to be 0.3. Yeah, it couldn't be easier, right? Well, no. You see, Python is going to have trouble accurately representing values like 0.1 and 0.2 in binary. So what is the answer going to be? Well, try it yourself in Python. When you add these two floating points, you're going to get the result that we see on screen here. Yeah, so you're going to get a slightly inaccurate result. Isn't that interesting? So one of the things that we need to consider is Boolean operations with this. Yeah, so now we know if we ever did something like, okay, 0.1 plus 0.2 equals 0.3, right? Yeah, now we will no longer be as stunned when Python responds with false. Yeah, we would have to build in some flexibility here in the comparison, sure, because according to Python, these two things would not 100% be equal. So just be aware of these floating point inaccuracies that can occur. It's not the biggest of deals. We just wanted to make you aware of this because, as we said, this is important to know, and it is one of the objectives in our official exam objectives. Well, all right, let's wrap up this particular section of content in the next video because we need to teach you about something we've actually seen in earlier videos, but it's time to really expand upon it. And it's a principle in Python called typecasting. Yeah, we'll take a look at it in the next video. I'm sure you've been very impressed with how Python allows us to work with all kinds of different data. And sometimes this can be a little troubling. Let's go into our Python shell for a moment and let's remind ourselves of something. let me grab a value for X and let's get it from our end user. We're going to look at the input function in great detail in just a couple of videos from now. But remember, we can, as we see from the context-sensitive help here, we can put in a string to function as a prompt. So I can say, give me a whole number, for example. And let me close the string indicator and then close the parentheses. And so when we run this, we are prompted to give a whole number. I'm going to give the number of 10. And when we print X, it sure looks like we have the number 10 for that variable X, but that's not true. Yeah, we have a string that is 10. And we can prove this by saying, go ahead and take X and add 10 to it. And sure enough, this is where we run against an error that says, hey, wait a minute, you're working with a string value, not an integer value as you might think. So one of the things that is wonderful inside of Python is our ability to take data and convert it as we need it. This is called typecasting. And let me give you some great examples of typecasting inside of Python. Yeah, there is a built-in toInteger function. Sure, and the toInteger function is going to do that integer conversion for us. So here on screen, you can say, I am saying integer or int, and then a value of 3.6. That is a float. So what do you expect to happen? Well, I think we should get a result of 3. And that's exactly what happens. How about taking the toInteger function and giving it a string? Yeah, so here I'm saying, give me an integer, and we have a string value of 12. And the toInteger function says, no problem, there is your integer value of 12. Okay, you knew I had to do it. What if we say, hey, go ahead and give me an integer for the string of hi? And sure enough, this produces an error. Yeah, Python has had enough. And it's saying, wait a minute. Your string doesn't work out to be a number that I can represent as an integer, so I can't help you here. Another nice function that we have, as you might guess, built in is the toFloat function. So if I say float and then I give the number 3, an integer number, Python will say, hey, wait a minute, no, that's 3.0, thank you very much. How about float and a string value of 12? Well, sure enough, you know what's going to happen, right? Based on our previous example, Python doesn't have a problem with this, and it says, okay, we'll make that 12.0. How about float true? Ooh, the Boolean expression of true. Do you remember what numeric value the Boolean expression of true gets? Yeah, it's a 1. So I think if we do a float of true, I think we're going to get 1.0. By the way, remember, there's a lot of case sensitivity inside of Python. So if I were to say float and then true all in uppercase, this would return an error. Notice you can tell that you're in trouble, can't you? And that's due to the colorization. Yeah, when I typed in the Boolean expression of true properly, it was colorized orange by Python. When I typed it in uppercase, no longer making it the Boolean value of true, it produced an error. And we had a visual clue there because, of course, it was not giving us that orange representation we would see with a keyword inside of Python. How about the toString function? Sure, we have a toString function. I could say, give me a string value. Notice it's str. And I could say, give me a string value for 3. And it would say, okay, there you go. Notice it would place 3 in the string indicators. How about string 12.5, a float? No problem. 12.5 as a string. And how about giving us a string of the Boolean true? No problem. It will take the value of true and it will provide it to you as a string. So notice there are going to be functions inside of Python that are going to enable us to easily typecast. Yeah, to take a data type and convert it from one to another. There are other typecasting functions built into Python, but we're not covering all of them here. We don't need to be that comprehensive, and many of them involve data sets, which we haven't even explored yet. So typecasting, we love that we have this power inside of Splunk. And guess what? Inside of Python, excuse me. You can tell I often teach Splunk. And we've got one more to wrap this up with, by the way. It's the toBoolean function. I almost forgot it. How could I forget it? If we do a Boolean of 0, it's going to say, well, that equates to false. If we do a Boolean of hello, it says that equates to true. What's going on here? Well, anything other than 0 is going to equate to true. What if I go Boolean and then nothingness? Well, that'll be equating to false. Yeah, so an empty string is kind of like a 0. It'll equate to false. Boolean of a space would... And we are ready to officially cover the print function. Yeah, we've seen plenty of use of the print function. But one thing I'd like to start out with right now is I'd like us to go ahead and take a look at how we could find documentation about any of the built-in functions. So let's go to python.org and let's go to the documentation docs area. And if you scroll down, notice there is under the Python 3.x resources, there is an area labeled library reference, also language reference, but library reference is going to get it done for us because there's the built-in functions right there. And notice there is the built-in print function. When you come in and you look at the built-in print function, notice what it does. It shows us the possible syntax that we can utilize with this function. Notice it says that we can have a number of objects to print separated by a, what is that? That's a comma. Yeah, that is a comma. So we can print multiple objects separated by commas. And then notice there's a separator entry and an end entry we can give. There's also a file and a flush reference, but we don't need to worry about these because they are not called out for us to know based on our exam objectives. So notice there is a lot of great value from checking the documentation when you're working with your built-in functions. And don't forget, of course, that we can read all about the print function here as well. All right, so we've got a couple of things to see based on this exploration here that we have not seen before with the print function. The first thing we'll take a look at is the ability to print multiple things, multiple objects. So I could say something like x equals 10 and y equals 5, for example. And then I can say print, I can print x, and then I can print y, and then I can print maybe x plus y, and we have to do case sensitivity here with these variables. And so, yeah, look at this example. Here I am printing x and then y and then x plus y for 10, 5, and 15. Now, one of those special characters that we saw we can introduce, or special arguments, I should say, is the separator. So let's play with that right now. I could say x, y, x plus y once again. And this time, instead of hitting enter, I'm going to do another comma, and I'm going to say that instead of separating things with a space, I would like things separated by, how about a pipe symbol? So now I'm going to close off my parentheses. So notice here we are saying, let's print x and then y and then x plus y. But for a separator, instead of a space, let's use a pipe. What do we expect? We should see 10, pipe 5, pipe 15, and look at that. That's exactly what we see. So there is this separator argument. Now, the other argument we haven't covered here is something that you're really best to experiment with utilizing a Python module. And what it is what Python will do at the end of the printing. Notice by default, we can see in the arguments here that by default, there'll be a slash new line. Yeah, that whole backward slash n is for a new line. So when we print, we have it end with a new line. But I can modify that. Watch this. I'm going to say print hello. And then I'm going to say, comma, the end equals, how about just a space? So first we're going to print hello, and then at the end of that printing, we're just going to do a space, and I'm going to then print, this is more text, because I'm not feeling that creative today. All right, so look at this. We have the two print statements, and we have the first print statement that is modifying the what's going to happen right after the printing. Yeah, instead of skipping to a new line, we're saying it should just enter a space. All right, we'll go ahead and file save this. I'll save it into my downloads as simply a module named print. And there we go. We're going to go ahead and remember, first, check the module. Okay, great, no errors. Now we're going to go back to that module, and we are going to run that module. And look at that. It works just as we would expect. Hello, and then there's no new line. There's a space, and then it says, this is more text. So, yeah, the print function, you now should feel very comfortable with it. And these additional options that we just saw, these arguments where we can set a separator character, and we can also dictate what's going to happen when the print is done, what happens at the end of printing. Remember too that we can mix values here. So I could always say, okay, print the value of x, and then give me a string, this is the value of x. This is the value of x. You get the idea. So just keep in mind that, yeah, we can print a whole bunch of objects. And of course, we had not defined what x was, but you get the idea. This will work just fine. In fact, let me prove it. X is 10, and then I'm going to print the value of x, and I'm going to just print some quick text in a string that says hi, and there we go. So no problem mixing different types of objects to print either. Well, thank you so much for joining me in this video. In the next video, per the objectives of our exam, we're going to be taking a look at the input function. I'll see you there. Well, you have been working very hard in this course. Congratulations. And I've got some great news for you. Well, actually, two pieces of great news. The first piece of great news is that this video is another very easy one. So go ahead and breathe a sigh of relief. You'll love how simple this concept is. And then the second piece of great news I have for you is that you have completed the first major domain in your journey of certified entry-level Python programmer. So we'll have some fun in the next video to celebrate that fact. But for right now, as you know, we need to talk about the input function, and this is review for us, because everything I'm about to show you, we have actually seen before. So the first thing I want to remind you of is when it comes to your input function, as you can see, it is very simple. There's one thing really with the input function that you need to decide on, and that is, do you want to have a prompt for your user? Enter something here, for example. That's right. Do you want to have a prompt for your user or not? I mean, that's really the one thing here as far as arguments go. Yeah, when we were looking at the syntax a moment ago, you saw that prompting is the only argument. So if we want a prompt, we would enter it. And notice you could use the same approach that you use when printing a string. We can use the single or double quotes around the text that would be our prompt. So enter something here, we're going to see that, and we can enter something, and there we go. It's just spit back out to us if all we are doing is the input command. Now, clearly what we are often doing is setting that input to a variable, and I'll show you that in one moment, but I'm sure you're curious, what would happen if you didn't use a prompt? Well, it's just going to sit there, waiting for your input. So that's a little strange. We can see where, the prompt is a great thing, although it's possible, of course, that we might print the instructions. And if we print the instructions, there would be a new line, and then there would be the cursor after that line waiting for the input. So I can see us not having a prompt. Now, here's the big thing I want you to know about the input command. And as I said, we did cover this in a previous video, but this is the big thing for us to remember. And that is, we are getting a string value. In fact, we just proved that to you, didn't we? Yeah, we entered 102 and we were given a string back. Here we entered 102 and given a string back. So by default, we are going to get a string out of the input command. Let's just see this even with a variable. So x equals input. So we're going to ask for something, and I'm going to give a number. Let's give a float. And if I ask for the value of x, look at that, it is going to be a string. So keep that in mind. You are getting a string when you do the input function. So what we can do, as we have seen in a previous lesson, is we could always say, all right, we need an integer, so we can enclose the input in an integer function. So I can say input a whole number, and I want to thank one of our viewers for pointing out that you would need to be precise like that because we want an integer. Yeah, we want an integer here. And, we know that because we're converting it into an integer. So it'd be smart to specify that we want an integer or a whole number. And so now, of course, we have an error actually. And what I did wrong there was I did not give enough parentheses, as you can see. So look at that. I have two open parens and I forgot my closing parens. So we need to stop the processing of this, and I can do that with, let's see. Okay, there we go. Just any character will stop the processing of this. Okay, let's try it again. And this time, let's do it correct. So the integer function, and then an input, And then our instructions, input a whole number, please. We should be polite. And then paren. There we go. And now we have this input a whole number. How about 157? And now if we print the value of x, notice it is an integer. It is not a string. Another way to kind of prove that would be saying something like y equals x plus 10. 157 plus 10 is 167, and there's our proof that we are indeed working with an integer thanks to the integer function. So the input function, yeah, what a great way, simple way to get input from our end user. And please remember two things about it. You can use a prompt or not, and it's always going to be a string. If you need another number, you're going to need to typecast, as we learned about, and you're going to need to convert that string into the format that you require. Well, thank you so much for watching, and I hope you'll be joining me in the next video for a celebration of the completion of our first domain. And as you know, we have completed section 1. So it's time to do some videos that will review section 1. And this is the first of those review videos. Let's go ahead and take a look at some multiple choice to help us review that content. Question 1, what is the correct output of the following Python code snippet? So we have x equals 10, y equals 3, z equals x / y. Notice I'm not giving anything away there, I hope. Print z. Is the answer going to be A, 1, B, 3, C, 4, or D, 10? So you can pause the video here if you'd like some time to think about this, and just go ahead and unpause when you are ready to cover the answer. So what is this question really zeroing in on? Well, it's those operators that we covered, and sure enough, this is integer division. That's right. So 3 into 10 is going to give us an integer answer, dropping the fractional portion or decimal portion. It's going to give us an answer of 3. That's right. So print z will end up printing the number 3. That is the result of that integer division. So if this was a struggle for you, certainly a whole lot of flashcards on the many different operators we have inside of Python, that could really help you out. Question number 2, which statements regarding indentation in Python are true? And we are going to be choosing 2. Indentation is never required in Python. The recommended best practice is 4 spaces to indent. Tabs for indenting are not supported in Python. Or finally, use a consistent approach to indentation in a Python program. Which 2 are correct? Again, pause the video if you'd like some time to think about this one. Well, indentation is never required in Python. This is not true. Yeah, not true at all. We do have times where we are required to indent in Python. The recommended best practice is 4 spaces to indent. That is absolutely true. That's right. 4 spaces is the recommendation. Tabs for indenting are not supported in Python. No. They are. They are supported, so that's incorrect. And then finally, you better believe it, use a consistent approach to indentation in a Python program. So Python would not want you using the 4 spaces in places and then using tabs in other places. Yeah, they'll support both. They just want you to use either one consistently. Question number 3, which of the following statements correctly describes a key difference between an interpreter and a compiler? Compilers execute code line by line, while interpreters convert the entire code into machine language before execution. Interpreters execute code line by line, while compilers convert the entire code into machine language before execution. Compilers are faster during development due to immediate execution, whereas interpreters are slower. And finally, interpreters always produce an executable file, while compilers never do. What's the correct answer? Well, the correct answer is interpreters execute code line by line, while compilers convert the entire code into machine language before execution. Notice that's going to make A incorrect. Yeah, of course, because that's just taking this and flipping it around, and that won't work. And then compilers are faster during development? No. Compilers can make development a bit tougher for us because we're going to be making changes and then we have to recompile. Interpreters don't produce an executable file. That's the job of a compiler. Great work for those of you that got that correct. Next up, which of the following variable names reflects the best practices recommended in PEP 8? Would it be the current temperature as shown in A or B or C or D? Yeah, think about it. What was the best practice recommendation? Well, sure enough, it is all lowercase and use an underscore where spaces would be appropriate. So current underscore temperature reflects the best practice. And finally, question number 5. What is the default value for the end argument in the print function? Is it A, which would be nothing? Is it B, which would be /n, C, which would be a space, or D, which would be /t? Yeah, the default value for the end argument in our print function is /n. That is a new line. Notice D would be a tab, C would add a space, and A would be nothing for the end argument. So /n is our default value. Welcome to Certified Entry-Level Python Programmer, everyone. We are at part 17, and it is time to do an assignment regarding section 1. That's right. What I would like you to do, if you are so inclined, is I would like you to create a Python program that will convert Celsius temperatures to Fahrenheit. Yes. And you're going to ensure your program accepts a Celsius value from the end user. Finally, of course, your program should follow best practices as covered in our course. As you might guess, the very next video is going to be my solution to this assignment. So you're going to be able to compare your own work in Python with your instructors. That's right. So you'll see my solution in the very next video. Remember how you're going to attack this assignment. The way to do that is to fire up your idle environment for Python. And then what you should do is do a file, new file. And what you're going to do is, of course, create your code here, and you're going to work with this code and debug this code. You're going to be saving this code. I'll save mine to my downloads folder, for example, and I'll just call it temp-convert, for example. Let's get that spelled right. So yeah, you're going to be saving this file and working with this Python file to create, of course, your temp converter. So yes, do it in a new file. And that is what we will come back and take a look at. As I stated in our next video, I will show you my suggested solution for this assignment. Welcome back, everyone, and we are ready to share my solution to the assignment for section 1. As you might recall, we were asked to create a Celsius to Fahrenheit temperature converter, and let me show you what I came up with for that. So I'm going to open up the idle shell and then do a file open, And let's go to my downloads folder and open the temp-convert Python program that I created for this assignment. Yours is going to vary from mine, of course, but let me walk you through my logic here and what I did. First of all, remember, it's always a best practice to document your program, and I do this, of course, with comments. So I have an initial comment of who wrote this program, and then a second comment of what this is all about. This is my proposed solution to assignment 1, of course. The next thing that I did, and I was really focused on, readability and comprehension here, as opposed to trying to do this in as few lines as possible. So I do a variable called cTempString, that's Celsius temperature, as a string, and I set that equal to getting the input from the user. We say, please input the temp in Celsius as a whole number. And notice what I did, a little bit of formatting there. Notice how I add a space after that colon. So notice you'll often be doing some cosmetic techniques like this so that your program looks great when it runs, as well as being, of course, error-free and completely functional. So notice we're getting the Celsius temperature as a string value. And then I'm going to take this and convert it to an integer and store that in simply the C_temp variable. So sure, we take what we got from the end user, we convert it to an integer, and we store it in that new variable. Then I'm going to be doing my Fahrenheit temperature, and it's going to be as a float. Yeah, and this will be taking our Celsius temperature and multiplying it by 1.8 and then adding 32. Notice my use of the parentheses here. That's just to make this conversion more readable. Yeah, sure, because the multiplication is going to have priority and would take place first there. So yeah, I'm putting in the parens purely for the readability of my code. Then I'm going to come up with my Fahrenheit temperature, which is to take that float value that we got and convert it into an integer. And then finally, it's time to print our results. So I print the Celsius temperature and I say in Celsius is, and then I print the Fahrenheit temperature and the in Fahrenheit text. And then of course, a little thanks for using my program. So when we run this code, we are, of course, prompted, please input the temp in Celsius as a whole number. Let's say it's 24 in Celsius, and then I hit enter, and our program says 24 in Celsius is 75 in Fahrenheit. Thanks for using my program. So I hope that you went in and paid attention to things like the, way in which your program looks. Yeah, does it look good? Are there spaces where you would expect them to be? And we are just going to take a moment here to introduce you to section 2 of our course, which we're going to be jumping into in the very next video. What I also wanted to do here was just kind of remind you of what our course is tracking against, and that is none other than the Python Institute's certification, specifically, as you can see under the certification menu, it's the PCEP entry level Python programmer. Yes, that's the exact certification that we are using as our guide. If you scroll down on the PCEP page, you can find exam information, and there under the exam information, remember, is the exam syllabus. So on the right side, the retiring version, actually retired long ago, And here is the latest greatest. If we scroll down, you can see the 4 sections that make it up. And we are about to start a very fun, very interesting section. I think, especially if you compare it to some of the more dry material that we had to cover in section 1, you're going to love section 2. Notice there's 2 blocks of information here, making decisions and branch the flow with the if instruction. So this is great. We're finally going to be really working with if-then type logic, which can allow us to do so much in our programming. I mean, think about the temperature converter that you created moments ago in section 1. That would have been so great if we could have made it where you can go either direction, right? Maybe the program could have started by asking, do you want to do the Celsius to Fahrenheit or Fahrenheit to Celsius? Yeah, if we had if-then type logic, we could easily build such an application. And then notice the second section in here is for various types of iterations. Yeah, one of the things that computer programs are great at doing is doing a task over and over and over and over again, or multiple tasks, doing those again and again and again. It's one of the reasons we love computers, is that they'll do something for us without fail over and over and over again, and can do this so much faster and accurately, more quickly and accurately than humans can. So notice, very excited about this second section. I hope you are as well, to get into some of the more interesting areas of Python that deal with logic and how we can do iterations and things of that nature. So I hope you will join me in the next video where we're going to dive into, you already know what it'll be the beginning videos dealing with the if statement. And as you know, it is time for us to tackle the if statement. Yes, let's add conditional logic into our programs. It's going to allow us to do so much more. Just think of your everyday life. It's a whole list of these if statements. If something's happening, then something else will happen. If I got enough sleep, I'll set my snooze. I'll cancel snooze. Yeah. If it's raining, I won't go for a walk. All these kinds of decisions, we need to bring this logic, if possible, to our Python programs. And the if statement is one simple way in which we can do this. Let's start a new file, shall we? And I like to save it right away. We know we're going to need to save it anyways. I'll save it in downloads, and we'll call this fun_with_if. We'll save that, and let's have some fun learning about this if statement. So what I'm going to do is I'm going to create a fun little menu with you right now. So I'm going to create a variable named menu, and I'm going to set it equal to getting input from our end user, and I'm going to give them a prompt that says, press 1 for this, or press 2 for that. Just having a little fun here. And we'll do a colon, a space, and then we'll end that prompt. Remember, when you are creating your programs, you'll always want to think about the format that the end user is going to be seeing. So press 1 for this or press 2 for that. How fun. So now we are going to have what in the variable of menu? We're going to have a string of 1 or a string value of 2. All right, and now we can have fun with our if statement. I can say if the menu is equal to, and remember, we're dealing with a string here, so I have to represent it as a string. If the menu is equivalent to, if the menu variable is filled with the string of 1, then we are going to do some code. Now, when I hit enter, you're going to see something really neat. The idle editor here helps me out. It sees that I now need indentation in Python. Yeah, it knows that what comes after an if statement must be indented, the stuff that is going to occur. It's basically the results of a then, if-then logic. So whatever comes after this if statement must be indented and is going to be performed as part of this if statement. So isn't that great? Once again, just to demonstrate that, I hit enter. The idle environment knows that's a place where we need to indent, and it does the nice indenting for me. Is it 4 spaces? Is it a tab? I don't know. I don't care. I'm just relying on the idle editor here to do the spacing or indenting for me. Now, how this if statement works is it now does whatever we want executed. So just think about that. This could be like running a function, and please notice that you could then run another function. So you would just continue in that same indent block, whatever instructions need to take place if menu is equal to 1. And then what happens is on your unindented next line, you would have what occurs next. Yeah, not tied to that if statement. Sure. So I might print something like, thanks for using my amazing program. All right. So notice the if statement is going to often do a comparison. Notice the double equals because we're using the comparison operator here. We're not assigning menu a value like we did up here. Here we're saying, is menu equivalent to the string value of 1? If it is, we're going to do some stuff. And then after that, we're going to print this. Now, we need a test for if they press 2. So let me add that logic into this. If menu equals 2, then do something. And what we'll actually do is print something. And what we're going to print is, what is it for 2? It's that. So we're going to print that. Yipper. So excellent. And for 1, we are going to print this. So a fun little functional program we have now that takes input from the user, and then if the menu variable is set to the string value of 1, it'll print this. If it's set to the string value of 2, it'll print that. Notice also with our fun little example here of the if statement, notice that we don't get into typecasting, right? Isn't that an interesting thing about our approach here? We know that we're getting a string value with our input function. And so we're just going to do our test for that string value. Yeah, no need to convert with typecasting as we've seen us do before. All right, well, I'm going to do a file save, and let's make sure we don't have any errors. Let's check this module for errors. And so we're going to go back over to that file, and sure enough, it is error-free. And now we're ready to run it as our true test. So let's run the module. Press 1 for this or press 2 for that. Let me try 2. And what does it do? Yeah, it runs that block of code indented under that if statement, which said print that, and then it says, thanks for using my amazing program. Well, obviously we need to go over and run this again, and this time we need to press 1. And sure enough, it prints this. And then Thanks for using my amazing program. So a very simple, straightforward way to begin where we are talking about if logic, and it's time for us to look at if-else statements inside of Python. So yeah, let's take a look at the exercise that we did in the last video. If you remember, we were playing with the if clause or if statement. So enter 1 for this, enter 2 for that. We ask the end user, and then we have our if logic that says if the menu item pressed is equal to 1, then print this. If menu item 2 is pressed, then print that. And then, of course, we say, thank you so much for playing at the end. Now, wait a minute here. What if they hit something that is not 1 or 2? Well, first of all, I want to see that running. So enter 1 for this and 2 for that, or 2 for that. Let me enter 4, for example. What happens? Ah, look at that. Just as we might expect. So let's think about this logically. We entered 4. It does this test, and it does not follow the print instruction because menu isn't equal to the string value of 1. It's not equal to the string value of 2, so this never happens. And then it just does our final print command. You see, this is where the else statement, the else statement in Python can be so valuable. The creation of an if-else logic. So I'm going to go ahead and say else, and then I'm going to print, and it's a string value that we print, you entered something strange. Yeah, we asked for a string 1 or 2 value, and they did something bizarre. Let's go ahead and do a file save, and we will go ahead and run our module. Enter 1 for this or 2 for that. We're going to enter, how about hello, something very strange. And sure enough, you entered something strange. Thank you so much for playing. Notice how the else logic here is going to give us a lot more power when it comes to our if statement. Now, something else that I want you to keep in mind when it comes to a structure like if-else in Python is the fact that you can nest this logic. And let me show you an example of this, kind of using an example from the textbook that the Python Institute makes available that goes along with this course. In fact, I'll show you that in a moment, just so you know what I'm talking about. But I borrowed this kind of an example from them. Here's a great example of if-else nesting. Notice the indenting is critical here so that Python knows and we know which if-else clauses go together. So it all starts with if the day is sunny. Yeah, so let's say it's a sunny day. Then we're going to execute the if-else inside of that stanza. So if table's available, we're going to dine in, else we're going to order to go. That's what's happening if the day is sunny. Now, what if the day is not sunny? Well, it's going to jump down to the else statement, and it's going to see if tickets are available, enjoy a movie, else go shopping. So notice how we can have if-else nesting to add even more sophistication to decisions that our Python programs are going to be making. Now, as I promised, let me just quickly show you what I was talking about there with the Python Institute. If you go to even like Amazon and you search on Python programming, you are going to run into, let's do this. Let's add the word certified. There we go. If I can spell that right. So certified Python programming, and there you go. Here's Python Essentials 2, and somewhere in here will be Python Essentials 1. In fact, now that I know the name of it, I can give some better searching for it. There it is. So a lot of folks will have asked me, is there a workbook that goes along with this? Well, this would be the closest thing to that. Notice this is the official course materials that aligns with the exam that I am teaching you to pass. So yeah, obviously I have this book. It's not the greatest textbook I've ever read. It's not the worst I've ever read. Yeah. So that's what I have to say about that. This is not required for you, by the way. I'm just showing you this because, like I said, it's what gave me the idea for our nesting example, and also some of you might be interested in picking up this text. Well, thank you so much for joining me, and guess what? The if logic in Python is so powerful, we're not done yet. So we'll be discussing more and elaborating more on other if features coming up next. And it's time for us to look at the else if statement. Yeah, it turns out there's always multiple ways, it seems like, to do things in Python. And let's take a look at that test file that we've been working with on a menu system. And we notice that we do an if test and then another if test, and then we have the else to catch everything else. There's actually a more sophisticated way to do this. Let's add another option in and show off a little bit here. Enter 1 for this, or 2 for that, or 3 to exit, for example. And what we can do is, for these additional tests, we can do else if statements. Yeah, look at that. If menus 1, else if menus 2, and now of course I can do my else if menu equals 3. And let's see, what else do we need to, of course we need to end that with a colon. Easy to forget that colon that we need at the end of the else if, and I'm going to print exit. So notice the else if statement is going to be a great way to test for additional values. We can do this as many times as we like. We can then optionally end with an else statement to catch everything else. Notice that else statement must come at the end of your else if tests. So let's go ahead and save this new approach utilizing the else if statement. And we're going to go ahead and run this module, and we'll try that 3 to exit. And notice it works perfectly. So a simple little video lesson here introducing you to this powerful else if statement that we can build into our overall if logic. By the way, when we have statements like this that kind of go together, this is what we call cascading statements inside of our Python programming language. Well, a very simple, straightforward video showing you yet another statement you can use, a nice tool in your Python logic tool belt. Well, in the last few videos, we were exploring an important aspect of programming logic inside of Python, as you know, and that had to do with decision making. Sure, if else statements and things of that nature to help Python be able to make decisions. Well, now we're going to tackle another important aspect of programming logic, and that is getting a computer program to do things over and over and over again. Sure, that's one of the beauties of a computer programming language, is that it has no problem doing things over and over again really fast. Let's take a look at a way to do this. One of the many ways we'll look at. This one's called the while statement. And notice we can create a while loop. And anytime you hear the word loop in computers, yeah, it could be a bad thing. So we better know how to break out of a loop. Sure. So look at this. I'm going to demonstrate the while command, and notice I'm tricking it. I'm just going to make it always evaluate to true. So what's going to happen here is we're going to see Python print this over and over and over again and never stop. Yeah, let's run this while statement and look at this. We are indeed stuck in a loop. If something like this ever happens to you, we can do Control-C on the keyboard, or you can hit the break button on your keyboard if you have one, and that's going to break you out of that loop. Thank goodness we can break out, with a keyboard interrupt there, so we ensure that the program just does not run and run and run in that loop forever, consuming an awful lot of resources, obviously. All right, so that's how to get out of a loop. I wanted to teach you that right away because, we're going to see lots of commands that can do these iterations, and it is possible you could get yourself stuck in such a loop condition. But now let's take a look at a fun example of the while statement in action. And in this example, we're going to get to review our if-else logic as well. And finally, I'm going to introduce you to a new concept in this sample program, and that is importing a module when you want to do something that isn't inherently built right into Python. Yeah, Python is modular, so brilliant. So if I want to do something with random numbers, no problem. I just import the random module, which has a bunch of functions that we can then take advantage of. And the very first thing that I'm going to do in this program after bringing in that module is I'm going to go ahead and create a variable called secret_number. And from the random module, I'm going to grab the random integer function, and I'm going to have it create an integer for us between 1 and 10 randomly. Yeah, it's going to pick randomly an integer between 1 and 10, and that will be our secret number. Now notice what we do. We go ahead and take a user guess variable and we set it equal to 0. You'll see why in just a moment. We then print welcome to the number guessing game. Now we're going to create a while loop that is going to run until the user guesses that secret number correctly. So what is the while syntax? We're going to say while the user guess is not equal to the secret number. So enact everything that's indented underneath the while statement while that evaluates to false, and then we're going to break we're going to loop while it evaluates to true, and we're going to break out of the loop automatically when the while loop evaluates to false. So now you can see why we set the user guess at 0. Yeah, we needed to make sure that inadvertently the user guess isn't the random number guess. We need this thing to start. So we set it at a value of 0, which is never going to equal the secret number. Next up, you can see we then set the user guess variable to their custom input. Yeah, sure. And notice we're going to convert that into an integer. Nice review of that, which we covered back in our first domain. So they're going to be guessing a number between 1 and 10. If the user guess is the secret number, then we're going to print congratulations, you've guessed the number correct, and it's going to jump down to thank them for playing. Notice there's an else if their user guess is greater than the secret number, we're going to print too low, try again. And then finally, our else logic is you're too high, try again. Yep, your guess is too high. So this will just loop and loop and loop until they get the number correctly. So I wanted to create an example here that did teach us that concept of importing modules to take advantage of the functions they contain. But then notice we have a nice review of key subjects that we have covered, and of course, a look at our new while statement. Well, let's go ahead and run this fun program and see it in action. Guess a number between 1 and 10. I'll do the classic right in the middle guess of 5. And I am too high with that guess. Try again. All right, how about 1? Too low. How about 3? Yeah, we got it. I just got a little overly excited in my own guess the number game. Just goes to show you I'm easily amused. Well, that is the while statement, folks, and there you see it in action. We are once again going to have Python iterate through the while statement until it evaluates to false. When it evaluates to false, then of course we break out of that while iterations. Well, there's other ways to do iterations in Python. Now that you have been introduced to the while loop functionality, I'd like to introduce you to some important commands that we can utilize when we are working with loop-like structures. Yeah, these are going to come in handy for the other methods of iterations that we are going to be discussing. So let's take a look at the pass, the break, and the continue commands in action. For the first one, the pass command, I'm going to just demonstrate this for you live here right inside of one of our files. This is just a fun little way we can put in a placeholder. Yeah, think about it. If I am creating some type of while statement in my program, maybe I want to go ahead and just have a simple placeholder. So I'm saying that the condition is going to test to false, which will break out of the while loop we know, but we have to put something in there. So we can put in there this statement of pass. And now let me print something just to make sure this is totally working. So I'll say success as what I'm printing. So notice, it's going to evaluate the while. It's going to see that it is false, so it needs to stop doing the iterations. And what are we actually doing inside it? We're doing nothing. So if we get the success word printed, we'll know that this is the correct usage of the little pass placeholder. So let's go ahead and save this thing and run it. And look at that. It works perfectly. So if you are constructing a program and you want to just have a placeholder inside one of your statements like this, it's no problem. We can just say pass. And obviously what's going to happen later on is we're going to come and add the appropriate criteria here, and we're going to input the correct instructions that will take place during that while loop. So pass, if you see it, you'll know exactly what is up with that statement. Now, let's go ahead and take a look at both break and continue and see what they can do for us in Python. I've got an example here for us to look at of break in action, and here it is. So here's a look at break. Notice what we do first is we just initialize a counter. So I have a variable called num, and I set it equal to 1. What we're then going to do is loop until we have a number greater than 11. So I'm going to say while our number is less than or equal to 10, do some things. And notice what we're going to do. We're going to check if the number is equal to 5. And if it is, we're going to break. What does this do? it exits the loop immediately. Notice what else we're going to do then. If it is not 5, we're going to go ahead and print the number and then increment the number. And notice this is the first use of that kind of shorthand for incrementing a number. Yeah, we're saying, all right, take that number and add 1 to that number, and that will be the new value of our variable called num. And then we're going to print the loop stopped early due to break. So what do we expect to see here? We expect to see the number 1 printed, the number 2 printed, 3 printed, 4 printed, but I think we won't see the number 5 printed, and I think we'll see that the loop stopped early due to a break. Let's check it out. We're going to go ahead and run our module, and look at that. It works perfectly. So it iterates through, prints 1, prints 2, prints 3, prints 4, but then we know there's a break instruction if the number equals 5. And we can see break working perfectly. All right, well, guess what? There's also the ability to continue with the continue command. So let's take a look at this example. Same thing, we initialize our counter. Same thing, we're going to loop until the number is greater than 10, but this time we're going to check to see if the number is odd. If the number is odd, we're going to implement it. We're going to increment it, so we're going to add to that number, and then notice what we're going to do. We're going to continue, which means it goes right back to the start of the instructions. So it's going to iterate this again, right? This time it's, of course, the number has been added or incremented with 1. Yeah, so pretty cool. And notice there is, outside of this if logic, we have printing the number. Sure, we're going to print the number and increment the number as well. Notice this is going to run until we hit the number equaling 11, at which point it will print finished. So what's going to happen here? We should see the even numbers printed between 1 and 10. Let's run the module, and look at that. 2, 4, 6, 8. Who do we appreciate? And then it does do the number 10, and then it is finished. So notice we have powerful commands we can use, break and continue, inside things like loops to finally control what is happening with our iteration. We also saw, don't forget, in this video, we saw the pass statement, which is just an easy way to put some kind of placeholder in where you will have additional commands later on. I'm so glad that we saw these special keywords that we can use in Python, because these will be coming up oftentimes in your programs, and you want to be able to interpret them just fine. Well, thanks so much for watching. I look forward to seeing you in our next video, where we're going to look at a different way to iterate through cases in our Python logic. Being able to iterate through a sequence of actions is very, very important in Python, as we've discussed. And the while loop is not the only way to do it. Yes, in this episode, we're going to go ahead and discuss the for loop. Now, let's think about this for a minute. If we know exactly how many times we need to iterate through something, well, we could use the while loop functionality. Sure, we could. So let's take a look at that. What we would do if we know we have to do something 100 times in Python is we might create a counter variable and set it equal to its initial value, and then do our while statement and do something like, while our counter variable is less than 100, go ahead and do something and then increment that counter. Sure, so notice this is a way that we can do something 100 times in Python. Now, I want to remind you that pass statement, remember we covered that in an earlier video, that's just a placeholder. Sure, when we have to put some code in there, we can put the pass in there as a placeholder so that we are just testing like the loop functionality, and then we're going to put the actual thing that we're going to do in place of that pass command. Okay, so with all that said, notice this works. It's a perfectly fine way to do something 100 times in Python, except we could actually do it more efficiently than this. Yes, and that's where the for loop comes in. Let's take a look at doing something 100 times with the for loop. It's going to be much easier. Notice I say for counter in range, and then I indicate what that range is. Yeah, I want to do something 100 times, so the range is 100. And notice we're going to indent whatever it is we want to do, and that's it. We're done. Yeah, look at that. So in the previous example, we had 4 lines of code, and in the new example, we have 2 lines of code. Yeah, so the for loop is a very powerful consideration for us when we know exactly how many times we want to do something. Now, let's talk about the range option in a bit more detail. So let's look at this simple little example I've cooked up for us here. For counter in range 10, print the counter is at, and then print the counter, and then thanks for watching when we're all done with our loop. So what we're going to learn from this is how the range actually works. Let's go ahead and run this and notice. So we set a range of 10. Notice what happens. It starts at 0 and it ends at 9. Yeah, so we do get 10 occurrences. It's just 0 through 9. Now, there's something else you need to be aware of with the range, and that is we can do 2 or 3 arguments in here. So one of the things you can do is give the starting unit. So here I'm saying for counter in range 2, 10. So what I'm expecting to see is we start at 2 this time and end at 9. Let's save it and let's go ahead and run it and see if it works as we suspect. Look at that, it does. So this time we start at 2 and we end at 9. Finally, something else that you can do with the range option is you can give a third parameter, and that is the increment. So I'm going to say, let's start at 2. Let's end actually at 11, and let's use 2 as the increment. So what should we see here? We should see 2, 4, 6, 8, 10. So let's go ahead and save it and run it and see if we are correct. Look at that, 2, 4, 6, 8, 10. So the for loop is going to be very, very powerful. As you can see from the title of this episode, it is time for us to add else functionality to our while and our for loops. Let's check it out. Here you can see I have a basic, simple little program where we set a variable named counter to 1, and then we create our while loop. While the counter is less than 5, we're going to print it and add 1 to it. Else, notice we now have an else statement, and we're going to print the else has been triggered, and the counter equals what that counter's value is, and then the program's going to end by printing program end. So remember, it's always fun to think about exactly what's going to happen here. And what I think is going to happen is it's going to print the value of 1, the initial counter value, and then it's going to print the counter value of 2, 3, and 4, and then the else will be triggered, and I believe it's going to say counter equals 5, and then the program will end. Let's check it out. We run it. 1, 2, 3, 4, else triggered counter equals 5, and the program ends. So sure enough, this while else functionality works just like you think that it would. Okay, now let's see something. What if we never enter the while loop? In other words, what if this evaluation is false? I think what's going to happen is we're still going to have the else triggered. Yeah, I think the else will always be triggered, even if we don't enter the loop. So let's check this out. Let's do a trial of this. And what we'll do is we'll just say, look, the counter is 1, but the while loop is false. So we are not going to execute, or I should say Python will not execute this print instruction here or the incrementing. I think what's going to happen here is it's going to jump immediately to the else, and it's going to say the else is triggered, the counter is 1, and the program's going to end. Let's check it out. We'll run this module and look at that. The else got triggered, the counter's 1, and the program ends. So notice whatever we have in that else clause, that's going to be executed exactly once, whether or not we enter the loop or not. Now let's check this out, shall we, for the for loop functionality. So sure enough, I've got a little for else example. For counter in range 5, print the counter, else, print else triggered, counter at, and then program end. So what should we see here? Well, I'm thinking we'll see 0 printed, 1 printed, 2 printed, 3 printed, 4 printed, and then it's going to trigger the else. And you're going to notice something interesting here when we run this module, 0, 1, 2, 3, 4, just like we expected. But one thing happens a little strange here compared to the while loop, and that is, notice our counter's still at 4. Yeah, interesting. So that works a little differently, doesn't it? Yeah, we start at 0, we go up to 4, and the counter retains that value of 4 inside of the else clause. So just a little bit of, difference there in the else execution with a counter value. Now, what about if this is false? Well, sure enough, as we've proven to you, the else will still trigger. Let me ultimately prove that to you here by showing you an example where I set the counter to 100 and then I make sure the for loop never executes. How do I do that? Well, I give a crazy range. I say start at 2 and go up to 1. So this will never execute. And I think what we're going to get is just the else triggering with the counter stuck at 100. Let's go ahead and run this and see if that's true. And that's exactly what happens. So we can use else clauses, as you saw, with our for and our while loops. That's right. And remember, what is in that else clause will execute exactly once, regardless of whether we actually do the iterations of the for or the while loops. Well, time sure does fly when we're having fun, doesn't it? We are already prepared here for a review of our section 2. As you remember, we're going to do some multiple choice style questions to facilitate our review, and let's get started with our first question. Notice a lot of these are going to be representative of what we would see in our actual Python exam, and that is where we have to interpret what's going to happen with some code. Sure, this is a famous way to test us in a multiple choice format on something like entry-level programming. Well, anyways, check this out. This is really simple, so we should never panic. What is the correct output given this code snippet? Well, we have variables A, B, and C created, and then we have if, else if, and else statements. So if A is greater than B, if that's true, that would be 7 is greater than 3 and C is less than A plus B, we would have condition 1 printed. Now notice C is not less than A plus B. C is equal to A plus B. So the if portion of this statement will not print. Yeah, and now what will happen? It'll try the else if statement. And that says if A is equal to 7 or C is equal to 5, print that condition 2. And sure enough, since A is equal to 7, that's what's going to happen. We're going to print condition 2. Notice the if statement won't print, the else statement won't print. Sure, because the else if is going to trigger as a true statement. So pretty simple, pretty straightforward. We just need to know how if, and else works and just take our time and work through the evaluation logic. Let's try another one. Question 2. What is the purpose of the pass statement in Python? It exits a loop prematurely. It skips the current iteration and continues with the next one. It is used as a placeholder for future code and does nothing when executed. Or finally, it terminates the program immediately. Well, we remember that the pass statement is used as a placeholder. Yeah, we'll put future code there, and it does absolutely nothing when executed. Remember, certain statements in Python will require some code or they'll throw an error message. So the pass statement allows us to input some code. How about question number 3? What's the correct output for the following Python code snippet? We have for I in range 2, 10, 3, print I. And notice it'll all be on one line because we have a new print n character of a space. So would it be 258 or 2, 3, 4, 5, 6, 7, 8, 9? Would it be the C option or the D option? Well, for this, we have to review what goes on in that range statement. If we have 3 entries like this, it's going to start at 2, it's going to go up to 10, and it's going to increment by 3. So I think it would be 2, and then 5, and then 8. And that is exactly correct. So yeah, 3 parameters with the range. It's going to be the starting number, the ending number, and how we'll increment. Finally, question 4. What is the correct output of the following Python code snippet? We have I set to 0. While I is less than 5, we're going to say, and execute what's in that while statement. If I is equal to 3, we're going to break. We're going to print I with our space n character, and we're going to iterate I. So what do we get? Do we get 1, 2, 0, 1, 2, 1, 2, 3, or none of these? Well, think about it. I is set to 0, and while I is less than 5, we are going to be printing I, so we would get the 0 printed, we would get the 1 printed, we would get the 2 printed, but grammar part 28. And you know what time it is. It's time for us to do an assignment based on section 2. So here is your section 2 assignment. You are going to create an interactive number guessing game. Now, if you are at a complete loss on this assignment, no problem. Check out our part 23 video, because if you recall, in that video, we do an example of a simple interactive number guessing game. So this is certainly going to help you get started. Now, this guessing game should generate a random number between 1 and 100. You're going to use Python's built-in random module like we did in the part 23 video in order to choose this random number between 1 and 100. Then what I need you to do is prompt the user to guess the number. You're going to provide feedback indicating if the user's guess is too high, too low, or correct. I also need you to keep track of how many attempts the user takes. You're going to continue prompting the user until they correctly guess the number. And finally, we need you to display a congratulatory message and show how many guesses were required once the user guesses correctly. Yeah, so we've made a few modifications, a few enhancements to the number guessing game that you might recall from our Part 23 video. So here is our assignment for Section 2. Best of luck, have fun with it, and as you know, in the very next video, I'll be swinging by to show you my potential or my proposed solution. Yeah, lots of different ways we can solve this, as we know, thanks to the flexibility that Python gives us, but I'll show you my recommended solution in the very next video. Have fun with your Section 2 assignment. Well, if you've been following along in our certified entry-level Python programmer course, you know what time it is. It's time for me to show you my proposed solution to our Section 2 assignment, our number guessing game. Now, remember, my approach is probably going to be different from yours. That's right. There's lots of different ways that we can achieve a solution in Python. That's one of the great things about the Python programming language. So I would encourage you to post your solution to the Section 2 assignment in the comments. It would be great to see different approaches. But with that said, let's check out my approach. So let's go over here and take a look at my solution. Notice I import the random module, and then I create a variable called number to guess, and I use the random module's random integer function in order to create our random number that's between 1 and 100. We're then going to create a variable called attempts and set it equal to 0. Notice this is my counter for the number of attempts. I'm then going to print to the end user that it's our number guessing game, and we've picked a number between 1 and 100 they have to guess. Now notice what I do. I create my while loop. And I did this a fun way. I decided to go ahead and make the while loop always true, and notice we'll break out of the while loop when they correctly guess. Yeah, so that is one way you could approach this. Notice in the while loop, I get their guess, and I go ahead and increment our attempts variable by 1. Then we have our if, else if, and else logic inside the while loop. We're going to say if the guess is too low, we're going to go ahead and give them that feedback. If it's too high, we're going to give them that feedback. If it's just right, if it's correct, we're going to give them their number of attempts and then break from the while loop. So yeah, this was the way I thought to approach this. That would be simple, easy, and very easy to interpret when examining our code. Well, all this is fine and good if it actually works just as we want it to, so let's go ahead and give it a test. Welcome to the number guessing game. I've picked a number between 1 and 100. Make a guess. Well, I think it'd be pretty smart to guess at the number 50, right? Dead in between. Ah, that's too high. Okay, how about 10? That's too low. All right, how about 30? That's too low. 40? That's too high. My gosh, we're zeroing in here. 35 is too low. How about 36? We got it. And our correct number of attempts was 6. I suppose we better sanity check this. 1 guess, 2, 3, 4, 5, 6. Yes, that counter behavior is working perfectly in our application. Again, you may have chosen to solve this a different way, and I would love to see your solution to the Section 2 assignment. Thank you so much for watching, and you know what's around the corner, folks. It's none other than Section 3 in our entry-level programming Python journey. Course. Yeah, we are ready to start a new section. And one of the things that I wanted to do is obviously introduce what material we're going to be studying together in this section, but I also wanted to once again revisit with you how you can find your official exam objectives that we are following for this course. So remember, you're going to go to the pythoninstitute.org, and right up at the top there is a drop down for certifications, and there is the entry-level general purpose programming certification that we are interested in. On this page, if you scroll down, you will see that there is an exam syllabus listed, and you can pull that up if you just click on that link. And notice we are working with the live and active syllabus right here. And as you can see, we're about to start Section 3, where we're going to talk about data collections. Yeah, we're going to be looking at lists first. Then we'll be looking at dictionaries, tuples, and strings. So notice, very first subsection in here, we're going to teach you all about lists, then tuples, then dictionaries, then strings. So we are progressing nicely through the course. And for those of you interested in working with data in Python, get ready. You're going to love Section 3. So the first component that we want to discuss with you when it comes to effectively storing a bunch of information is called a list. Yeah, let's check out using lists inside of Python. First up, let's see how easy it is to create a simple list. Notice I declare a variable, numbers, and I set it equal to my list of things. Now notice we separate each thing with a comma, and the list is contained by square brackets. Now, it just so happens in this example that we have these integers that we are storing in the list. But please keep in mind, you could be storing a mix of objects in your list. That's one of the things that we love about lists. Yeah, I could have a string and then an integer and then a float. It doesn't matter. But in this simple example, we have this simple list and it's all of these integers. So notice how easy it is going to be to create one of these lists. Now, if we say print and then we say the numbers list, what do you think Python will do? Well, Python will print the list for you, and notice to really convey that it is a list that you are dealing with, when it prints the numbers, it will include those square brackets. So we can see at a glance, the contents of the numbers variable is actually a list of integers, and we see that. Now, how can we get to specific list content? Well, that's easy. And that's because what Python is doing is it is indexing our lists for us automatically. Yeah, see that value of 10 in our list? That has an index of 0. And the 5 in our list has an index of 1. And the 4 in our list has an index of 2. So notice if I say print numbers 0 and I reference the index that we are interested in, Python will go into our list, it will retrieve that first object with the index of 0, and it'll say, okay, here is your numbers index 0 value, and notice it prints the number 10 for us. Now, what if we want to change the content inside of a list? Let me give you a couple examples of this. So I set my numbers to 10, 5, 4, 2, and 1. And then I say number 0, we're going to change. Yeah, we're going to change it to 12. And now, of course, I'm going to print my numbers. And you guessed it. That's how easy it is to change the contents of one of our lists. We have a new list now, and it's 12, 5, 4, 2, 1. How about this example? I'm going to go ahead and have my numbers, and then what I'm going to do is I'm going to say, okay, the value in numbers 3 should be changed to the value in numbers 4. Yeah, do you see what's going to happen? When I print my numbers now, it's going to print 12, 5, 4, 1, 1. That's right. The number of the index of 4 was copied into the index of 3. So we have changed the list once again. Now, we're going to see lots more that we can do with lists. But before I let you go in this video, I want to show you one last little trick, and it's the length function. Yeah, we may be manipulating and adding to and deleting from lists, and we may want to just sanity check how many objects are in our list, and this is called the length of our list. We use an len function, which stands for length. So check this out. I go ahead and create my list of numbers, and then I print the length of these numbers. Yep, you guessed it. Python will return 5. So very valuable when you want to check how big your list has become. Well, I hope you're excited about this list concept, and it's time for us to continue with our discussion of lists. And as you can see in this episode, we're going to see how to remove stuff from lists. We'll see how to add stuff to the end of a list, and then we'll see how we could insert a value anywhere we want in a list. So of course, we're going to begin with deleting from a list. How can we do this? Well, let's go ahead and create a list. So notice I will create a variable called myList, and we're going to set it equal to our list. And notice this time I'm demonstrating how the list can contain, different objects. So notice I put a string of Tony in the first index 0 position, then a 5, then 4.2, then 10. So now we decide we want to delete one of these values. No problem. We're going to use the delete statement. That's del. I'm going to reference my list, of course, and then I'm going to give the index number. Do you see what value would be deleted? Sure, it would be that value of 5. Remember, from left to right, our indexing starts at 0. So I think when we print my list now, we are going to see that number 5 gone from our list. And what do we see? It's exactly what we see. So deleting my list index of 1 is going to remove that value of 5 that we had in our list. And notice index numbers shift now, right? Tony is still indexed at 0, but now the number 4.2 is indexed at 1. All right, well, let's see how we would append to a list. This is adding a value at the end of the list. So let's first create a list. So here I say my list is going to equal our string value of Tony, a value of 4.2, and a value of 10. I'm now going to run what's called the append method against our list. We'll learn this syntax of methods later on when we talk about object orientation, but just so you know, it's just really cool that we have what appears to be a function, but it's actually a method. It's mylist.append. So we're going to do an appending to our data, the mylist data, and notice I'm appending the string of test. So sure enough, you know what's going to happen. When we print my list, we're going to see the values of Tony, 4.2, 10, and then the string of test. That's right. When we're appending using the append method, what we add will appear at the end of that list. Yeah, that's the definition of doing an append. All right, well now, what if we need to insert some value somewhere? Well, guess what? We're going to use a method of insert similar to append, and think about it logically, we're going to need to provide two pieces of information, aren't we? Sure, we're going to need to provide where in the list we are going to insert the value, and then of course we have to provide the value. Yeah, so let's take a look at inserting. I'll create a list, again, a string value of Tony, 4.2 for a float, and then 10 for an integer. And then we use the insert method. So I say mylist.insert, and then notice I want inserted at index 1 the string value of test. So sure enough, you guessed what this will do. We'll now have Tony, we'll now have test, then we'll have 4.2 and 10. Yeah, notice how we're extending the length. Notice where we are inserting exactly where we want to in index position 1. And notice how the other values are just sliding off to the right. 4.2 had an index of 1 when we started. Now the value of 4.2 has an index value of. Did you ask yourself this question when you were playing with your lists in the previous video? Did you ask yourself, could I have a negative index reference? And what would I use that for? Well, let's go ahead and answer that question in this video. Yes, we can have negative indices. I don't think this would show up in your exam, but you never know. And we certainly want to be aware of this in case we were to see it in code. You would want an explanation for this. So here we are in the idle shell, and let me just go ahead and create a quick list for us for demonstration purposes. So how about we do this, and then in our list we will have that, and then in our list we will have the other thing. So this, that, and the other thing is inside of our list. And let me use consistency there to distinguish our strings. And we're going to just close that up with the square bracket. So here we have our list. And what I'm going to do now is I'm going to use a negative reference for an index. And I'm going to do one of the ones that is fairly popular. It is -1, because -1 does a very specific, neat thing for us. So I'm going to print my list -1 for the index reference. What does this do? Well, the -1 will go to your list and it will print the last thing in your list. Isn't that great? We don't even have to know how long the list is. Yeah, we don't have to know list length at all. We just say my list -1, and we will see that it gives us the last object in the list. By the way, when you're testing a feature like this, I now want to see what -2 would do. So if I do a Control P on the keyboard, I need to do a, let's see, Alt P in Windows. Nope, that's not it. How about Command P? That's the one. Yeah, it gets confusing moving back and forth between Linux, Mac, and Windows like I do. But anyways, we just solved it. It's Command and then the letter P. And notice what that's doing for us. Underneath the shell menu, notice previous history is Alt P, and that's enabling us to bring up quickly that previous command. This can really help us when we're testing a feature. All right, so now we're going to try -2, and sure enough, it's going to return that. So notice we're just cycling backwards at this point through the index of the list. Let me do another recall of that command. Let's just confirm with the -3. And if you're anxious to see an error message, yeah, we could cause that. Notice if we ever go out of range with our index, we will be called out for that. And notice the index error is quite specific to let us know that we're out of range. So negative indexes, sure, they're possible. They enable us to walk backwards through our list. And remember, kind of a clever one is the negative one to always be able to get that last element. Well, you knew it would happen. You knew that loops and lists would go together nicely. In this video, we're going to take a loop at for loops, and we're going to see some examples of how they can be used in conjunction with lists. To get us started, we are going to use a for loop in two different ways to populate a list. Yeah, and we should pause for a moment and reflect on that fact, shouldn't we? We haven't covered this with you yet. I don't know if you thought of this on your own, that you could do this, but yeah, pretty neat. You can start a list as empty. So all we do is just set the myList variable name equal to the square brackets with nothing inside. Yeah, that creates an empty list for us in Python. And then look what we're going to do. We're going to do a nice for loop with the range set to 10. Now remember how this is going to work. That's going to be a range of 0 through 9, isn't it? Now notice what we do. We use that append method that we learned about in the previous video, and we're going to go ahead and append the value of I plus 1. So what would be the first entry in our list? It would be 1, the number 1. Yeah, because initially I will be set to 0 in the loop. So we'll start numbering at 1, and I do believe it will go to 9 when we print the myList variable. All right, let's go ahead and run this, and let's confirm it works just like we thought that it would. And it does. Look at that. So we have just used a for loop to populate a list. How cool is that? Works perfectly. Oh, by the way, it goes up to 10, right? Because we know the range stopped at 9, but we're adding 1 to that. Yeah, so we start at 1, we end at 10 using the approach that we just did. Now, I've got another example for you. This is fun. That was our look at the append approach. What if we used an insert? Yeah, what if we used an insert approach? Let's take a look at that. Here you can see we are once again creating an empty list named my_list. And then we do our for I in range 10 again, but this time notice we are doing the insert method. And we're saying start at the index of 0, and then what are we going to put in that location? Well, it's our I plus 1 once again. So the first value is going to be 1. Then the next value is going to be 2. So think about it, using the insert method like this with the index of 0, we should see that the list is in the reverse order when we print it. Yeah, think about it. The insert method here will actually reverse the order. By the way, once again, we'll start at 1 and end at 10. Due to the logic of how the for I in range works and the way we are incrementing that value. All right, we're going to go ahead and run it, see if it works as we suspect, and sure enough, it does. We have our list, and the list is populated with the integers 1 through 10, this time in reverse order. Fun little thing to exercise to get us thinking and to, recall how our for loops work as well. This is all such great review. Yeah, great review of append and insert along with our for loop logic. Okay, now what if we wanted to do something with a pre-existing list? Can for loops help us out there? Sure. What if we want to, for instance, add all the values in a list? Yeah, being able to enact some operation on everything in a list is clearly going to be very valuable for us. So let's go ahead and grab another example here that I've got for you where we will take action on all of the entries in a list. Notice we begin by providing the list, and I just put together some random values here, 10, 20, 1, 4, 3, and then we declare a variable called total and set it equal to 0. Then what we do is we do something clever, and I'm going to tell you right now that there is an easier way to use a for loop to add up everything in a list. So there is an easier method that I'll show you next, but I just wanted you to see this cool concept where we say for I in range, and then notice what we set the range to. It's the length of our list. Yeah, notice how we can use the length of our list in various locations, and that way we don't need to hard code it, right? It can be dynamically obtained, that length, when our list is populated, let's say, dynamically. So pretty neat that we can use that value like that. And then notice what we do. We take our 0 total and we're adding to it the my list entry, and we're using the I as the index. Yeah, index 0 is 10. So 10 is added to 0, and then 20 is added to 10, and then 1 is added to 30, and then 4 is added to 31. You get the idea. So it's going to add up everything in here for us, and using this for loop approach. So let's see if this works. By the way, what is the total that we should see? It should be 10 plus 20 is 30, plus 1 is 31, plus 4 is 35, 38. It should be 38. Let's run it and see if it works. It works perfectly. Great. Now, I told you that we wanted you to see this particular example. I wanted you to see this, like how we can cleverly use the length of the list here, and how we can cleverly substitute for the index in our list. But if we need to add up everything in our list, there is a much easier and more direct method than this. I'm glad you saw these kind of neat things about this approach, but now let's just look at how this would be very easily accomplished. Yeah, notice we give it a list. Once again, we set the total to 0, but all we need to do is say for I in my list. Go ahead and add to the total the element from our list. Cycle through those. Isn't that neat? So it goes in and it says, okay, the first thing in the list is this object of 10, and then it goes and increments through our list. So this is a direct and real easy way where we can add everything up that's in our list. Yeah, that's if it works. Let's go ahead and run it and look at that. It works great. So for loops and our lists, yes, they go together like the great philosopher Forrest Gump once said, they go together like peanut butter and jelly. Thanks so much for watching. We've got more great content for you on the way regarding these amazingly simple to use and very powerful structures called lists inside of Python. You know what we might need to do with one of our lists, or several of our lists? Yeah, we may need to sort them. Yeah, think about that. Let's say we have a list of a bunch of integers, all in a random order. It is conceivable in our programming logic we would need to sort those. Turns out there's a couple of different ways we can approach this. For example, what if we just want to see the elements of a list sorted? We don't want to change the actual order. Yeah, let's play with that. We can do that. I can say numbers, for example, a numbers variable, and I can fill it with all of these integers. Notice I am intentionally ensuring that they are not in order. So there is our list. Now, if I wanted to print this list sorted, for example, all I need to do is use a function that we have called sorted. Yeah, that will sort any list, and it will leave the original list just the same. Oh gosh, you gotta love that. So notice I say print sorted and our numbers variable, and it will do the sort for us. And now let's prove that our original list has not been impacted, and look at that. If we print the original list, you can see the entries, the objects, are in their original order. Pretty neat. So, the sorted function. Please note when you are practicing this, don't forget your double closing parens there. Yeah, it can be very easy to forget that additional closing parens that you need because, of course, we need parentheses for the print function, and then we need parentheses around numbers inside the print function. We're doing a function in a function there. Yeah, so just don't forget the appropriate number of parentheses. Okay, but I know you're curious, how can we sort the list permanently, in effect? Yeah, we want it in a new order in Python's memory. Okay, no problem. What we are going to do is we're going to use another method, and the method is sort. Yeah, so I can say numbers sort, and notice if you wanted in reverse order, you could specify that. So I can say reverse the order is true if I wanted to, and this will sort in reverse order. Obviously, if you don't want the sorting in reverse order, you would just do nothing like this. So let's try this and then we'll try the reverse. How about that? So I just did the method sort against my numbers list. Let's go ahead and let's do that. Whoops, I always hit the wrong button in Windows. Let's do that. Control P, or in my case in Windows, Command or Alt P to bring up previous commands. And let's print the numbers now and look at that. The sort method of our list did exactly what we wanted it to do. Now, we have one more thing to test here, and that is to sort in the reverse order. So we're going to say reverse equals true, and we are going to run this, and then we're going to print numbers again, and look at that. It worked beautifully. It sorted them in the reverse order. So, two things we learned here, really important. There's a sorted function that we can use to just display the list in order. And then there is the sort method of a list that can, quote unquote, permanently do the sort. Now, notice these methods of lists. Yeah, we've seen like append, insert, now we've seen sort. There's a bunch of other great methods that we can use with lists, and I'd like to show you some of those, as well as how to look. Now, earlier in these videos, we took a look at some of the powerful methods that we could have with our lists. Do you remember this? Yeah, we learned about the insert method. We learned about the append method. Well, there's plenty of other list methods that you can utilize, and let's just pause for a minute and make sure we understand that and where we could look them up. So I'm going to go ahead and fire open Google, and I am going to indicate that I want to do a search at onlypython.org, and I want to search for list methods. Yeah, this is a great way to do a search of a specific website, and oftentimes it's going to be more efficient than maybe a non-Google search mechanism that the website has. But anyways, yeah, don't forget this trick. It can really help you out at times. And look at that, it did great for us. It brings us right into the data structures area of the documentation. And look at this, it brings us right to these additional methods. So notice here is the insert method and its documentation that we saw before. There's the append method. Whoops. I just hid the table of contents there, no big deal. So there's the append method. Notice there's an extend. Extend the list by appending all the items from the iterable that we provide. So there's remove. Remove the first item from the list whose value is equal to X. There's pop, which is to remove an item from a specific position. So if you don't give a specific position, it'll take the last item from the list. Yeah, it pops off that last item. How about getting rid of everything? Clear. There's a count to count up how many times a certain value appears. There's a reverse, there's a copy, you get the idea. So lots of methods with your lists, and this is how we could easily consult the documentation on these various methods. Now let me show you something else that I want you to be aware of when it comes to methods in Python. We can actually have them appear inside of idle. Yeah, watch this. Very handy. So I'll do the classic my list here to create a sample list, and I'll put a bunch of stuff in it like we like to do. And then let's say I want to manipulate this and I can't remember all of those various methods. What I can do is say my list and then put in my period and hit the shift button on the keyboard in Windows. Yeah, so it would be shift in Windows. I think it's shift 2 on the Mac. But anyways, notice you hit the right key and it brings up the list of possible methods. Yeah, so one of them we saw was count. And if you remember, all we have to do with count is put a value in there that we want to count. Let's do the value of 10. So there we go, my list count 10. And I'm thinking it should respond with 2. Yeah, the number of occurrences of the integer 10 in our list. So these methods are very, very powerful, and you now know how to get more information on them. I'd like to wrap up this video with just a little word on the difference between methods and functions. Yeah, that'll kind of drive students crazy sometimes, I notice. They're very, very similar, aren't they? Like, here's an example of a function. I'm going to print my list. And the deal with a function is it's available to an entire Python program. But notice a method is private to that object that it is working on. Yeah, so we are doing something against my list specifically. Yeah, that's what a method is all about. And we'll have lots more to say on this later on when we start talking about object-oriented nature of Python and things of that nature. But just wanted to once again kind of make that clear. Yeah, those methods do look a lot like functions. It's just they're very different from functions in that they are private to that object that they are directly associated with. Well, all right, everyone, we've got, believe it or not, we've got lots more fun to have with these lists in Python. I hope you'll join me for the upcoming videos. You know what topic we have not covered yet at all with lists when you think about it is how do we identify a slice of a list, a portion of a list? Yeah, this is easy to do. It's called slicing. And I'm going to show you this, but before I do that, I want to show you one of the reasons slicing may be so handy. Yeah, let's take a look at something interesting in Python, shall we? Specifically, what I'd like to show you is that the lists that we define, they work a little different than variables. Yeah, let me prove this. Let's create a variable a, and let's set it equal to 10. Now what I'm going to do is create a variable b, and I am going to set it equal to the value of variable a. So you would agree variable b is 10. Now what I'm going to do is I'm going to change the value to 20 of variable a, and I'm going to print variable b. What do you think is going to happen? Well, we would certainly think that variable b is still set to 10, and that's exactly what happens. Yeah. But lists work a little differently. Lists are names for a space in memory, and they function differently from the behavior we just saw. Let's prove this. I'm going to go ahead and create list A. And list A will consist of the value of 10. I'm then going to create a list B by setting it equal to list A. And then what I'm going to do, you guessed it, I'm going to say for list A's value at the 0 location in its index, go ahead and set that to 20. So we are going to now print list B, and just like before, we would expect it to be at its original value of 10, but no, sure enough, it is at 20. That's right, list B is identical to list A. That's what we said, and it's going to follow the manipulations of list A that we do. Pretty interesting, isn't it? Yeah. And this is where we might need to take a slice of a list in order to create a new list that is in of itself totally unique. All right, let's go up and let's do this. Let's restart the shell so that we can make sure everything that we did is all erased, if you will. And now let's go ahead and teach you how to slice a list. And I'm going to teach you at the same time how to make a new copy from this slice. Yeah, an independent copy, because that's how slicing works. All right, so let's go ahead and create another list A, shall we? And this list A is filled with all kinds of fun integers. La-di-da-di-da-da-da. Realize I'm doing this for, brevity, right? We could get all fancy with the contents of lists, but when you're experimenting with them and learning about them, no need to get all fancy. All right, there's our list A. Now I want to create a list B that is a slice of list A, and I want list B to be independent of list A. So what I'm going to do is I'm going to say, okay, list B is going to equal list A, but we are going for just a slice of list A. And the key element here is a colon. Yeah, that's right. You indicate the index number you want to start your slice at. So I want to start at index number 0. That would be the 10. And let's say I want to go up to, let's count, 0, 1, 2, 3, 4, 5. If I want to go up to 5, I have to give the index of 6. Yeah, because it's non-inclusive. So notice what we're doing here to create the slice. It's the starting index number and the ending index number non-inclusive. Yeah, so we expect this slice to be the 0 index, the 1 index, the 2 index, the 3 index, the 4 index, and the 5 index. So we should expect our slice to be everything but the value of 10. All right, well, let's see if we print our slice, and that is list underscore B. Yeah, got a little confused there on my variables for a minute, but we want to print list B. And did it work? It worked perfectly. Yeah, look at that. It worked perfectly. Let's create, and by the way, it is independent. Yeah, remember, it is independent. If I want to see list A, I can go ahead and look at list A and notice it is completely unchanged. Yeah, because we created list B from a slice of list A, they are now truly two independent lists, just like I'm thinking you wanted in this exercise. Okay, now let me show you some other fun things about slicing. What if you wanted everything? Yeah, what if you wanted an exact copy? Well, let's try it. I'm going to go ahead and say list C is equal to list underscore A, and we are going to create our slice. And if you want everything, all you have to do is just give the colon. Yeah, you omit the starting and the end values. Let's see how we did. Let's print list C, and look at that. It is truly everything. Now, here's an interesting challenge for us. In this slice up here, we did 0 through 6 for the index, and we know that gave us everything but this last value of 10. Wait a minute here. How do we even include the value of 10? Think about it. If I list 0 through 7, 1, 2, 3, 4, 5, 6, 7, the problem is it won't print the 7. It won't include the 7. Yeah, 0, 1, 2, 3, 4, 5, it's 6. Okay, I counted wrong. That's right, I counted wrong. So if I say 0 to 7, that's probably going to give us an error message. Do you see the problem? There is no index 7. Let's try it. List underscore D is equal to list underscore A, and we are going to say 0 to, what do we want to do? I keep getting confused. Oh, we want to try 8, right? 0, 1, 2, 3, 4, 5, 6. No, we want to try 7 to try and get it to include that last value. All right, let's print list underscore D. And look at that. Surprisingly, it doesn't give us an error message. It just works. Weird. It's not an elegant way to do this. No, because there is no index of 7. Yeah, so we wouldn't want to put that in code. How you would properly do this? Watch this. It's so easy. Let's do a list E, and list E is going to equal to list A, and for the index, you would just go start at 0 and leave off the trailing index. Yeah, that's telling Python he wants the last index in the list. Another way to do it is pretty neat. Remember, we had those negative indexes that we could use. And remember that one of the negative indexes that we loved was -1, because that always stands for the last index value. So sure enough, we could do that as well. So let's print list F, and Oh, that's funny. I'm so glad we tested this. What does it do? It goes to the last index value, but of course that's not inclusive, so it gives us the value before that one. Oh my goodness. So what's the elegant way to include the last element in the list? Yeah, we saw it. It's to not reference the ending element in the list. So notice, these take some playing with. Slicing definitely takes some playing with it so that you can get the practice that you need with this interesting feature. Okay, I want to show you one more example. Are you ready for it? Let's go ahead and see what happens if you were needing to increment. Yeah, we can increment. So I'm going to create a list A, B, C, D, E, F, G. How about a list G? And we are going to set it equal to list A. And this time we're going to say start at 0 and go ahead and end at, we'll end this one at, I don't care. How about we end it at 0, 1, 2, 3, 4, 5, 6. We'll end it at 6. And notice we do a colon and I could say 2, and that is our increment. Yeah, in other words, we are going to grab every values from the list every 2 increments. So let's go ahead and print our list G. And look at that. So notice we were starting at index 0, which was 10. We were going up to index 6, and that's 1 less than index 6. So it's 0, 1, 2, 3, 4, 5 is the last index that is printed. And then we incremented by 2. So it got the 10, it skipped 2, it skipped 20, and then it grabbed the 30, and then it skipped 10, and it grabbed the 2. So it is counting by 2, if you will. All right, so that is slicing lists. Remember, we learned a lot in this section. The first thing that we learned was lists don't function like variables. No, lists are locations in memory that we are describing basically with the variable name. We saw how copying them doesn't work like you might suspect. And then we saw how you can create new lists from slices of existing lists. And we reference a starting index number and an ending index number. If we want to get everything, we can just use the colon. If we omit either the start or the end, it will assume we wanted to go all the way to the end of the list, and that would be inclusive. And we saw -1 is the last entry in the list, so it would go 1 before that one. And then finally, we saw that you can not only specify the starting and ending of your slice, but you can also skip entries as well. Well, thank you so much for watching, everyone. Fun with slices, and I love it when we learn additional material as well as we did in this episode. Well, I know it sounds crazy, but we're not done with lists yet. Please join me for more videos on this very powerful structure in Python. You may have been thinking about this right when we showed you lists inside of Python. Sure, and that is the ability to check if some value is in or not in a list. Yeah, let me show you a very simple example of this. So I've gone ahead and created a list called authorized users. Yeah, our auth users list. And you can see I've put the string values in there of some usernames. So sure enough, I ask the current user to input their username. And then I have a simple if-else construct that says, if the current user is in, and notice there is our in statement that we are so excited about when it comes to list. If the current user is in the authorized users, we're going to print out welcome to our amazing application. If they're not, we have an else statement. So sorry, access denied. So notice in and not in going to be very easy to work with our lists. Let's go ahead and make sure this actually works. And so please enter your username. I will do one that is on the list, and we are welcomed to the amazing application. Of course, when you're debugging something like this, you would always run it again. And this time you would want to do, some random username that is not on the list to ensure access is denied. Now, as I said, there is the in statement, but don't forget, there's also not in. So let's play with that real quick. So notice I say not in, and notice the colorization here helps me to know that not in is a valid statement that I can use. So that's so neat. So here I'm saying if the current user is not in the authorized users, let me just go ahead and grab this and copy it and paste it right here, because that's what we would now need to say in that logic. And then the else is going to be something like welcome. Yeah, so we've just kind of reversed the logic here because now we are focusing in on the not in operator. So we'll do a file save. We'll go ahead and run this, and we will do one that is not in the list. Excellent, access denied. And we've got one more test to run, and that would be one that is there for us. And there we go. We are welcomed to the application. So I love it. You probably, again, have been thinking about this quite a bit. If you have a list, isn't it going to be very critical that we have the ability to see if something is in or not in that list? And these operations are returning true or false statements that we can easily incorporate into things like if-else logic, as we have seen. Well, we're not done with lists, believe it or not. I bet I know what you're thinking. What in the world is a list comprehension, and why do we call it that? Well, let me just define this for you. In Python, a list comprehension is a way for you to easily fill a list with its contents. Why it's called a comprehension is a nod to mathematics. Yeah, in the study of mathematics, there's something called a set comprehension. So anyways, yeah, a very interesting name, but what we're talking about is, as I'll show you, a really easy way to completely fill out a list. So let's take a look at a file I have here for us where we do it a roundabout way. Yeah, this is not doing a list comprehension. I'll show you that in a minute, but this is a roundabout way of filling up a list. Yeah, think about it. I create an empty list, and then to complete that list, I use a nice for loop. I say for I in range 8, take my list, and let's use the append method, and let's fill it up with the integer of 10. And then let's go ahead and print this. Yeah, so that should work, right? It should append the integer 10 in our list 8 times. So let's see if this actually works. And sure enough, it does. So yeah, when we print the list, it has those 8 occurrences of the integer 10 inside the list. But my goodness, that's kind of a lot of work, isn't it? It just seems like Python kind of intuitively you think, well, do we really have to create the empty list and then fill it in such a kind of crude manner, if you will? Well, sure enough, we don't have to go through all of this. What we are going to see is now the official list comprehension way to do it. That is in another file. Let me go ahead and open that right now. There it is. It's my comp2.python file. And yeah, here it is. Look at how succinct we can do this. And I give you 2 separate examples here. So I think we had 4 lines of code before. Now we only have 2 lines of code. So I have 2 examples of this in here for us. Yeah. So notice what we can do. We don't have to create an empty list. No, we can just directly say, all right, my list is going to be equal to, and we have our for loop language right inside what would be your list. How cool is that? So in this example, I take the string test and I place it in the list 4 times. And then in this second example, we go ahead and take 2 raised to the power of I, and then for I in range 8. So this should give us 2 to the 0. It should give us 2 to the 1. It should give us 2 to the 2. Yeah, for those that have studied like binary in terms of TCP/IP addressing in the network field, this is going to print for us the decimal values for binary bit positions. Anyways, you can just see the point I was trying to make to you is that we can do math as well in here when we are generating the list results. So this is really great, isn't it? Yes, list comprehensions allow us to do our for loops right inside the list in order to create their contents. And as always, we better make sure this works. So what do we expect to see? We expect to see my list printed, which would be a list of the word test 4 times. And then we should see 1 through 128. Yes, because again, we're going to get 2 to the 0, which is 1, 2 to the 1, which is 2, 2 to the 2, which is 4. So those are the values we're going to get. Let's run this thing and look at that. It works just as we would have expected. There's our first list, and it's filled with the string test 4 times. Then there's our second list we created, and it is filled with 2 to the 0, which is 1, all the way up to 2 to the 7th, which is 128. So, list comprehensions, a powerful, very simple method that we can use to fill our list. Yeah, that's right, to fill the list with values. Well, I know, you may be having a little list fatigue at this point, but I've got great news for you. We have one final video. I think you're going to love it on lists. That'll be next. And then we'll be turning our attention to our next topic, which I believe is tuples. Fun to say. Yeah, we'll look at tuples as part of our data and Python module. Thanks so much for joining me here. And well, I certainly hope you've been enjoying our videos dealing with lists in Python, and we're going to wrap up. I know, you're upset about this. We're going to wrap up lists for right now by taking a look at using a list to build a matrix. Ooh, that's right. What are we talking about? We're talking about a grid. Think like a chessboard. Now, before we get into this, I need to remind you of something. Let's jump down to the Python shell and let me remind you of something. A list can be a container for absolutely anything, including another list. So look at this. We have a list inside of a list here. It's 10, 20, 30 in that list. And of course, I can have another list in this list. How about 40, 50, 60? And of course, I could keep going. Sure, so a list can contain other lists. Now, how do we reference the specific value out of a list? Well, we're still going to use an index. Sure, so you can play with this. You can print my list and you can play with the index. For example, I think 0, 0 for the index would be this list here. That's the first 0 index. And then I think 10 would have this second 0 index. So I think this is going to give us 10. And that's exactly what it does. So how would we get, let's say, the value of 50? No problem. this is index number 1, and inside there is the index number 1 as well. Yeah, 0 is here, 1 is here. So I think if we do this print over again, and we change this to 1 and 1, I think we're going to get the value of 50 returned. Yay! That's how easy it is to use these multiple index designations to locate right where you are in your list structure. Okay, so now that we've got this, let's think about the overall point of this video, and that is to be able to construct a matrix in Python. Well, that's going to be none other than a list of lists. Sure, think about it. We have this top row here of the chessboard, row 8, and we can think of row 8 as our list and then a list below it. Yeah, row 7. In fact, when chess folks are talking about their moves, they have a letter and number system like you see here. So notice they are using 2 index values to describe their moves. Sure, they're saying the pawn will move from A2 to A3. Or I think they just say the pawn moves to A3. Yeah, because it has to be that pawn that makes that move. By the way, I'm no chess master. I don't even play chess. I think I played chess like 3 times in my life or something. So anyways, but isn't this neat? Yeah, they're using 2 index values to describe that location. And notice we end up doing the same thing in Python. Okay, you want to see how easy it is in Python to create a chessboard matrix? Oh my gosh, incredibly easy. Let's pull that up. Let's get back to our idle shell here and let me open my chessboard Python and look at how easy the chessboard is to create. 1 line of code. And that's because of our list comprehension feature. And notice I'm having a little fun. I'm nesting 1 for in another for loop. That is how we can create the whole chessboard in 1 line of code. What I do notice is I create a row with this line of code right here, and each cell, if you will, in the row has nothing, just an empty space in it. So here is an empty row, and then it's nested inside another for loop that creates 8 of those rows. How clever. Yeah, so a loop in the list comprehension to very quickly create our matrix of 8 rows, all filled, of course, with the blanks. And of course, I print that, and then obviously you would, if we were programming a chessboard, we'd need to like put the right pieces in their places. So how about those rooks, those castles that are in the corners? Yeah, the corners of our matrix would be 0, 0, 0, 7, 7, 0, and 7, 7. Yeah, those would be those corner pieces. Now, when you run something like this, it looks awfully ugly, but if you look close, it works. It's just not aligned, right? It's not aligned. But look at this. Here is, I've just highlighted it. Here is the chessboard with all the blanks. Yeah, it's 8 rows of blanks that we constructed. Sure. And then look at this. Here it is with the rook in their, the rooks, I should say, in their appropriate positions. And isn't it neat? Even not properly lined up, you know, even not with formatting on this, you can really see that these are correct. You know, there's the top corner rook, there's the other top corner rook, and then here's the bottom left rook, and here's the bottom right rook of a matrix inside of Python. And again, it really is worth looking at one more time just how simple it was to create that matrix thanks to list comprehensions and a little nesting of our loops. So lists, oh my goodness, they're incredibly flexible and powerful, as we've seen in a whole bunch of videos dealing with these lists. Well, not as complicated, but certainly important are tuples. And I hope you'll be joining me. And we are going to jump into a discussion of the basics of tuples. And it is, I chuckle every time I say tuple. I don't know why. Anyways, it's great that it was placed here where it was in our curriculum because let's remember lists. I know how you love them. So here is a list, and it is very similar to a tuple, except there's a big difference. With a list, we can go in, as you know, and we can change a value in the list. Here is me manipulating the first value in the list, and now I will print the list, and you will see, of course, that we manipulated the list. A tuple is just like a list, but you cannot manipulate it. That's right. So in the case where we want a list, but we want it to be read-only, we would create a tuple. So let's take a look here. My tuple. What we like to do is use parentheses in a tuple. So I'll do the 10, 20, 30, 40, 50. Hey, you might be wondering if in a tuple you can mix and match your objects like we could in lists. And yes, you can do that in a tuple as well. So there is a tuple of that same sequence, and it uses the index numbering. So if I were to say, okay, I want to manipulate the first value in the tuple, and I want it to be, let's say, 5, Python says, wait a minute here, tuples don't support that. Yeah, they are read-only. Now, you can create a tuple without the parentheses. I personally would never do this. So notice we could go in and we're creating a second one here, and I'll do something different with it. I'll go up to 60, for example. Notice no parentheses, but it's still going to work. Let's go ahead and print that thing. And does it give us the parentheses when it prints it? Yes, it does. I would definitely use the parens when creating a tuple, personally. In fact, it gets really weird if you want to create a tuple and you only want one object in the tuple. Yeah, if you don't use parentheses, it looks really odd. As a matter of fact, to truly create it, you need to do a trailing comma like that. Yeah, if you just did this without the comma, you're actually creating a variable. So yeah, I definitely like parentheses. And please note, with the one object in your tuple, let's see, do we still have to use the trailing comma there? I don't think so. Let's see if this tuple is just fine. We would definitely have to do that, of course, if we weren't using the parentheses. But remember, I don't really, whoops, I just totally made a mistake. Let's, you know what? I'll go ahead and just restart the shell. That's fine, because I'll try this again. So my tuple 3 equals just one object inside it, 3. Yeah, this is going to work just fine. So we're going to print my tuple 3, and no, I take that back. Look at that. It is not a tuple. So I'm so glad we did this little exercise. We need to have that trailing comma even, oh my gosh, I'm trying to bring up the last command I did there. We need that trailing comma for sure. So it would be my underscore tuple underscore 4, for example, and we would have the one object inside it. And to truly make sure that it is a tuple, we need that trailing comma for that one object. What else did I want to show you in this video? Well, sure enough, you could do this. You could create an empty tuple. That's right. And you would need to create it, obviously, with the open and closing parens. So I think that's going to do it for this introduction of just the basics on these tuples. Again, so much like a list, aren't they? Except notice when we go to modify the tuple, we would get an error because that flies in the face of what a tuple is all about. Yes, it is like a list, but it's a list that cannot be modified in the programmatic logic. Thanks so much for watching. Wait a minute now. In the last video, we taught you how to create tuples. So what's going on in this video? Well, I struggled with the title, but what I wanted to show you was a couple of different ways that we can create tuples. And the first one is a review. Yeah, it's slicing. Yeah, we can do the slicing that we saw with indexes. And this is a big deal with tuples, isn't it? Because we know that a tuple cannot be changed. It's what we call immutable. Yeah, it can't be changed. So here is this sample tuple, and this tuple we know can't be changed. So what if we want to create, some other tuple based on this one? Yeah, that does have modifications. Yeah, we can do slicing. So I would say my tuple 2, for instance, is going to equal my tuple, and then do your slice. And the exact same slicing rules apply. So I could say start at index, and I need square brackets. Start at index 0 and go up to index, let's see, this would be 0, this would be 1, this would be 2. So let's say we wanted to just capture the 10 and the 20. We would go ahead and give the index of 2 because it actually slices 1 before that one. So there we go. I'm going to go ahead and print my tuple 2, and let's see our result. It worked just like we thought it would. We now have the my tuple 2 with the 2 values inside of it. So slicing works just like it does in lists. And in fact, there's a lot of features that we covered in lists that work fine with your tuples. Yeah, things like in or not in, those comparisons that we do to see if something is in one of our lists. Yeah, we can do that kind of stuff here. But there is another way to create a tuple that I wanted to show you in this video. I think it's pretty wild. Watch this. I'm going to go ahead and create a list, and this list will consist of these values. Sorry I'm such a bore, but it's just really easy for me to quickly create lists using the whole 10, 20, 30, 40, 50, 60 thing. So anyways, there's our list. And sure enough, if we wanted to convert that list into a tuple, we have a function for that. Yeah, so I can say, give me a tuple, please, out of my list. Look at that. And Python says, yeah, no problem. And now I'm going to print my tuple. And what do we got? Yep, it did just what we asked it to. It took our list and it created our my tuple variable from the not variable. It created my tuple out of the list, my list. And guess what? You can go the other direction, just so you know. So you could have a tuple and you could use a list function to create a tuple out of the list. Yeah, so it works in both directions. Have you noticed what one of the great things about studying Python is? It's that not all the topics are at the same level of difficulty. Yeah, I mean, some of this stuff is pretty simple and straightforward compared to other more complex topics, and that makes studying it kind of nice. It's not like it's all hard. So let's take a look at lists inside of tuples, like we said we could do. This is going to work just as you would think it would. And don't forget, you could always put tuples inside of lists, which will be intuitive after we walk through this. So, okay, let's go ahead and create a tuple right now, the classic my tuple, and it is going to consist of, how about the integer 10? You knew I was going to do it. And then how about a list inside of this tuple, and the list will be 20, 30, 40, and then we need to close the brackets for that list. Then we have a comma, then we have 50 and 60, and then we'll end this thing. I'll get rid of that extra space just because I'm particular like that. I want it to look as consistent as possible. Anyways, yeah, there you have it. Notice how the index of 1 is going to apply to this list. Now, sure enough, this is going to work just like you think it would. And what I mean by that is we can't modify this value. We can't modify this value. We can't modify this value, but lists can be modified. Yeah, a list is mutable. So we can manipulate a value inside of the list. So I could always say my underscore tuple, and then I could give the appropriate index. It would be index of 1, and then the sub-index, if you will. Let's manipulate the value of 30 and make it 25. So that would be a index of 1 inside that list itself. And so we're going to say inside the my tuple, we've got this list, and we're going to manipulate a value inside there. And as I said, we can set it equal to 25. All right, so notice it accepted this command. This is telling me, oh my gosh, yeah, we can go in and modify. I mean, we didn't get an error message. Watch this. If I went in and we set this to 0, and we set get rid of this, so we just try and go in and change the value in our tuple of 10, yeah, we are not going to be permitted to do that. Okay, but my gosh, did this work? We never even verified it. So let's print my tuple. And I think we're going to see that it did indeed work. Look at that. So inside the list, inside the tuple, we were able to make a modification. But as we proved when trying to modify this value in the tuple, that is just not going to work. Remember, the fancy language for this, can we change things or can't we change things? Remember the fancy language. So this list, its contents is what we call mutable. We can change it. These values in the tuple, they are immutable values. We cannot change them. Well, thanks so much for watching, everyone. And guess what? It's time for us to tackle another data structure in this section. It's time for dictionaries. And yes, a dictionary is just what it sounds like. Oh my gosh, it's early for me. I'm recording this much earlier than normal. So sorry, my voice may be a little harsh, but I'll keep drinking this coffee next to me in order to get through our episode in Dictionary Basics. Yeah, I just realized you probably don't know, but I'm kind of an evening YouTube maker. But we're mixing it up today. Let's talk dictionaries. And my gosh, what's wrong with me? You know, we're halfway through this course at least, and I haven't been attentive to your eyes at home, have I? No. Let's go into the settings here and it might be a little different than where we would find them on the Mac. So just one moment here. I want to look for the overall settings, options, configure idle. Here it is. And notice on the highlights tab, we can do a dark theme. Come on, Anthony, change the mode of your idle shell. All right, here we are in the dark mode. But that's not really what we're here for. We're here for, of course, to talk about dictionaries. So let's go ahead and take a look at what a dictionary is, why don't we? Yeah, so let's jump in and pull up an example that I've created for us today on Dictionary Basics. And notice I didn't want you to have to watch me type. So I built these dictionaries, on my own time, so to speak. Notice I create an English to Spanish dictionary. So there's our variable, English_Spanish. And what's it going to store? It's going to store a dictionary. And I did this example first because notice a dictionary is just that, a dictionary. So English to Spanish, dog is perro, cat is gato, and mouse is raton. And I'm very proud to say that I came up with that out of my head because for whatever reason, I remembered those definitions from my high school Spanish class. All right, how about phone numbers? Notice I have a string for what we call the key here, and then I have this big integer for the value. And that's really what a dictionary is. It is a listing of keys and values, a key and a value. Notice we can create an empty dictionary, and then we could fill it with definitions, of course. And notice here's another way to create a dictionary that a lot of people like to do because it's easier to read. So notice this is called hanging indenting. I create my variable and set it equal to the open curly braces that we use with our dictionaries. And then I give my key value pairings, and then I close the dictionary. So that's perfectly valid way to go. And then how about number dictionary? Yeah, I just wanted to show you that, there's no strict rules here. So here my key value is 10, 20, 30. Those are my key values. And my actual values for those keys are listed. Now, by the way, one more thing. I'm sure you've noticed very specific syntax here, right? We use a colon between a key and its value, and we use commas between the key value pairings. By the way, notice that dictionaries aren't really about order. Yeah, when we were dealing with lists and we were dealing with tuples, those are what we call sequences, where you're going to have these values in some specific order. Dictionaries aren't really like that. Dictionaries, sure, we could order them, we could manipulate them, but the whole idea here is it's not necessarily a structure we're going to iterate through. It's a structure we're going to go and look something up inside of. Now, with that said, I will teach you how to iterate through dictionaries, and we can do that, but it's not their primary function like we have with sequence type data like our lists and our tuples. Okay, now, how would we look something up here? Well, how about we do a simple print, and I say, we can pick any one of these, right? How about we pick the English-Spanish dictionary? So I'm going to say print English_Spanish, and sure enough, in brackets, we're going to specify the key. And notice the key is case sensitive. So in order to print the dog value out of the English to Spanish dictionary, I put dog in square brackets, and guess what? Dog is a string, so I'm going to need to remember to include the string characters. So case sensitive, and it must exist inside the dictionary or we would get an error. I repeat, the index or key value that you're looking up must exist inside the dictionary or we're going to get an error. So let's go ahead and save this thing, and let's go ahead and run it, and we should see it prints Pero. Yeah, it worked perfectly. So the dictionaries were created perfectly with all this code, and we were able to do a lookup in the dictionary. Okay, now wait a minute. We just mentioned that the key value that we're looking up must be in the dictionary or we are going to get an error. So we're going to need a way to guard against that type of an error, certainly. And boy, oh boy, that's not hard to do, thankfully. And it's not hard to do because we have the in and not in operators that you might fondly remember. So let's go ahead and pull up another example here. I'm going to go ahead and open another file that I created for us. Let me just find it here quickly. And that file is going to show you how easy it is to deal with the lookup in a dictionary to ensure what we're looking up is actually there. All right, here we have it. The English to Spanish dictionary. It's the same exact one I created a moment ago, our dog, cat, mouse. And this time we say to the end user, go ahead and give us a word. Yeah, so we have a word variable, and they are going to have presented to them, enter an English word to translate to Spanish. And then notice what we do. I'm previewing our next section of content a little bit here, where we're going to be talking about strings in Python. I do a couple of important string methods here to the word that the user is going to be providing us. Yeah, I strip off any extra characters that they may have inadvertently done after they type in the word, and I make sure the word's all lowercase. Yeah, two great string methods. Those are string methods that we're doing to whatever string the user provides. Yeah, we're trimming off any white space and we're making sure it's lowercase. Then we do a simple if-else. If word is in the English to Spanish dictionary, we'll then print the value for that word. And if it's not, print, sorry, that word is not in the dictionary. So notice how it's going to be very easy with a simple if-else loop to check for that word in the dictionary. Gotta love it. So let's go ahead and run this thing. And it says, enter an English word to translate to Spanish. I will begin with an error condition. I'll say, what's the word for elephant? And it says, sorry, that word is not in the dictionary. Yeah, let's go run that thing again, shall we? And give us an English word to translate to Spanish. This time I'll say cat. I do believe, oh, and we'll even say it in uppercase. And I think our lower method on the string will convert that to lowercase. I think it'll find it in the dictionary, and I think it will tell us that the Spanish word is gato. So there you have it. Isn't that amazing? We have created a fully functional English to Spanish dictionary, and it is only involved 1, 2, 3, 4, 5, 6 lines of Python code. Yeah, we really see how powerful Python is in this dictionary example. Powerful and simple. Well, as you might guess, we are not done talking dictionaries. Welcome back to our Certified Entry-Level Python Programmer course, and it is time for us to do two things. Yeah, you have to love it when we get multiple objectives handled in one video. We're going to look at some dictionary methods that are possible inside of Python, and this is also going to teach us how to iterate through Python dictionaries. Remember, we said iterating through a dictionary is not something that you do directly, because a dictionary isn't a sequence like a list or a tuple, but as we're about to see, we can easily move through these objects, these dictionary objects, and we can do it a couple of different ways. All right, well, let's take a look at our example. First of all, notice on the very first line here, we have this simple little English-Spanish dictionary from a previous video on dictionaries. So we have our key and our value pairings. And remember, in this dictionary case, we're dealing with all strings. So we would need to note that with our single quote or double quotes. And remember the syntax we're using here, the colon between the key and the value and the comma between those entries. Okay, so notice what we're going to do here. I print the statement, here are the keys in your dictionary, and we have a clever way that we can iterate through all those keys. And sure enough, it's thanks to the keys method. Yes, our dictionary method called keys. So notice I say for key in our English to Spanish dictionary, let's use the keys function. So we're going to then print the key. Yeah, notice how simple that is. So this method is going to get us all the keys, and we're going to use a for loop to just iterate through those and print those. Sure. Now I print an empty line, and then I say, here are the values in your dictionary. And you guessed it, we have a method for dictionaries in Python that is called values, and it would get the values. So I just do a simple for loop that says for value in our dictionary's values, go ahead and print that value. Now, you might be wondering if there's a way to get all your keys and there's a way to get all your values. There's probably a way to get all of your key value pairs, and you are correct. Look at this. Here are the key value pairs in your dictionary, and all we would need to do is iterate through the items. That's right. There is an items method for our dictionary. And notice I'm saying for English and Spanish, yeah, this is the key, this is the value. Let's go ahead and print all of those. So I print English to Spanish, iterating through all of the items. So yes, we do have methods with our dictionaries, and we've seen three very powerful ones here. Keys, in order to iterate through and retrieve all the keys if you like. Values, in order to iterate through and retrieve all your values. And finally, items, where we can iterate through and retrieve all the items. Well, this is all fine and good if it works. Let's run the module. Look at that. We got all of the keys. Well, you probably knew it was going to be our final topic on dictionaries. We need to discuss how you can modify them. Dictionaries are perfectly mutable. Yeah, so they're not like our tuples. We can just directly modify them. Let's take a look. Here you can see I'm at the idle shell, and I have entered our English to Spanish dictionary that we've been working with. Yeah, so there's our 3 entries. What if I wanted to change the entry for dog? If it's mutable, the dictionary, I should be able to just directly do this, right? So I would actually say English, Spanish, and then I'd give the key of dog, and then I could modify the value, I believe. I'll give it the word perrito, which is doggy in Spanish. All right, so, and I'm not sure if I'm spelling that right. It might be a single T, and at this point in the video, I apologize to all of my Spanish speakers out there. Not sure which is right, but let's go ahead and use this to modify the entry. Let's see if this works. And of course, to test that, we can just print it. So let's print our English-Spanish dictionary. And look at that. We did directly modify the value stored in the key of dog. Yeah, so notice it's a mutable object. Therefore, like a list, we can just directly modify it. Now, what if we wanted to add a brand new item? Well, guess what? That can be done just directly as well. So I can go English, Spanish, and then I can give my new key value. How about bird? And I do believe that is going to equal in Spanish the word chica, which interestingly is also the word for girl, I believe. So context would be important there. And we go ahead and enter this. And did it work? Let's check it out. Once I hit the right command recall key, and I always forget that in Windows, as you probably remember. Anyways, let's print and look at that. It worked perfectly. Yeah, pretty surprising, right? That you can just add a new key value, and then add the new value for that key directly. Wow, so pretty interesting. Okay, but there's another way we can actually add an entry to a dictionary, and that is because we have an update method for dictionaries. Yeah, so check this out. I can say English Spanish dot update, and then I can give the new key value pairing. How about horse, which is gosh, I'm going to really butcher this. Again, I hope I'm spelling it correctly. This is really prompting me to get back to some Spanish study, but caballo, which was one of the first words I kind of fell in love with when I was studying Spanish. I just think that's, for whatever reason, such a cool word for horse. So, does this work? Let's check it out. I'm going to hit enter. Okay, no error message. That's a good sign. And now I'm going to print, and look at that. It did indeed work. We just updated the dictionary with that new value. So, multiple ways. Yeah, you can add to a dictionary, as we've seen. What if I want to delete a value? Well, no problem. One way to do it is to just go ahead and say delete, and then you would give the appropriate key. So I'll say English, whoops, got to spell that right, underscore Spanish, and I would say something like, let's get rid of the horse entry. And so close off the square brackets there, and let's check out if that worked. Yep, it's that simple. So we can just say delete. We can reference our dictionary and the appropriate index that we want deleted for the index and value pairing. One final manipulation I want to show you in this video, and that would be another way to delete. And what we have is another method for dictionaries, and it's called pop item. Yeah, pop meaning remove, pop off. Yeah, pretty interesting. So English underscore Spanish dot pop item, and then you just give it empty parentheses. We don't need to do anything fancy with the pop item method. We just want to pop off the final value inside of our dictionary. And notice what Python does. It shows us that, okay, you just popped the item of bird chica. And now, once again, if we were to print our dictionary, yep, sure enough, it did remove the bird chica entry. So, can we manipulate our dictionaries? Oh, of course we can. They're mutable, and it's very easy to do so. First, we saw how you can overwrite a value with ease. Then we saw how you could add a new value with ease. Then we saw a method called update that you could use to add a value. And one of the things to watch out for there is, notice you have to do the curly braces and they end up being inside of the regular parens for the function itself of update. Then we saw how you can use the delete command to get rid of an entry, or if you want to, you can pop the last entry out of the dictionary. By the way, a little bit of trivia for you. In early versions of Python 3 code, pop item would randomly remove an entry from the dictionary. Yeah, I think about 3.6 and higher, they kind of came to their sanity with that method, and they have it pop the last item in the dictionary. You know, I just realized it's been a while since we've hit a video that we already know something about, and that is, of course, strings. Yes, we've already discussed strings in this course, and we've encountered them numerous times, but let's go a little further than we have gone before with strings in this video, and we'll even be doing more with them in the next video. But first, let's just kind of remind ourselves of some basics here. I'm going to say my string is equal to hello, this is a string. Notice that I can use the double quotes, as we've discussed, or single quotes to make the string. And that gets really, really important when you have a single quote or double quote that you want to use inside of the string. For instance, let's do the single quote because we are giving a quote, comma, this is a quote. You get the idea. Notice we need to use double quotes inside the string, so we go ahead and we use the single quote approach so that we can use the double quotes inside of the string. Now, what if you had both that were going to be in your string? Oh boy. Well, no problem. Don't panic. That's when we can use the escape character, which is the backslash on the keyboard. Watch this. I'm going to go ahead and say quotes, or single or double doesn't matter, because I'm going to escape the problematic repeated character. This is a, and then I'm going to escape and say quote, and then escape, and then the quote again. And this is a quote dash. We also have single quotes. I'm getting too wordy here. We also have its. Notice, so we had the single quote in here. That's why we had to use quotes on the outside of this string. But then we had double quotes on the inside. So that's why we used the escape character. So anyways, you get it. Now I'll close the whole thing up with the double quote, and no syntax error. It works just fine. We can, as you saw, vary what we're using on the outside here based on what we might be using on the inside. But don't forget, you can always just use the escape character that says, hey, we are not closing the quotes up right here. We're just using quotes inside of our string. Here's another trick that you can do with strings. It's called a multi-line string. You ready for this? So let's create my string 4, and we are going to say, yeah, look at that, double quote, double quote, double quote. We do either of the styles 3 times. This is a multi, and then line, multi-line string. It goes over many lines. And then how do we close it? Let me actually add another line. This is yet another line of text. And when we're ready to close it, you got it, triple single quotes, because I picked the single quote to create the multi-line string. Look at that. And yeah, if you print it, it prints just like you entered it. So let's print it, and there is your multi-line string going over many lines. All right. Well, I've got one last thing at this stage that I want to impress upon you when it comes to working with strings. You could always concatenate them. So look up top, I have my string and my string too. I could say new underscore string equals my underscore string plus my underscore string underscore 2. So look at that. That's going to work. Print new underscore string. And yes, it takes what was this string and adds it to this string. It is opening up possibilities for us here, isn't it? I mean, my gosh, if we could add these two things together. And by the way, there's even a more direct way to do that. You could give the Python code the two strings. Watch this. This is an example of adding two strings. Yeah, so there's kind of an automatic concatenation that you can do. Print new underscore string, and notice it just takes those two strings and adds them together. Okay, but just think about this. We're able to like add these strings. So could I do something like this? Could I say new string is going to equal the string of hi, and then multiply that 10 times? My gosh, is this going to work? It will. Yeah. So pretty interesting that we could do mathematical manipulation as well of our string values in Python. Well, my goodness, we looked at a lot here. Remember, to create your strings, you're going to use the double quote or single quote approach. One nice thing is that would accommodate using double quotes inside a string, for instance. But remember, you can always escape those values. And then we took a look at the triple indicator, if you will, to do a multi-line string. And then we also saw how we can add strings together, even implicitly add them together. And we even did a little math against our strings. Well, thank you so much for watching, and you guessed it, more with strings in the very next video. Yes, you knew it was going to happen. We've got more to say about strings. And I remember how surprised I was the first time I saw this. Let's go ahead and let's create a string. And the string that we will create will be hello with some exclamation points. Okay, so there is our string. The first time someone pointed out to me that the string is indexed, like the other data structures that we've been talking about in Python, my gosh, I was so surprised. Yeah, so if we do my great thing to do would be to just test this with print and then my underscore string, and then let's specify an index number. And does that print the H in hello? It sure does. So notice we have indexing taking place inside the string. Notice it works just like we're comfortable with. It starts at 0. So the H is 0. Could we go ahead and get the opposite with the negative, for instance? Could we go to the very end of the string immediately with the negative? We sure can. So just like before in indexing that we've seen, -1 is going to be that very last exclamation point. Now, There's something else about strings I need you to realize, and that is that they are immutable. Yeah, look at this. So if I go my string and I say 0 for an index, and I say this is going to equal W, it's going to say, nice try. The string object does not support item assignment. Yeah, that my string that we constructed early on here in our testing, that is an immutable structure. So guess what we can do? You're not going to be surprised. Yeah, we can slice in order to create a new string. In fact, I've been really trying lately in my writing not to overuse the exclamation point. You know me by now. In this course, you know I'm pretty excitable about the silliest of things, and I am the type that will overuse exclamation points. So why don't we create a new my string, and this new my string is going to be equal to my string, and then let's start at 0, and let's go up to, let's count here, 0, 1, 2, 3, 4. If I say index of 5, it will give me just what I want, because we remember that last index value is not inclusive in the slicing. So look at this. We're going to create a new my string variable, and it's going to be none other than a slice of our string. So you know what we need to do? We need to print new my string, and look at that. It works beautifully. So 3 big concepts I want you to be aware of that we've seen in this video. The first is that, yes, our strings are indeed indexed, so we can take advantage of that. We also learned that strings are immutable. And finally, we learned we could always create a new string from a string, and to do that, we could engage, if we wanted to, in slicing. In fact, don't forget, if you were to just indicate a colon in those brackets, you would be creating a new my string that is a complete copy of your previous string. Well, thank you so much for watching. And we are all the way up to part 49, as you can see, and it's time for us to discuss string methods. That's right, it's our last video on strings, and it's our last official video in this section of content. So yeah, this is a big milestone. I just wanted you to understand, and we've already seen a couple of them, there's going to be a lot of very helpful string methods that you can use. Let's go ahead and see if we can find the list. So we're going to go to the site of python.org, and I'm going to say we're looking for string methods. And I think the built-in types documentation is what we are going to need. And if we look through here on the text sequence type of string over in the table of contents, there is our string methods. So look at these. There's so many of them. Capitalize. Wow. Copy of the string gets returned with its first character capitalized. And by the way, that's an important point I wanted to make there. Notice it's a copy. Yeah, strings are immutable. So if I say my underscore string equals hello, and then I realize, oh my gosh, I need to capitalize this, what we would be doing with this method of capitalize is just altering the presentation. In other words, print my underscore string dot capitalize. Oh my gosh, I picked the one that's going to be difficult for me to spell. Capitalize, is that right? Well, we're about to find out. And the arguments here we're going to use are absolutely nothing. And I misspelled it. Okay, no problem. Let's just do a little copy paste to help me with my spelling here. There we go. So I'm going to copy that, I know. This is ridiculous that I'm being this lame when it comes to figuring out how to spell. It's just I am. All right, let's paste that in and let's enter and look at that. The method works just like it's supposed to, but you guessed it, if I go ahead and just show us what string we are working with, you guessed it, it's the original string. So these methods are going to be very, very critical for us manipulating the output of the string, but the original string, as we said earlier, is immutable. That's right, it is immutable. What other type of methods exist? Well, there's case fold, return a case folded copy of the string. Okay, don't even know what that is. I'd have to read more about it. Center, wow, count, encode, ends with. I mean, there's a lot of them here. And some that we already have seen that are very, very useful, let me remind you, is strip. Where is strip? There's R strip. Somewhere in here is just strip. There it is. So we can use the strip function to strip off the beginning and end white space we might have in a string. So this is very, very useful when you are accepting input from a user. So let me say my underscore input equals, we are going to say input, give us a string, is what we want to say. And I need to remember my string syntax for the input prompt. There we go. And what we want to do is accept this input and then make sure that we trim off any space when we go to use the value. So watch this. I'm going to add space, 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 space. This is a string, space, 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 and hit enter. And if we print the my underscore input, we're going to see that the value does have all of those spaces. Yeah, it has the spaces that we can kind of see before the string, and the spaces after the string we can't really see. You can if you highlight like that though. If when I click and drag to highlight, it's showing the entire string, which contains a bunch of white space. So once again, you can handle this by saying, I need to print my input, please, but I need you to strip all of the extra space that is around this string. So a lot of times we are manipulating the string input with these various methods, and we would have good reason to do that, of course. Like these extra white spaces are going to mess up us using the string. There was another one that we saw, which was upper. Yeah, go ahead and convert all of the letters to uppercase. I'm guessing there must be a lower, right? If there's an upper, there must be a lower. Let's look for that. These are in alphabetical order. There it is. There's the lower method. So my goodness, there are lots of methods that we can use with strings. And there's even some functions. We can't forget about functions in Python. And sure, there's some functions that you can work with, like for instance, the length function. So I could say, I want you to print now the length of the my input string, and Python would have no problem with that. And I love that I chose that one, further proving that there's a bunch of white space in it, because this is a string is actually 28 characters long. So that really demonstrates that in our original string, we've got a whole bunch of white space. Well, all right, so go ahead and just take a look, be familiar with these various methods. You know, there's a lot of them, but you could read about each and every one of them in under like a half hour, right? Or maybe an hour. But yeah, it's always good to know what types of methods exist for our strings just to see all the fancy stuff that we can do with strings and manipulating those strings. Well, my goodness, in this section of content, we have covered so much. We want to do a good, thorough review, and we'll start that in. Hey everyone, well, as you know, we covered an awful lot of content in this section of our course, so what I decided to do was do even more review. Sure, instead of doing the entire section, we're going to do topics from this section. We'll do review and practice exercises. So let's get started. Let's jump in to our Certified Entry-Level Python Programmer Lists Review with some fun practice questions. What is the correct output of the following Python code snippet? So we have the variable numbers being set to a list, as you can see. Remember lists? Yeah, lists are mutable, meaning we can change them, and they're sequential, meaning it's going to be really easy to iterate through them. But in this example, you can see we've created a list of our numbers. 0, 1, 2, 3, 4, 5, and 6 are in the list. And we have this command, print numbers -1. What will be the output of this command? Well, do you remember how our lists are going to be indexed? Yeah, the first value is going to be an index of 0. So 0 has an index value of 0. 1 has an index value of 1. And the indexes work like that in this example. And if we say -1, you guessed it, it's going to be the last entry in that list. So -1 here, a negative indices, it's going to print 6 for us. And that -1 index is, as we mentioned, a really handy way to get your last value in the list. All right, well, it's time for question number 2. What is the correct output of the following Python code snippet? So here we have our numbers creation again. Nothing has changed there, but this time we set a new variable named result, and it's going to involve our numbers list. Look at this, numbers, and then in square brackets, 262, and then we're going to print that result. What is going on here? Well, sure enough, we are slicing our list. And if you remember, the first value in the brackets there, the number 2, says that we should start at index 2. So what is index 2? It's the value of 2. Yeah, so the first value that we would be printing here would be 2. And then notice it's going to go up to an index of 6, but that's non-inclusive. So it would start at 2 and go up to 5, but then that third number indicates we're going to increment by 2. So sure enough, we're going to get 2 and 4. Yeah, you see what happens here? We would be printing, let's think about this. If we didn't have the increment of 2, what would we print? Well, we'd print 2, and then the value of 3, and then the value of 4, and then the value of 5. Notice we don't print the value of 6 because that is not inclusive, the last index number. So if we didn't have the increment, we would have printed 2, 3, 4, 5. With the increment by 2, we'll only print 2 and 4. Yeah, pretty easy stuff, but definitely worth reviewing, right? In case we've forgotten any of this content. Hey, what's the correct output of the following Python code snippet? Here we set fruits to apple and banana, and then we use the fruits.append method to append a list of cherry and date. So what would this look like when we print it? Well, pretty interesting. It's going to look like B. Yeah, that's right. It's going to be a list within a list. So we have apple and then banana in our original list. And then the third entry that we appended is an additional list. So it's a list within a list consisting of cherry and date. I created this review question for us because this is a point that I don't feel I really effectively drilled home when we were going through lists initially. All right, well, I've got one last question for you folks, and this one is a fun one, and I say that in that this is something that your exam authors at the Python Institute, this is something that they're really going to be striving to do. And notice it has us be challenged in a couple of different topic areas in one question. Yeah, sure, this is talking about list comprehensions, but it's also reviewing some of the mathematical operators. Yeah, so this is a great thing that they'll love to do. They throw multiple topics in a single question. Well, anyways, the nums variable here is set to a list of 1, 2, 3, 4, and then we say the result is equal to x raised to the second power 4x in our nums list. So yeah, raising x to the second power, that's fine, but notice we're only going to do it if we have a remainder function of 0. Yeah, so that means we're only going to be doing this for our even numbers in the list. Yeah, so what are our even numbers in the list? 2 and 4. And if we raise 2 and 4 to the power of 2, we're going to get 4 and 16. So if you were to see something like this in your actual exam environment, don't panic, just interpret it kind of one step at a time. Hey everyone, thank you for joining me in this Python entry-level Python programmer. Did I say Python twice there? Yes, I did. You know what the name of the course is. And we are ready to give you your assignment on lists. That's right. Let's review lists by having you create a lists-related Python application. Let's jump in and take a look at what I've set up for you. I need you to build me, you guessed it, a grocery list. And what I'm going to do is give you this code to get you started. So you're going to create an empty list. Notice you're going to create my grocery list. You're then going to print the kind of heading of our grocery list. And then notice I've created a while true menu that will repeat over and over and over again so the user knows what they're up to. It's going to print the number 1 would be input by a user to show the list. Printing or inputting the number 2 would be to add an item to the list. Number 3, remove the last item. Number 4, query how many items there are in the list. And then finally, 0 would be to quit. So can you complete this application for us? That is your assignment. Yeah, you'll need to be able to build in the code for adding an item to the list, showing the list, removing the last item, etc. You can check with our previous videos on how to do these various functions with lists. But yeah, you're going to create that fun grocery list application. As you know, I'm going to be back in the very next video with my solution. So you'll have fun comparing your solution to my own. And of course, many of you are going to far outdo what I accomplish in this assignment, and that's just great. So have at it. It is your lists assignment. And this is our solution video for the lists assignment that we all had together. So let's take a look at my solution to the list assignment. Now, if you remember, this is what we were given. Yeah, so we were given the beginning of our application, weren't we? We create a my grocery list variable, and notice we set it to an empty list, and then we are going to print the my grocery list heading, and then we had this section we were given of a while loop. Yeah, set to true. While true, we're going to be printing the menu system. 1 to show the list, 2 to add an item, 3 to remove an item, 4 to query how many items we have, 0 to quit, and then an empty line. And then notice my solution kicks in. So what I begin doing here is getting from the user their selection. Notice I set this to a menu underscore selection variable. Obviously, I'm going to use input. I'm going to ask them for their selection, and then notice we're going to have a little fun here. I'm going to strip off any additional characters they might have done accidentally when they're inputting this number. Now, you might say, well, wait a minute, Anthony, where is your verification for them hitting a number like 8, which isn't on our list? And that's actually going to be all the way down at the bottom. Notice I have this final else statement that says, please choose a number from 0 to 4, because that would be the case if they did not select one of our numbers. So yeah, I'm doing a little bit of error correction, little bit of verification steps as we are moving through our solution. That's fine. I didn't go too crazy with that. But notice something that we did in the very first if section here. I say if menu selection is equal to 1, go ahead and then do this additional if else logic. Yeah, I say if the length of my grocery list is 0, then go ahead and print your list is empty, else print the grocery list. Yeah, so notice we do a little if then, or if else, excuse me, nested inside of our first if selection, just dealing with the fact that the list may be totally empty, and to not confuse them, the user of the app, I'm going to go ahead and print that their list is empty. Yeah. Now, how about if they select 2? So I have an else if for them selecting 2, and here we have a new item. Yeah, so I'm going to go ahead and get input from the user on what it is they want to add. Once again, using that nice strip method for stripping off any additional characters. Then, here's a great review. We're going to take our grocery list and we are going to use the append method. And we're going to take that new item and we're going to append it to the list. And then notice we're going to print added an item and we're going to list the item that they gave us. So a little verification there for them that their step worked perfectly. What if they choose 3? Well, no problem. We have an else if they choose 3. And then I'm going to do my little length, make sure the list actually contains something. And then if it does, we're going to go ahead and use the pop method to pop off that last item. And we're going to print, we remove that last item. Otherwise, we're going to print, hey, there's nothing to remove because your grocery list is 0. Yeah. So notice another kind of built-in error correction there. How about if they choose 4? Well, this is to get the length of our list. Yeah, so no problem. We'll just say number of items on your list, and then we'll get the length of my grocery list. All right, finally, we have, let me scroll back over to the left here. Yep, there we go. And then scroll down. Finally, we have what if the selection is 0? Yeah, if it's 0, we're going to thank them for using the grocery list. And then this is key. We're going to break out of this. Yeah, don't forget the way I had you do this, you are in a while loop that's always going to evaluate to true. So this is just going to go over and over and over and over again until they actually quit. And that would be quitting via a break in the action, if you will. Well, all right. As you might guess, a big part of this assignment was testing it. Sure. So you're going to get in there and you're going to run this module. Yeah, and this will take you a little bit of time, right? Because you'll want to verify everything you built. How about pressing 1 right now? This should trigger that logic to see if there's anything in the list, and sure enough, it should print for us, your list is empty. So obviously a good thing to try next would be 2, add something to the list, and I'll add eggs. I do need eggs, by the way. I just realized that. Yeah, I'm going to go get eggs later today. In fact, let me do my actual shopping list. This may be a little embarrassing. Let me add another item, and I got to get them today. It's my Nerd Gummy Clusters, the greatest candy ever invented. All right. Also, I need today some bread. All right. So now if I do number 1 to show the list, yeah, looking a little bit better there. There is our shopping list. What if I want to remove bread from it? I'll just tap the number 3 and that should remove that last item. Now let me show the list again, and sure enough, the bread is gone. How many items do I have total? I have 2 items on my shopping list, and guess what? The quit works beautifully. So I hope you had a great time in this assignment, where we took the initial construct of an application and then we went in and built the logic. And as you can see, not very hard, not very difficult, and a great review of some of those key methods and functions that we would need of lists in Python. Thank you so much for watching. And you guessed it, next up, we're going to be reviewing, I believe it's tuples. That's our next topic to review. And it is time for us to review tuples. If you're one of my students that's going, what the heck is a tuple? I'm glad you're here. I know we covered this in this section of content, but we covered so much, it's time to get some review done. Let's jump in and take a look at our tuples review. I've got 4 questions to challenge us on tuples and make sure we feel a bit refreshed in this topic area. Which of the following statements correctly creates a tuple with 3 elements? So one of the things that we kind of remember right off the bat here is lists are done with the square brackets. Yeah, so this is a great reminder of that, isn't it? So I can eliminate C and D right off the bat. And that really is the strategy I would use if I was facing a question like this in certification. I would immediately eliminate C and D just based on that fact. Square brackets means list creation. And then as you look at the syntax of the A and B options, you can see that there's an issue with that trailing comma, so B is the correct answer. Notice it's not the square brackets, but it is our standard parentheses that are going to surround our tuple when we create it. Great work on that one. All right, number 2, what will be the output of the following code? So we can see we create a tuple in a variable called my_tuple, and it consists of the integer values of 10, 20, 30, 40, and 50. But then we say print my tuple, and notice we give some instructions in brackets. Yeah, this is referencing, of course, our index values. And remember how index values are going to work. Just like in lists, the indexing will start by default at 0. So the value of 10 is index 0. The value of 20 is index 1. The value of 30 is index 2. You get the idea. Now, what does that syntax mean? Print tuple 1:4? Well, it means we need to start at index value of 1. That would be the number 20. So guess what? We're done. Yeah, isn't that amazing? Notice how quickly you can arrive at the correct answer because option B is the only one that starts with 20. That's our correct answer. Yeah. Now, what is that second value of 4 doing? in that index reference there? Well, that's saying where we're going to be printing up to in the tuple. And remember, it's non-inclusive. Yeah, so what is the index 4 value here? The index 4 value would be, let's see, 0, 1, 2, 3, 4. It would be 50. But we don't end up printing that. It's not inclusive. So we would indeed print here 20, 30, and 40. Yeah, so we can get the correct answer here very, very quickly, as we saw, but I want to make sure you understand what that second value does. That's where we're going to be printing up to, and it's non-inclusive. Remember, if you see a third value included in the index reference, that would be the increment value. All right, well, how about this multiple choice question? Which of the following statements is true about tuples in Python? Tuples are mutable, while lists are immutable. Both tuples and lists are mutable. Both tuples and lists are immutable. And finally, tuples are immutable, while lists are mutable. Well, I think we better remember that immutable means we can't change that particular thing. Mutable would mean we can change it. So what's correct here? Well, that's the big difference between a tuple and a list, everybody. Tuples are immutable. They can't be changed. But our lists are mutable. We can go in and freely edit and alter our lists. Great job to everybody that got that. Very important point, obviously, about our tuples. One of the reasons we have them. Yeah, if not, lists would do the job. All right, and finally, what is the type of the following object? We have a data variable set equal to, in parentheses, we can see in brackets 1, 2, and then 3, 4, and 5, 6. What is this? Is it a list of lists? Is it a list of tuples? Is it a tuple of lists? Or is it a tuple of tuples? That's fun to say. It is a tuple of lists. Yeah, so this is indeed a tuple. And you can tell that because look at the far outermost, symbols there, right? Those are the parentheses. Yeah, so we have created a tuple, and that tuple does consist of lists inside it. Yeah, and this is certainly a valid structure that we can have inside of Python. Sure, a tuple made up of lists. Well, everybody, thank you so much. I hope this review was beneficial to you. If it's been a while since you looked at our tuples videos, I hope this review was beneficial. And yes, I'm going to have you get into some programming with tuples in the very next video. Welcome everyone, and you know what time it is. It's time for your assignment when it comes to tuples. That's right. Let's jump in, take a look at what we're going to be doing together for an assignment on tuples as part of our reviewing of tuples. That's right. So here you go. Here is your assignment. 3 tasks. Number 1, you're going to ask the user to enter their first name, and that needs to be a string, their age, that needs to be an integer, and their city, which needs to be a string. You're going to store the information in a tuple named person, and you're going to print each value from the tuple using indexing. Okay, so one of the things that I would recommend you do here, just like with any type of an IT certification task, I would read very carefully and think about this exercise very carefully. For instance, does it matter what we call the first name variable? For instance, we're getting a first name from the user. Does that have to be first name, one word, first underscore name? Well, they didn't say, so that doesn't matter. But does the tuple need to have a certain name? Yes, indeed. It needs to be named person. So when we are analyzing tasks, be sure to look very closely and always think about, okay, what are the true requirements here and what would they be grading for? The mysterious they, I'm just saying, whatever certification we're taking, someone's going to be in charge of that and someone's going to be grading it. And we need to really think about those requirements. Okay, well, have fun with this Tuples assignment. And of course, as you know, I'll be back to review my sample solution with you in the next video. And I am your instructor, Anthony Sequeira, and I am here to give you my solution to our Tuples assignment by way of reviewing I think it was our third section of content in this course. So let's jump right in. As you might remember, I gave you an assignment. It was an easy one. Yeah, straightforward, easy one. I did that on purpose. I thought the last assignment I gave you was kind of tough, so this one a little bit easier. We had 3 things to do. Ask the user to enter their first name as a string, age as an integer, city as a string, store the information in a tuple named person, and print each value using indexing. Let's take a look at my solution, shall we? Notice one of the things I did in my solution was I reminded myself, and I want to remind all of you, how great comments can be, right? So here is my comment that this block is addressing step 1, and then here is our step 2, and then finally here is our step 3. Notice step 1, so easy. Let's get a first name variable and let's do our input command to get that first name. And we were told that this needs to be a string, but that's a piece of cake for us because the default value for our input is going to be a string. Now notice on the age variable, this is when I do my typecasting and I say, okay, we need an integer for age. By the way, don't forget, helping your end user. So maybe enter your age as integer. Yeah, we want to try and help our end users as much as possible work with our program. So yeah, not a bad idea to say there, we need an integer. But notice we are definitely converting the string to an integer with that integer function. And then finally, enter your city. And maybe again, help them out, your current city, as opposed to they might put the city of their birth, for instance. All right, step 2, what did I do here? Well, I created that variable that we needed called person, and look at this, we create our tuple out of first name, age, and city. The tuple is immutable. It can't be changed. And we'll try and prove that. Yeah, we'll prove that in our example here. Anyway, step 3, print each value using indexing. Yeah, pretty clever. Remember, person 0 would be our first name component of the tuple. Person 1 would be our age, and finally person 2 would be our city. So, does this thing run properly? I hope so. Let's run it. And we're going to save it first because I did make a little change there. Enter your first name. Hey, it's Anthony. Enter your age as an integer. I'm going to do the old I'm still 35, even though everyone watching knows that's not true. And then enter your current city. We'll say Tampa. And we'll say enter. And what just happened? This character, I think I accidentally hit on the keyboard because that looks strange. We'll have to run this again, but notice it is printing out first name, age, and city. Boy, oh boy, let's run this again. I don't know what's up with that extra character, although I do think I may have just hit something on the keyboard. All right, enter your first name, Anthony. Enter your false age, 35, your current city. And yeah, that was just me accidentally hitting the backspace on the keyboard or backslash. So anyways, it runs just as we would expect. And now a quick review of immutability when it comes to these tuples. we should be able to cause an error here pretty much. So demo of immutability, immutability, maybe. Maybe that's right. Immutability. No, totally wrong. Whatever. You know what I'm trying to spell. All right. How you can demo this? Oh my gosh. You can just go ahead and try and make a change. For instance, I could say person and then give my index of 0. And I could say that needs to be Tony. So I want to change the first name value in my tuple. And so can I just directly change it like this? Well, I don't know. Let's try it. We're going to file, save. All right, so here we go. Let's run this new version with the demo of immutability. Let me enter my first name, my fake age, and my current city. And then, yes, excellent. We are seeing an error, just as we would expect. We attempt to go in and change an element of the tuple, and it says, sorry, a tuple object doesn't support item assignment. Yeah, because Anthony and the 35 and the Tampa, these entries in the tuple are immutable. So a little bonus there, just proving the beauty of the tuple is it can't be changed. Well, thank you so much for joining me in this solution video to our assignment on tuples. Next up, we got something called dictionaries that we need to review. I'll see you there. And you know what time it is. It's time for us to review dictionaries and strings with a nice review segment. Let's jump right in. First question that we have for you, what is the output of the following code? So notice we are creating a dictionary and we have an initial key of A with a value of 100 and then a key of B with a value of 200. We then reference data A equals data A plus 50, then data C equals data B minus 100, and then you can see we print the length of our data. So you might want to pause the video here, give this some thought, and then go ahead and return as I review the answer. So yeah, this was an interesting one, having us review some code that we are using to manipulate a dictionary. And this one was pretty easy, wasn't it? Yeah, if we create a new item, if we create a new key value of C with a new piece of data, when we print the length of our data dictionary, it is going to reply with 3. Because we now have the A, the B, and the C indexes or key values created, the key value pairings. Yeah, pretty cool. Pretty straightforward. I thought this was a little bit out of right field for what we had covered in our course together. So I just wanted to see if you could respond appropriately to a code setup like that. All right, next up, what is the output of the following code? And we can see another dictionary that has been created. And then notice for key in my dictionary, we're going to print the key, my dictionary key, and then we're going to have an N character of a space. So go ahead and pause the video here, look at your options, and unpause when you're ready for me to review the correct answer. Well, all right, everybody, I'm looking at these answers, and the first thing that I notice is our print statement is going to be printing the key and the value for that key. Yeah, so notice we would get the key and the key's value. So I can rule out A and B right away. Yeah, look at that. A is printing just the keys. B is printing just the values, so I can eliminate those two. Now, comparing C to D, we see that, well, there's just this is just kind of a formatting thing. Would we get a space between x1, y2, z3 like that? No, actually, if you run this, the output that you get is the key value of x, a space, the value of that key of 1, and then a space, and then y, and then a space, and then 2. Yeah, so the formatting output that you would get would be D. All right, next up. Which of the following statements about Python dictionaries is true? Dictionary keys must always be strings. Duplicate keys are allowed if the values are different. I'm laughing because that one just doesn't seem possible, does it? Dictionary keys must be immutable data types. And then finally, the values in a dictionary must be of the same data type. So what I would do on a question like this is I would just start eliminating incorrect answers. So I had chuckled about B. Yeah, we can't have duplicate keys. My goodness, Python is going to get awfully confused by that. So I eliminate B. Dictionary keys must always be strings. Ooh, I eliminate that. Much too strict, not how it works at all. And then the values in a dictionary must be of the same data type. No, we covered that. You could have values be all over the place. So the only correct answer by process of elimination here is dictionary keys must be immutable data types, and that's exactly true. So they would be strings, or they would be integers, or they would be tuples. Yeah, they would be our immutable data types. All right, last but not least, we did cover strings in this section. So let's go ahead and work in a little string review here, which is the output of the following code. So we have a variable called text that we fill with the string of Python. And then notice we have a very clever little print command here. What would be the correct output? I'll go ahead and pause here. You'll want to pause your video, think about this, and unpause when you're ready for me to cover the answer. All right, well, the first thing that would be printed would be the text from index 1, and that would be the lowercase y. So look at that. Right off the bat, we can eliminate options B and C. Woohoo! Yeah, not B and C. And then we're going to add text -1. That would be the N. So YN. And guess what? We could stop right there. Yeah, we have arrived at our answer. Now let's just sanity check the text 2:4. So that would start at index 2. And that would be, let's see, 0, 1, 2. That would be the lowercase t. And then it would go up to index of 4. That would be the O. But of course, it doesn't include the O. And so it would be giving us the H. So YNTH is the output we would see. Well, great work, everyone, in this review of dictionary concepts and strings. And you guessed it, coming up, I'm going to go ahead and give you a dictionaries assignment. In this episode of our Certified Entry-Level Python Programmer course, we are going to assign to you your assignment for dictionaries. Let's jump in and take a look at this assignment so you can get some hands-on experience with these. You are going to create a dictionary, and you need to call the dictionary snacks. The keys are the first names of 3 friends. The values are their favorite snacks. Now, you're going to be doing 4 things inside this little application. First, I want you to code to check for if Alice is a key value or key entry in snacks. And then you're going to print all the friends' names using the .keys method. Then you're going to print all the snacks using the .values. And then finally, you're going to print each friend and their snack using items. So a nice review of a bunch of the material that we had in our dictionaries section. Have fun with this. Welcome back, everybody, to our Certified Entry-Level Python Programmer course, and we are ready to run through a sample solution for our dictionary assignment. Remember what that assignment was? It was to create a dictionary called Snacks. The keys are the first names of 3 friends. The values are their favorite snacks. And then we needed to check if Alice is a key in Snacks, print all the friends' names, print all the snacks names, and then print each friend and their snack. Notice we had to use some methods there in order to do that. Now, some of you may have gotten really creative here and done menu systems and all that kind of stuff, but I intentionally did not, because I wanted to remind you, when we are in a certification environment, let's say, and we are solving a task like this, there's no points for extra credit. Yeah, there is no points for extra credit. So you can go and you can accomplish these verbatim in your solution, and that is going to work. So notice I went in and just did each of these things in order to get credit for this assignment. By the way, I did this on purpose. Notice that when it comes to style, you can do pretty much whatever you want as long as you're consistent. And I don't like a space after the pound in my comments, but notice, even if you're going to do it that way, do it consistently. Otherwise, it's, going to make your code look problematic. So whatever technique you end up using, be sure to do that consistently. All right, well, anyways, create the dictionary name Snacks. Well, that sure was easy. I went and created my variable named Snacks, and then I created my dictionary. Notice I did this over several lines like I showed you inside our lectures. This is great for readability, isn't it? Yeah, it shows me my keys and my values in a much easier to read type of mechanism, but certainly this style is optional. Then we check if Alice is in the dictionary. So I say, if Alice in Snacks. Yeah, look how easy that is. And then if it's true, we're going to print Alice is in the list, or else we're going to print Alice is not in the list. And by the way, Alice is not in our list. So hopefully that's what we're going to see at the command line. Then we say print all friends. So I print and I use a string of friends, and then I'm going to print out all of the keys of our object called Snacks. So this is the keys method of the Snacks dictionary. Yeah. And then print all the values, no problem. Going to do the same thing, just printing all the values of Snacks. And then we're going to iterate through our dictionary. So I'm going to say for friend and snack in Snacks items. Notice we're using our method once again in order to iterate through all of the items. We're going to print friend, and then likes, and then snacks. So it should be Tony likes nerd gummy clusters. Yeah. Now, I did realize as I was solving this assignment that I created, I probably should have had you print a specific item. Yeah, let's just make sure we can do that here, a little bonus. And that's so easy to do. Remember, you can print a specific item with ease. I can say snacks, and then I can use my square brackets to say, like, what is the Tony favorite snack? So yes, we can print a specific, in this case, it would be a specific value. So yeah, that should work. So let me go ahead and save this, and we will run it. And look at that, no errors, gotta love it. Alice is not in the list. The friends are the dictionary keys of Tony, Bella, and Eve. The snacks are the dictionary values of Nerd Gummy Clusters, cookies, and pretzels. Tony likes Nerd Gummy Clusters, Bella likes cookies, Eve likes pretzels. So there's the step where we are iterating through the dictionary. And then finally, I'm printing a specific value, the value for Tony. So lots of fun with our dictionaries in this assignment. I hope this drove home some of the points of our work with dictionaries. And you guessed it, it's time in the very next video for us to start a brand new section of content. I'll see you there. You might be at the point in your certified entry-level Python programmer journey where you're saying to yourself, what more could we learn? My goodness, we have covered so much together in this course. Well, there is some more important stuff to learn. It is our final section of new content. So let's get accustomed to what we're going to be looking at here in section 4. To do this, no surprise, I'm going to go to the pythoninstitute.org, and from the pythoninstitute.org website, we're going to go up to certifications. We're going to go to the PCEP entry certification right there, and we are going to scroll down, and we're going to find the exam syllabus. There it is right there. And we're going to go ahead and take a look at this. My gosh, the live and active one is right over here. I'm going to click download. It'll bring up the PDF and we can see our section 4. By the way, this is really something you should have printed out. I know some of you may have even built your own listing of all this stuff right in something like Excel, and you're tracking your progress. This document is going to be so great for you, especially considering that we have an awful lot of objectives. So, we're human, we're going to forget stuff, and as we are doing our final review before our certification exam, we can go through here and allow this to be the basis for our review. My videos coordinate to these, so you'll be able to jump in and review whatever videos you might need. Okay, well, with all that said, let's get to why we are here. We are going to be starting now section 4, and notice it's really two big things. It's functions and exceptions. You already know what a function is. A great example of a function is the print function in Python. Yeah, anytime we need to print something to the screen, it's so easy to do thanks to the print function. And if we want some kind of special end character, we can specify that. We know there's attributes, there's manipulations we can make of how the function works thanks to those attributes that we can set. Well, guess what? We can create our own functions. That's right. If you have something that you're going to be doing over and over and over and over again with your application, with some of its logic, my goodness, make that a function. That's going to reduce lines of code. It's going to add consistency. It's going to just make everything so much easier for you as the coder. So creating our own functions is going to be something really, really fun that we can do with Python that we're going to look at. And then we're going to talk about errors. Yeah, otherwise known in programming speak as exceptions. So notice we've got some subsections on functions, and then we've got two subsections on exceptions. What kind of errors can we experience in our programs? This isn't a comprehensive list, but it's the ones we need to know about at this level of our education. And then how can we handle errors in an elegant way? So really cool content. Maybe exceptions isn't the coolest of concepts, but it sure is critical. And then I don't know about you, but the thought of building our own functions is just something that's really neat. Oh my gosh, I am a nerd. All right, well, I hope you are as excited as I am to get launched into this section 4. And yeah, we're not going to mess around. Join me in the next video for the beginning of our discussion of creating our own user-defined functions. Well, I hope you're excited for this section like I am. We're going to get into our discussion of functions. Yeah, one of my favorite parts of the course. You're going to love this. Functions allow us to decompose our big, projects when we code in Python. And shout out to ChatGPT that I think did a bang up job on my request for a really cool decomposition using functions in Python slide. Anyways, so what we like to do is we like to take a big complex program that we need to write, and we love to break it up into functions. One way you can tell you can probably benefit from a function is if you're looking at your code and you keep doing the same thing over and over and over again in code. Yeah, that's a sure sign that you probably could benefit from a function that does that over and over again for you. Something else that's great about decomposing our big applications into functions is we can get different teams working on different functions. Yeah, so they don't step on each other's toes at all. So where do functions come from? Well, you already know some of these sources. For example, we've been using the built-in print function over and over and over again in our course. We've been using the built-in input function over and over again. So a lot of these functions are built right into Python. Something else you remember doing in our course is you remember bringing in custom functions from modules. Yeah, you import a module like the random module, and then you use functions from inside it. You use functions in classes. Now, this is beyond the scope of our entry-level Python programming course, but just know that inside of classes that we can define functions, and use that way. They're called methods inside of a class. And finally, something we are tackling in this section of our course, and that is you can define your own functions. Yeah. Super fun. And how you do that, it's really simple. You go in and you say in your code, I want to def, that's short for define. I want to define a function. And you give it a name and parentheses, and then you do the colon, and then you indent what that function's going to do. Yeah, the function needs at least one line of code to be valid. So we define a function in very, very simple syntax like this. Now, let's jump in and actually see this in action so we can learn a little bit more about it as we introduce it to you here. So let's start a new file, and let me try this. I'm going to define my underscore. How about we give it some actual function? Let's give our function a function. How about define my signature? Yeah, this will actually do something. And what it will do, notice there was an automatic indent there nicely. And that's great because we need to indent the body of our function. I'm going to say print, and we will print my full name, which really is a lot of typing that you have to do. So great. I don't have to ever print my full name again. Oh, thank goodness. Yeah, I don't ever have to print all that again because I have now defined a function that will print my signature. Now, if we run this, it does absolutely nothing. Let's prove that. I'm going to do a file save. Let's save this into our downloads. We'll call it, just test. So let's save this, and we are going to run this, and it does nothing. Yep, it ran. Yes, it ran, and there wasn't an error or anything like that. It just did nothing, and that's as expected because we're just defining the function here called mySignature, but we're not calling it, is the specific Python verbiage that we use. Yeah, we're not calling it. So let's call it. First, I'm going to print our program starts here. Our program starts here. All right, so you can see what I'm doing here. This is when the program will actually start doing something, that we can see when we run it. And notice I can then call the mySignature. And so we just reference it with the mySignature function name. And then how about print? And we're going to print our program ends here. All right, so what's going to happen? Well, the program is going to run. It's going to process this. It's right at the top, and it's going to process this, and it's going to know what the mysig function is and what to do. But then it's going to print our program starts here. It should then drop in our signature, and then it should print our program ends here. Yeah, because what happens is we define it, and then when we call it, it jumps up here for the execution, but then it's going to return us to the next line in just our regular old programming, if you will. So let's go ahead and file save this and make sure we understand how to call these functions and how they are going to work from a logic perspective in our code. And look at that. It works just like we thought it would. So one thing to watch out for is you clearly are going to need to have to define your function before you call it. Yeah, you'd have to do that. The Python works from a top-down perspective, and Python. I'm sure you are excited to take your next step when it comes to functions, and let's do that right now. We are going to focus on function parameters. Yes, so in the previous example, in the previous lesson, we just had a function with absolutely nothing in the parentheses. That's no fun. We can define parameters in the parentheses. So check this one out. I say, let's define my function, and in the parentheses, I have my number. Now, what will this fun little function do? Well, it'll do a print, and it'll say number equals my number. So notice when we call this function, we have to provide a parameter. Yeah, we have to provide a number in this case. So I say my function 102, and if we've done everything right, it will print out number equals 102. Let's make sure that functions work just the way we think they should. Let's take a look at the function that we were just looking at in PowerPoint inside of our Python environment here. So let's go ahead and call this thing, shall we? We'll say my underscore function, and we'll give that number of 102. So we'll go ahead and save it and run it, and look at that. It behaves just as we thought it would. It runs the print function, and it puts in the number that we provided with the function when we called the function specifically. What do you think would happen if we did this? Yeah, what do you think if we refuse to provide the parameter? I'm not having a good feeling about this. What about you? Let's go ahead and run it. And yeah, we caused an error. Yep, we sure did. It says, hey, your my function call is missing one required positional argument called my number. Boy, this is one of those errors that we get in Python that really is as close as you could get to plain English, I would think, right? I mean, this is explicitly telling us exactly what was wrong. I love it. By the way, notice it is a positional argument. We're going to have more to say about positional arguments as opposed to other types of arguments that we can do in the next lesson. And one more thing, notice I'm calling these things parameters. The actual error message here is calling them arguments. That's another fun kind of interchangeable way to refer to the parameters inside of our function. Okay, so I want to teach you something else before we leave this example on our parameters. I want to show you something pretty nifty here. Watch this. So let me go back to where this thing was working. Okay, so I'll get it back working again. We'll put a number in there of 100, but now I'm going to do this. I'm going to go ahead and create some code above our function definition, and I'm going to say my underscore number equals 200. What is happening here? Well, what I'm demonstrating here is that we have something that's called scoping of our variable names, and we have a scope inside this function definition that will, when we're in that function definition, cast a shadow on this variable with its assignment. Yeah, isn't that interesting? So this my number in the function will not have any effect on this my number variable. Yeah, this is because this my number has a different scope. Yeah, it has this very important scope inside of the function definition only. So what we will prove here is that this my function is going to work totally normally with the 100. And then let me do this line. How about print the variable my underscore number? All right, so what do we expect to see? Well, we expect to see the function run and say num equals 100 because it is not confused by the my number variable up here in a different scope. This we would call global scope for this project. And notice when I print this globally scoped variable, it should print the number 200, shouldn't it? Now, let me make this absolutely clear. While I have to teach you this, it's part of our curriculum, it's part of our requirements, understand that we would never do something like this by design, right? I mean, yuck, this is not good. I don't want to have a my number variable here with another my number variable in my code. I mean, that's something I would want to avoid. But it is worth the academic exercise here that we see this. All right, let's go ahead and file save this thing and let's run it. And look at that. It does just what we thought it would do. Yeah, the function runs normally with the my number variable that we passed of 100. And sure enough, that globally scoped variable is going to print its value of 200. And yeah, now we know a lot more about these parameters. Now, before I let you go, let me just go ahead and show you one more example here. And that is just reinforcing for you the fact that, well, that's our old example. Let me get the other one. There it is. Look at this file. I just wanted to impress upon you that, yes, of course, you can use multiple parameters. Yeah, you can use multiple parameters. And we'll see in the next lesson some implications of that. But just look at how this would work. I create a function here called greetUser, and it takes a first name and a last name argument or parameter. And then what do? I use that in a print statement. I print hello to the first name plus the last name with a nice exclamation point for emphasis. And then notice in this code, I am calling the greet user function that we created with my own first and last name. So when I run it, it works just like we would expect. It does a nice hello, Anthony Sequeira, exclamation point. All right, so yes, multiple parameters. Yeah, no problem at all with multiple arguments or parameters inside your functions. Well, thanks for joining me, everyone. And as promised, we are going to discuss, I don't need glasses, we're going to discuss passing parameters to our functions in this video. Let's jump right in and get started. So the first thing I wanted to mention to you is I was lazy and foolish in the last video. I said that parameters and arguments are used kind of interchangeably in Python, and that's not, well, that is true, but it's not technically accurate. Yeah, we always want to be technically accurate. And just so you know, according to the creators of Python, a parameter is when you are defining the function. So here you can see I'm defining the function called my function, and I have my parameter. Yes, that's when we have a parameter. Now, notice I'm calling the function down below, and I'm giving it a value. That value is called the argument. Yeah, so just let's know that for our certification exam, by the way. Yeah, so it's parameters during the definition, it's arguments technically when we are passing that parameter in. All right, but now to the main content here that we need to discuss, and that is what we've been doing so far when we have multiple parameters. Yeah, that's positional parameter passing, sure. So here in the simplistic example, I'm defining a function and there's 3 parameters that need to be provided, an A, a B, and a C. And sure enough, when we call the function, we provide the arguments in the appropriate order. And so, yeah, this is the kind of standard way to do it. We call it positional parameter passing. Sally sells seashells at the seashore. That was wicked hard for me. All right, next up, the alternate way to go is go ahead and use keyword argument passing. Ah, look at this example. So we define my function and it's F name and L name for your parameters. And what do? Well, when we call it, when we provide the arguments, we go ahead and specifically call them out. And notice on purpose here, I did them in a different order. Yeah, because we can. So I said the L name is going to be Smith. The F name is going to be John. So you can call out exactly what parameter you are defining with your argument in your calling of the function. Yes. Now, the question that you probably have is, could you combine these 2 methodologies? And kind of surprisingly, the answer is yes, you can combine these 2. But the key is you always need to start out positional. Okay, so you always need to start out with a positional reference. So let's take a look at combining these 2 methods. Here I define my function once again as simply A and B and C. And then notice when I call the function, I give the positional parameter pass first of 1. Then I can use my keyword method, and I can use any order I want at that point, right? C is 3, B is 2. You get the idea. I don't recommend you combine these just because you can, but obviously if you needed this capability of using the 2 parameter passing methods, then go for it. If you need it, do it. So, an easy, simple, straightforward lesson, I hope. In this lesson, of course, we learned the real difference between saying parameter and argument when you're working with functions, and then we took a look at 3 options for passing in There is another very useful feature when we are defining our functions inside of Python. We can set defaults for our parameters. Let's take a look at this right now. So let's jump in and play with some default parameters. Why don't we? So let's define a new function. I'm not feeling creative. We'll call it my function. And now it is time for our parameters. I'll do fname and then I'll do lname, but I will set lname equal to Smith when I create the function definition. And we need to end that with a colon, of course. Look at this. So I am setting a default last name. Pretty interesting here. Let me go ahead and print. We'll give the body something to do here. We'll print hello to, and then we'll go ahead and let's do a space there. And then we'll go ahead and do the fname. And we will then print a space. Let's add a space. There we go. And then we will concatenate, to use the proper name of what we're doing here, the last name. All right, so there we have it. We have something to do with our function. And now let's go ahead and call the function. Now the first test that we want to do here is let's call the function and let's go ahead and provide a first name and last name. So I'll go ahead and provide my first name and my last name. Notice for some reason I'm deciding to mix the use of single quotes and double quotes in this document, and don't do that. Yeah, I don't know why I'm doing it. All right, so we're going to file, save, and we are going to run this. What do we expect to see? Well, I'm thinking it's going to ignore the default value because we have provided a last name value. But let's check. So I think it's going to ignore the default. And look at that. Hello to Anthony Sequeira. It did ignore the default that was set. All right, great. So look at that. We can set a default and then we can just overwrite it with the function. All right, but I want to try another variation here. Let's go ahead and just give first name. So I'm thinking if we just give first name, I'm thinking the default will kick in. And this will say hello to Anthony Smith. Let's save and let's run to see if we are correct. Look at that. So we don't provide a last name and the last name default kicks in just like we were hoping it would. All right. So cool. Now, let's try something else here. What if I go in and I also set a default first name? Yeah, you were probably wondering about this. So I will set a default first name of Joe, or actually John, right? John Smith is the most common name in the United States, supposedly. All right, so there we go. So now, would I have the ability to do something like this? This failed in an earlier lesson when we tried it before. Yeah, there were a couple of parameters we had to provide. We didn't provide any and we got an error message. I think this would work and would print hello to John Smith. Let's try it. We'll do a file, save, and we'll run it. And look at that. Yeah, it's now going to work. Now that there are defaults in there for those values, it's going to work just fine if we just call the function and we pass no arguments. Obviously, if you set a first name or a last name or both, it will overwrite that appropriate. Have you noticed that our functions that we've designed so far have been kind of lame? They just print something to the screen. let's start having a bit more fun with logic and the functions that we define, and we're going to do this using none other than the return keyword. That's right, this is a powerful keyword that we can use when we are working with our functions and their definitions. Let me show you exactly what I'm talking about. So to have some fun here with our first demonstration, it's going to be to define a bouncer function. Yeah, that giant person normally that stands in front of a club checking identification to see if you can come in. We have an 18 plus club here, by the way, notice. So 18 plus to be able to get in. So what do? We ask for the name and the age parameters, and then notice I have an if function or an if statement, and that says if the name is nothing, then we are going to ask them to tell us their name, and notice we're going to return to the code. So the function is going to end. This is the example of a return command without any value or expression associated with it. In the next example, I'll show you how we can use the return function with a value or an expression. But what we're using it for in this example is just to break out of the function. Yeah, because they didn't give us their name. Yeah, they didn't give us a name value. Notice if their age is under 18, we're going to do a customized message to them. We're going to say, sorry, whoever your name is, this club is for 18 plus. Notice this breaks out of the function. And then finally, if they pass these tests by the bouncer function will print welcome into them by name and ask them to enjoy the music. All right, well, let's see this function in action. So let's go ahead and copy it to the clipboard, and then let's go to an idle session and let's input this function, and then let's call this function. So I'm going to say, okay, how about my daughter Bella, and her present age is 23. So I would hope that she gets welcomed in by the function and she's told to enjoy the music, and that's exactly what happens. Notice we did give a name. She was older than 18, and she was therefore welcomed into the club with this code right here. The function never had to go to either of these return statements. She would be mortified if she knew I was doing this right now. And someone that she works with is taking this course with me. So I'm in big trouble. Yeah, this will get brought up to her. All right, anyways, what about when she was too young? All right, let's check that out. Whoops, that's the wrong keyboard shortcut to pull up my last command. All right, so I'm going to go ahead and think back to a time when she was just 16. And of course, that club would not be for her. Finally, we do need to check the code of a non-entered name. And the age wouldn't matter because that test actually runs first in our code, doesn't it? Yeah, so there's no name, and that should promptly exit the function code. Let's try it. Yep, please tell me your name right away when there is no name value provided. So this function has taught us how powerful this return keyword can be. And in this example, as I indicated, we have created a function where the return keyword is being used just to break out of the function and doesn't carry with it any particular value. Well, as you might guess, I'm going to go ahead and show you now an example where the return does carry with it not only a value, but a couple of values here. Yeah, look at this. So we are going to define a function that does total with tip. We're going to take the amount and the tip percentage, and we are then going to create a variable tip amount, and we're going to do the round function on our amount times the tip percent divided by the 100. This 2 right here is to what place we want to round to. And then we do this for the total, adding the amount to the tip amount. So a nice little tip calculator. And let's go ahead and see this in action. Notice it's going to return, thanks to the return keyword, a couple of different values from our function. This can be an expression, or it can be, variable calls from what happened in the expression above. So neat. Let's go ahead and copy this. And we'll go over to idle and we will run it and make sure it works just like we think that it should. All right, so I'm going to clear off a little space here, paste it in, and now let's call it total underscore with underscore tip. And I'm going to say, $104.23. I had a friend with me. That's why it's so high. And what's our tip percentage? Oh, the service was absolutely amazing. I'm going to tip 25%. All right, so the tip amount, $26.06, and the total with tip, $130.29. So this works exactly as we would want it to. The return takes us out of the function, carrying with it the tip amount and the total. By the way, could you take these amounts and immediately manipulate them in your code further? Of course you could. Yeah, of course you could. So we could be taking these amounts and, writing them, manipulating them, and writing them into a new variable. So the, sky's the limit on your creativity here. It really is great that we have this return keyword so that our function can return to the surrounding code important data. You will notice the name of this lesson. It's the none keyword. And yeah, that's really, really important. None is a keyword. You see, this can be pretty confusing in Python. Let's take a look. To prove to you, first of all, that none is a keyword and not some type of a value like 0, watch this. If you go x is equal to none, notice it's highlighted in orange there, recognized as a keyword. So if we try and say x equals none plus 1, we're going to get an error. Yeah, and it says that there's an unsupported operand type, our little plus operator there, for none type and an integer. None is a key word. Now, we could say x is equal to none, and then we could perform like a test to see if x is equal to none, but that's the extent of it. And you might be wondering, okay, Anthony, well, why are you bringing this up here? Why is this coming up in our discussion of functions? Well, functions return none if there is nothing to return. Let's go ahead and prove that to you. So I'm going to go ahead and actually, I think I've got it open here. Yes, I do. Here is our fun little function that says, okay, we're going to take this value of n, and if n does not have a remainder, okay, so here's our modulus operator. So we're going to take our n and we're going to be dividing it by 2 and seeing if there is a remainder. So if there is, if this modulus calculation is equal to 0, we're going to return the value of true. So notice what we did. We're printing the results of this function if we give it the value of 2. What should that return? It should return the value of true. But what's going to happen when we ask for the value of 1, where we are not going to be equal to 0? Well, sure enough, if we print the result of this function, it's going to return the keyword none. Yeah, so none really is a keyword, and it is used to communicate that the function didn't return anything. So we're going to go ahead and run this and look at that. Sure enough, the responses are true, and then we get a response of none when the function truly has nothing to return to us. And that would be in this case right here. So none, yeah, it is a keyword. It might show up, as we've discussed, from the return of a function that has nothing to output to us. So now you know about this very interesting keyword inside of Python called none. Thanks for watching. In this video, we're going to discuss recursion. This is when a function calls itself. That's right. The function literally calls itself and recurses. Now, before we get into this, let's answer a question that you may have had, and that is, can we pass something like a list into our function? And the answer is, yeah, we could pass a list into the function, and we're going to want to iterate through that list most likely in our function. And so look at this. We define an iterative sum function here that's going to take some numbers, and it's going to start with a total of 0. And then for every one of those numbers, it's going to add that number to a running total and then return that total. So you can see in this example how, yes, a function could take a list, and then you're seeing how we could actually iterate through this list and return some kind of a value. Let's just play with this, make sure it works. So we'll go over here to our idle shell and we'll paste in this function definition, and then we'll call it. So iterative underscore sum, and then we are going to provide it a list, 10, 20, 30, for example. And what we would want to do is print this result, obviously, or we're not going to be very happy with running this function call. Alrighty. There we go. And look at that. It just does its job just like we want it to. Sure. Just iterate through this list of numbers that we have provided. And in this case, we're going to add them up. Okay, well, as you might guess, this example can be done with recursion. And if we introduce recursion into this equation, it's going to be a lot fewer lines of code. Yeah, it's a simpler way to do it. So let's check it out. Let's have the function call itself. I've got another example here for us, and it uses recursive function logic. Check this out. Here's our recursive sum of our numbers. And notice I say if not nums, then return 0. So we have a little built-in logic against there being absolutely nothing provided as far as numbers go. But then we're going to return the numbers added up. Yeah, notice we're using the first number, and then we're adding it to the next number, and we're doing the whole next number thing by calling the very function in the function. So we're calling the function in the function we're defining. Woo! This is getting real Matrix and bizarre, isn't it, right? No, not Matrix, Inception, right? A dream within a dream. Yay to all you Christopher Nolan fans out there. All right. So, and by the way, I should make clear that I'm a Christopher Nolan fan myself for most of his films. All right, so anyways, imagine this. We can call the function within the function. Yeah. And if I wasn't worried about the kind of error check there on what happens if there is, no value inside of our list, then this is all done with one line of code inside of the definition. So let's go ahead and just make sure this works. As you might guess, it's going to work just great. And then I want to conclude here, making sure you understand a caveat about these two approaches that we've looked at. So I'm going to print the recursive sum, and I will go ahead and provide a list just like before of 10, 20, 30. And we need to get all of our parentheses in place there, and you can see it does just what the previous code did. And by the way, the previous code, the iterative way we did it, if I provided nothing to this, an empty string, it would have returned the total is 0, just like this returns the total is 0. In fact, let's check that out real quick. Let me... Man, oh man, I could never get the command shortcut right. I apologize for all of you that have seen that a bazillion times in all of these episodes. Anyways, what are we going to do here? We're going to give it an empty list, and sure enough, it returns 0, just like our non-recursive, our iterative sum would have done. So, what's the deal? Why wouldn't we always just use a recursion like this? It works so easily and beautifully to get the job done. Well, one caveat I want to tell you about using recursion is because what's going on here is there's actually another list being created. This is creating a slice, isn't it? And adding it. So it's not like this is the most efficient thing for Python to be doing. There are limits to how deep the recursion can go and stuff like that. So just suffice it to say that there are limits on recursion in Python. So for massive lists, for instance, we might be feeding the application. Iteration is the way to go, but you can use recursion and enjoy it, especially if you have a super short list like we do. Yeah, so if the list is super short, the recursive approach is not going to cause a problem at all for Python. All right, those get into more advanced topics. As you might guess, the main thing I wanted you to take out of this video, two main things, was that, yeah, we can feed things like lists into our functions. And when it comes to stepping through those lists, we have two approaches. We can iterate or we can use recursion. Thanks. Well, time flies when you're having fun. It's our last video on user-defined functions. And we're getting pretty close to the end of our content, aren't we? Because we have one major topic left after this one, and that is exceptions in Python. Yes, so close to the end. It's amazing. All right, let's talk a little bit more about scopes in Python. I want to make sure you understand this, and we've got a couple of points to make that we haven't made so far about scopes, and we have a command we're going to share with you. It's called the global keyword, and you'll see why it's very important in a moment. And I want to bring this up with you because we're going to have at least one example in here of things not functioning like you might guess they would. And whenever that happens in Python, we want to make sure we provide guidance. Okay, but first up, let's check this out. We are defining a function called scope test, and notice inside of scope test, we're going to set x equal to 120. We're then going to call scope test, and I guess this is one of those examples where a lot of people would think, yeah, it's going to print 120. But what's going to happen here? Yeah, see, this variable is local to this function, so I think we're going to get an error message when we go to print x. Because even though we called the function, x out here is not defined. Yeah, this is internal inside of our scope definition. Let's go ahead and run this thing. And yep, we got an error. So one of the things that we remind ourselves here with this example is the fact that we can set a variable inside of the function, but that is going to be private to that function, as we saw in this case. All right, so let's take a look at another example. Let's go the other direction, if you will. So let me show you my second example here. In this example, as you can see, we are going to define a scope test2, and we're going to print the variable value is, and then print the value of this my underscore variable. Notice I'm setting it to 200 in my code. I'm then calling that function, and then I'm also going to print the value of my variable. So notice what's happening here. We're trying to feed a value into the function. Will that work? Yeah. So what do we expect to see here? Well, if we can indeed feed this into the function, we should see the variable value is, and we should have 200 here. And then when we print the variable, it should print to that value of 200. All right, well, let's go ahead and run this and see what happens. And look at that. It worked just fine. So as we can see from this second example, yeah, we can set a variable to some value. We can run a function, and the function can work with that value. And then, of course, we do our just printing the value outside of the function works as well, of course. All right, let's take a look at another example. And this one is our test 3 case here. Notice in this example, it's just like the previous, but this time we're doing something interesting. Inside of the function, we're setting the variable's value to 400. Let's go ahead and run this and see what happens. Yeah, look at this. So inside the function, it's now 400, but outside the function, it's now the 200. So notice it would have just accepted this value, but the value's been overridden. And we actually kind of covered this concept before. This is when I was talking to you about one value kind of shadowing another, is how this is referred to. All right, but now let me show you something that we can do to control this, because you would certainly want to be able to control this. So what I'm going to do is bring up our fourth case here and check this out. Here I say, all right, the my variable value is a global variable. So now what we're going to be doing is when we set it to the 200 here, and then we run this function, the function is going to pick up that external variable, and it's going to reset it, if you will, to 400. So now we're going to get the my variable value at 400 in both places. Let's run it, and that's exactly what happens. So notice we have control over this whole concept of variable scope thanks to the global keyword. Yeah, the global keyword here is saying, hey, look, we want the global. Well, it's unfortunate, but it's inevitable. There's going to be errors with our Python applications. Yes, it's going to happen, folks. What'll happen is perhaps we have an error in the program. You know, we've done something incorrectly, or what's frequently happening, you've probably seen it already, is you're going to get unexpected input from a user of the application. Let's take a look at this, and let's begin our discussion of what we call exception handling in Python. So check this out. I've got this simple little, we're going to get a number from our user. Notice we have this input function that we are using, asking them for a number. We're typecasting it to an integer, and we're storing that in the my number. Well, sure enough, this can cause problems if the user does something crazy. So let's go ahead and run this thing, and let's do something crazy like put my name in. So notice what happens. This throws an exception or error in Python. Now, every single line of this turns out to be valuable information for us as the developer of the app, but for an end user, this is all not going to make any sense. I mean, what'll typically happen is they start reading here at the top and then they quickly bail because, you know, they're like, this isn't making any sense. I don't know what a traceback is. Most recent call last. They're, you know, the error message here for us might make sense. The actual error itself in kind of plain English, invalid literal for integer with base 10, and then they show the Anthony string. But again, for an end user, that might not make much sense. By the way, I do want to draw your attention to right here. Notice this is a value error. That's the specific type of error or exception that was raised by this problem. Okay, a value error type. We'll talk to you in the next video a lot more about these different types of exceptions that we can have in Python. But right now, we're going to solve this nightmare of a situation where gobbledygook is the technical term, is returned to our end user and freaks them out. We never want that to happen. So let's fix that right now. Watch how easy this is going to be to fix. I'm going to come up here and I am going to issue or create a try block. And now I'm going to indent what we are going to be doing under that try block. That is what we were doing a moment ago, and that's getting a number from our end user. But now what we're going to add to our little application here is also the except block. And this is going to print something much more friendly. You did, or maybe something even like super friendly, please check your input. Okay, so asking the end user, hey, I think you did something wrong. And notice this is only going to execute if there is some type of an error that occurs in the try block. So you gotta love it, the try except syntax that we can use inside of Python. Let's go ahead and save this thing and let's run this thing. And once again, I'll put in my name and nice. No more big, ugly, frightening error for the end user. A more elegant, please check your input. By the way, it's always great to make sure that your program does work, right? So let's go ahead and just run this one more time, giving it a number and ensuring that, okay, yeah, there is no further error that we have to worry about in our application. Notice what I was just doing there, right, was, checking multiple cases. And I know you've been doing this throughout all of your practice and your work in Python, and that's terrific. Keep it up. This is good practice to get into. We want error-free software whenever possible that we create. And notice in this lesson, we saw a nice kind of elegant way we can try things. And if there is any error, handle them with our nice except block. Well, thanks so much. As I promised, in the next lesson, let's learn a bit more about these types of exceptions we can get in Python. And then in the lesson after that, we'll really step it up with the try except capabilities of Python. So think about one of the majorly important jobs that our Python developers had to do. Yeah, think about developing the Python programming language and needing to handle all these different potential errors that could occur. Yeah, what the designers of this programming language did was they created this hierarchy of potential errors, of potential exceptions. So notice there's a base exception, and then from this we can derive an exception group, and underneath that we have arithmetic errors that could occur, like floating point errors or overflow or zero division errors. So notice there's this hierarchy. What about things that could happen with the operating system? Well, if you go down to the bottom of this or near the bottom of this hierarchy, you'll see the OS error node. And then from there, you can see like the various connection errors that you might get into. So certainly a robust part of how Python works for us as a programming language. And keep in mind that certain of these, are kind of so famous that we should be familiar with them. We've probably seen some of these as we've been doing the various assignments that we've had for you in this course. So dividing by 0. And don't forget, multiple different ways we can divide in Python. We might be doing kind of standard division, or we might be looking for the whole number or the remainder that exists during division. All of these would throw this error if we were trying to divide by 0. Something else we've probably seen, sure, the value error, where we need to be providing an integer or a float and we're not providing that value. Another common error, the type error. Well, actually, this is less common than the value error, but notice what's happening here. We create this little short list, and then I go to reference that short list, and I'm using 0.5 as the index reference for the list, and that is not going to work. That's going to throw a type error. Yeah, and Python will say to us, look, you can't use that value for an index. Another error is the attribute error. So here someone is going to that short list and trying to reference the method called depend. I think they meant append, not depend. Yeah. So anyways, shortlist.depend3, sure enough, Python's going to really say to us, nope, can't do it. There is no type of method called depend. This is a classic attribute error. And finally, our wonderful syntax errors. And the important thing to remember about these is a lot of times they're not going to be found until the code is actually executed. So that's one of the challenges with an interpreted language like we have here with Python. If we are forced to compile our code, we'll definitely catch the error at compile time. But with Python, you can have your syntax error and it's not going to be discovered until that code is actually run. So lots of different potential errors or exceptions that we can have in Python. As we've seen, they follow a hierarchy, and I didn't initially plan on showing this to you, but it is well worth showing to you. Remember, all of these are going to be documented for us. So when we go into the Python documentation, we can go to, we can start at the beginner's guide, for instance. Actually, let's not start at the beginner's guide. Let's go into the language reference. Inside of here, of course, we're going to find our documentation on the exceptions. And let's see. Actually, you know what? Let's just do this. Site. I'm going to search the site, python.org, and I'm going to search it for exceptions. All right, here we go. So the built-in exceptions of Python. So here is your documentation on what we just covered. For instance, here is our exception hierarchy in full, if you want to look at that, as opposed to just the snippet that I gave you. And since this document is so massive, because there are so many potential exceptions that we can run into, one of the things you can do is just like a Control F to search on the page. And I could say like give me more information on syntax error. And it's, of course, going to show us all of the information involving syntax error that we might need. What was another one that we looked at? How about the type error? So we can go ahead and find the exact documentation for a specific exception with ease up in the Python docs. Well, thanks so much for joining me in this video where we went a little farther on this topic of exceptions in Python. Well, folks, this is a milestone video in our certified entry-level Python programmer journey. This is the last official technical content piece. Yeah. So we're going to follow this video up with some review of this major section of content that we just finished. I will talk to you about the exam and what it's like and getting fully prepared for that. But yeah, this is our last video of official content, and I've got more great news for you. It's very, very simple. Now that you understand the different types of exceptions that we can get inside of Python, I need to show you something that you're really going to enjoy, and that is, notice with your try except, you can do specific types of exceptions as a parameter in your except clause. So isn't this great? So notice I just do this silly little example where we get a number from the end user. It needs to be an integer. Then we do something potentially dangerous. We take that number and we divide it into 100. Notice if they give us a non-number value, we're now going to print out a customized message, but just on that specific exception type. Just like if there's a zero division error, we're going to give them a custom message type there. Notice this now, without any specified exception, this must come at the end. Okay, that's the first thing I want you to know about this. That could certainly be certification relevant. This now just default except clause is what we like to call this, must come at the end and would be what would be printed if something else went wrong, notice. So if it's not one of these first two, well, this will trigger. Okay, so that it becomes our default exception. And please, I'll state it one more time, that would need to come at the end to work in our Python logic. All right, notice I print when the end of the program actually gets reached. So what would be a great way for us to test this? Well, let's just go ahead and force a division by zero error, why don't we? The kind of middle case right here. All right, so I'm going to go ahead and run this module. And please input a number. I'm going to input the really terrible number of 0 for this silly little program. And yep, sure enough, there was a zero division type of error and the end of the program was reached. So we have this great capability. We can go ahead and specify specific exception code based on the exception that was raised. Great stuff. And at the end of this list of exceptions, you can, if you like, and it's a common thing that we do in Python, to do a final default except syntax for anything that might not have been caught in the earlier exception code. Well, thanks so much for watching. And as I said, you can look forward to some review videos coming up now for the major section of content. You know what time it is. It's time to review section 4. That's right, the fourth and final section of our certified entry-level Python programmer course. Let's get going. Review question 1. Remember those functions. We learned about defining custom or user-defined functions in this portion of our course. So here we have one that I wanted to show you because this is what can happen to us sometimes in certification. We can begin to question ourselves on a really easy question. Yeah, define greet, and a name will be the parameter, return hello plus name, and then we print greet Alice. What is the output we're going to get? Are we going to get hello, hello Alice, Are we going to get name, or are we going to get greet Alice? Well, the answer, of course, is hello, Alice. That's right. So, sometimes you are going to get a very straightforward question like this in a certification exam environment. I don't care if it's from the Python Institute or not. I'm saying this is kind of a lesson we can learn that, sometimes it's going to be just a straightforward question like this to see if you know the basics of defining a function. So a lot of times this could really freak us out, and we're looking for some kind of a catch when there is no catch. It's just a straightforward, pretty easy question. All right, next up, how about this? Define multiply, and then we have A as a parameter, B with a default parameter setting, and then return A times B. Wow, what an amazing function, right? So print multiply with a value of 3, what's going to happen? Well, no problem, right? The 3 is the value for A. We don't have to specify a value for B. There is a default there. So the output will be 6. Yeah. Again, no trick here. As long as you know about how defaults work, default parameter values, there is no trick here. Yep, we're not going to get an error back. We're going to get the value of 6 back. All right, how about question 3? Notice what I did in this question. I removed the highlighting, the colored text. That is a benefit to us, and we don't want to assume we're going to get colorization in an exam environment, so let's get used to not having those handy colors. Does it make things a little more difficult? Sure, it does, and that may be a very reason why we don't get the colorization of our code. But anyways, here we go. X equals 10, okay. Define change, X equals 5, print X, and then we call that function, and then we print X. This would be very tricky, I would think, if you had not taken this course. But hopefully, with you taking this course, you look at this and you realize, oh my gosh, this is easy. The right answer is going to be 5, 10. Right, and that's because of variable scoping, as we discussed. X is set equal to 10, and that's just fine. Within our function, X is set equal to 5, and that ends up being printed as the value that we call first from the function of change, and then we print X, and that's the global variable X, which has that value of 10. So notice here we are seeing the shadowing of a variable. We see that 5 shadows out the variable value of 10. And then when we call that value of X later on, it's going to have retained its value. So yeah, this is a great look at scoping as we discussed with the functions that we work with. All right, finally, we have this review question for you. We define a function called safe divide, taking A and B parameters. We then have a try block, which says we're going to create a variable called result from A being divided by B. We then have an except block, which is for zero division error, which is going to return a result of none. And then finally, we return the result. So what is going to happen here if we do print safe divide 10, 0? What's the output? Are we going to get 0? Are we going to get none? Are we going to get an error? Or are we going to get the value of 10? Well, look at this. We are going to get a zero division error, and the results of that, or rather the result of that error, is not going to be the error message. Yeah, sure, it's going to return the value of none. One of the interesting things about this code too is notice things stop at the exception block. Yeah, because we do have a division by error, zero division error here, then none is the result. We never get to the return result code. Well, great job, everyone, in this review. This, as you know, was not a massive section of content with our functions and our exceptions. So, yeah, a nice, concise review. And you guessed it, in the next video, I'm going to go ahead and give you an assignment involving these last two major topics. Well, look at this. It's our Section 4 assignment. Yes, and you are not going to be surprised. Sure, with two big topics. So our assignment will incorporate those two big topics of Section 4. So you are going to ask your end user to enter two numbers. You're going to use a try except block to catch any errors if they enter something that's not a number. So you're going to be matching on value error. Okay. Now, also print a friendly message if any other error occurs. Now, if you don't know how to approach this, just go back and check out the videos that we did on exceptions, particularly those that involve try and except from that point forward. Now, notice you're going to create and use three functions here. One function's going to add the two numbers. The other function's going to subtract the two numbers. And then finally, a function to multiply the two numbers. After calling all three functions, go ahead and print the results. All right, folks, have fun with this one, and you know what's going to take place. I'll be joining you in the next video where we will walk through my, potential solution, one of many. Thanks. One to the solution of our Section 4 assignment. And what was that assignment? Well, as you might remember, we needed to enter two numbers and then do try except block to catch any errors. Particularly errors that involve value error. And then we also need a friendly message if any other error occurs. You now recognize that, of course, as the default except block that we can have. And we taught you that. Yep, as far as the functions go, that's going to be easy. It's a function to add two numbers, subtract, or multiply, and then we need to print the results. As you know, there's lots of potential solutions, so don't freak out if your solution does not match mine exactly. You know that by now. Notice what I did. I went in and just defined an add, a subtract, and a multiply. Each will involve the two parameters. One will return a plus b, one will return a minus b, and one will return a times b. I print a message. Welcome to my super safe calculator. Why is it safe? Well, one reason, we don't have a division by zero possibility here, do we? No, we're not dividing at all. So then I have a try block, and we're going to grab numbers from our end user of the application. Please remember, here we can see typecasting. So we want a number, and we know the input function will default to a string. So we put that inside of a float typecasting type maneuver. Please, this is very important for you to know. Remember, this was covered long ago together in our Python course, but a nice review there of forcing a float for the number values. All right, now notice what I'm going to do. Right in that try block, I'm going to, notice, skip a space and then print addition result. And I'm going to take those numbers that we received and stick them into the add function. Then we'll take those numbers and stick them into the subtract function and then the multiply function. Notice, if there is a value error, we should print, oops, that wasn't a number, please try again. And if there's any other error, then we need to print something strange happened, please try again. So this was my solution. And I gotta tell you, one of the trickiest things about this for me was, solving my own assignment was, how in the world am I going to test this other error? Yeah, it can be tricky to figure that out. Let me show you what I did. So first of all, let's make sure this thing works. Welcome to my super safe calculator. Enter the first number, how about 10? Enter the second number, how about 12? And look at that, it works great. Adding them gives us 22, subtracting gives us -2, and multiplication gives us 120. Now, the other thing we would want to do, of course, is test for the value problem. That's easy to test for. So I'm going to run this thing again, and I'm going to say Anthony for the first number, and sure enough, right away it says, whoa, that wasn't a number. So that triggered the value error that we have for a except syntax in our application. But again, as I said, what gets much trickier and was the trickiest thing for me is how do you create another error that isn't a value error? And one thing you can do, or one thing I did at least, is you go ahead and do some type of strange unexpected input. For instance, Control C. Yeah, Control C when it asks you for the first number. Control C is going to trigger like some type of unexpected input error, something outside the scope of a value error. And excellent that that works that way, because we do get to try that default except syntax of something strange happened. So you may have approached this very differently. And you also know by now that you can easily build on these. Yeah, so if you want to go farther into extra credit world, right, by all means do that. Yeah, add in the division function and do an except block that would check for division by 0 problems. So have fun with this and continue to use these exercises and assignments to really just build upon what you're able to creatively put together from an entry-level Python perspective. I'll see you in the next video. In that next video, by the way, we need to talk about your exam. Yeah, the exam process. I hope to see you there. Well, we have reached that time where we need to focus on the exam that some of you are going to be taking to achieve the Certified Entry-Level Python Programmer Cert. So you're going to head on over to the pythoninstitute.org site. And as you might guess, you can pop up to the certifications menu and you can go to the PCEP entry level certification. And if you check out this page, scroll down because you're going to get the exam details. So notice you're going to be taking the PCEP 3002 exam. That's what we have prepared you for. It is a 40-minute exam. And there's an NDA tutorial portion that takes 5 minutes. So you're talking 45 minutes here, and there's 30 questions. Notice it's single and multiple select questions, drag and drop, gap fill, sort, code fill, code insertion, interactive, and scenario-based. And now you might be going, oh my gosh, I'm getting nervous about all these weird sounding question types, and there's only 30 questions, and I have to get a 70%. And, what are those going to be like? And obviously you could get a little nervous reading this, but have no fear, because look at this. For just $95, that's right, 95 US dollars, you can purchase the exam, a retake of the exam, should you not pass on the first try, and a full practice test. Yeah, so if you look at these different prices, that's the way to go. Yes, spend, in my opinion, the $95 if you can, and go ahead and get your exam, a retake, and a practice test. So you can go ahead and purchase that, and where everything's going to be stored, for instance, your practice test is going to be in this Test Now location. So I've logged in over there at Test Now after purchasing. And as you can see, there's this home tab it'll bring you to when you log in, and notice you will have purchased a practice test as I suggested that you do, right? So you're going to come in here and select the practice test, and you have, I think it's like 60 launches of the practice test. and you can go ahead and launch it. And notice it's going to do a great job of going over the exam specs with you, which we've already talked about. But then notice it gets right into both review materials for you and practice question materials, and then a full-blown practice test. So this is really great, really worth it. If you look at exam block 1, for instance, I'll go ahead and launch this. It goes through and does a nice review, as I said, of the major topics. So look at this, a nice concise review of everything that you and I talked about and went through in class together. There may be some things we didn't mention in this review, okay? And that's great. So you'll have the context. It'll be easy for you to completely comprehend any new information that I didn't share with you. So that's just great. So you'll go through the review, and then once you get to the end of the review, as you might guess, we get to an exam block. So notice there's going to be 18 questions here. We need to get at least, or there's 460 total points to score. And notice they grade everything around the passing score that you will see in the actual exam. So notice we just start these 18 practice questions. A program which is used to transform a source file into an executable binary file is called an interpreter, an IDE, a linker, or a compiler. Well, if you have to take source files and you have to transform them into an executable binary, this is a compiler's job. Yeah, that's a compiler that you need. So anyways, you get the idea. You're going to go through these 18 questions. It's going to grade you. Let's see if I can break out of here. Yes, I can. Great. So, and don't forget, you're going to be reviewing on these sections and taking these little quizzes at the end. But don't forget, you also have a practice test as part of that study, and then a final practice test. So you have no shortage here of practice questions to help guide you through your actual exam experience. Well worth the money. I'm sure you agree. Yeah, we are buying the exam itself, these materials, and a retake that I doubt we're going to need after going through these materials. And all of that is less than $100 US. Now, just to prepare you, I don't want anyone to go into shock later on, because as you know, I'm going to be creating the next level of certification here with the Python Institute materials. And I just want you to know that the price does start going up. Let's see, let me go into the shop and show you this real quick. So we are talking about this PCEP level of certification. But if you come in here and let's see, where would I do it? Okay, right here, the filter type. Let me turn that off so we start seeing more stuff here. I just want to see what I'm saying. The prices start going up. Yeah, look at this. So here's the exam for the associate level Python programmer, the next level that we'll be doing. And notice this exam price goes up considerably. The prices don't stay low like this for long, but we might as well take advantage of it while it's there. And I'm glad I showed you the shop here. Notice the key to working with their store is using these category and type filters over on the left. Yeah, you're definitely going to want to do that. If you watch this far, I'm thinking you are interested in achieving. Some of you have been waiting quite some time for this video. I needed to take a bit of a break. I also needed to, decide if I would be teaching the next level of the Python programmer curriculum. And I've decided, yes, it is a go. So we are going to begin the creation of, and I hope you'll be joining me for, the Certified Associate Level Python Programmer. That's the PCEP certification from our Python Institute. And I thought I would go ahead and just give you a quick look at what we are going to be covering in those domains. Notice when you look at these domains, there's a lot of subjects that we have already covered together. We've talked about modules, we've talked about exceptions, strings, list comprehensions, input-output. Many of these topics we are going to be delving further into in PCEP. Then notice things like packages and object-oriented programming. These are going to be new subjects for us. And really call your attention to object-oriented programming having 12 exam items and making up the vast majority, the largest topic area, 34% on OOP, object-oriented programming, an exciting part of the PCEP course. I really hope you'll be joining me for this next step, but if you are not, I just wanted to thank you right now for taking this entry-level Python course with me. If you're still here listening to my voice, it means you've watched 75 videos of training, and I cannot thank you enough for that dedication. Congratulations, and I hope to see you in our upcoming PCEP course. Thanks for watching.